is structured into different sections, and each section contains lesson videos focused on the topic of the section or module. At the end of each section, there is a video exercise with answer, and it is followed by quizzes related to the section. The lesson files containing drawings and resources used in the video are available for download with every lesson. And if you want to download all the lesson files at once, then download it from this video. The course contains video lectures with practical real life examples from industrial drawings. And the video lessons are made to facilitate learners to follow along the video and practice the lessons on their own. New features of AutoCAD 2018 software are also included in the course, and they are mentioned in the respective video lesson. Now, if you ever feel stuck with the topic, or if you have any question related to any of the topic of this course, then let me know and I'll try to answer it as soon as possible. So let's get started with the first module. When you start AutoCAD, you'll reach this start screen on which you can see this get started column, on which we have some frequently accessible tools, like we can open the files, open a sheet set, we can get more templates online, or we can explore some sample drawings. Also, we can open a drawing using some predefined templates from this drop down list, or we can directly use this start drawing box to open the drawing with the default template. On this column, you'll see some of the recently opened drawings, and you can change the preview of these drawings using these small tabs. So you can change it to big thumbnails, or you can change it to the list view like this. You can also pin some of these drawings for their frequent access. For example, you can pin this 1.2 drawing. Also, let's pin this 1.4 drawing. So now, even when you open more drawings, these two drawings will always remain in the list and on the top of this list also. Also, we have some notifications related to our drawing. And here I'm connected to my A360 account that you can see here, my name and the email ID. You can log in if you're not connected here, and also you can see the ID at this point here. So now let's click on this push pin to remove it from our drawings, and now let's select this learn tab. And now we have some videos which can be used for learning about the new features or some of the content related to the AutoCAD. Also, we have here the latest video from Autodesk, and also some learning tips and other online resources that you can access. So I'll get back to this create tab, and I'll start the drawing from this start drawing option. And here we are in the main drawing area. So now this main window of AutoCAD is divided into a couple of parts. Here we have this ribbon panel, and this ribbon panel is divided into different tabs. Here we have this home tab, the insert tab, annotate, parametric, and so on. Also, these tabs are divided into different panels. We have the draw panel, modify, annotation, and other panels. We can expand these panels to access additional tools, and also you can click on this push pin to make these panels sticky here. So even after removing the cursor, these panels will remain expanded, and if you select this push pin option again, when you remove the cursor, the panels will collapse. You can also move these panels, so you can click anywhere in this panel here and drag it outside if you want to move it, just like this. And we don't have the draw panel here, now we have it here. And if you want to take it back to the home tab, just click on this small icon that will return it to its rightful place. Currently, all of the panels are not visible in the drawing area, and it will depend upon the resolution of your monitor. And if you want to show or hide some of the panels, you can simply right click on this blank area, and from here you can select the panels. So go to this show panels and select the panels which are not checked. In this case, we have all the panels checked. So let's say that we want to hide utilities panel, so I'll click on this utilities, and now we don't have that panel here. Now I'll go to this blank side again, right click, select show panels, select the utilities, and now we have the utilities panel. In a similar way, you can also bring or hide tabs here. For example, we have home, insert, annotate, parametric, but we don't have 3D tools or visualize. So let's click on this visualize, and now we have this visualize tab here. In order to hide this, right click on the empty space on any tab and select this visualize option again. And now we don't have it here. We also have here command line, and all the commands that you will enter will appear here. You can expand this command line by clicking on the boundary of this command line and expanding it like this. So it will keep a record of all the commands that you will enter, and you can always collapse it to its original position like this. You can hide this command just by clicking on this close icon, and if you want to bring it back, simply press Ctrl 9 key to bring it back. You can also hide it using the Ctrl 9 key. So I'll bring it back again in the drawing area. We can also hide multiple elements from the drawing area. So here we have this file tab, we have here the model tab, and also these layout tabs. So you can hide these tabs. Also we have here this navigation panel, and we have the view cube. So in order to remove or bring these visual elements, you can go to the view tab, and from here select the corresponding option. For example, we have here file tabs. Just uncheck this option to remove the file tabs. Also, if you want to remove the layout tabs which are here, click on this layout tabs, and we don't have that layout tab anymore. We can bring it back by clicking on these options. Similarly, you can click on the UCS icon, view cube, or navigation bar to toggle their visibility. For example, here we don't have the navigation bar anymore, and we also don't have the view cube. Now after turning this off, and we can turn off UCS also. So let's click on these icons again to bring them back in the drawing area. On the top left, we have this quick access toolbar on which we can place some of the tools which are frequently accessed. So we have the save as, print, undo, redo, and also the new and open. In case you want to add more tools to this, you can click on this down pointing arrow and select the corresponding option from this list. So let's say that we want to add this properties or the workspace option. So you can click on this workspace, and here we have it now. You can also add layers option from this AutoCAD 2018 version onwards. So this is a new addition in the AutoCAD 2018 version. You can add the layer drop down now on the quick access toolbar. So I'll just turn off this layer as well as the workspace. You can also search for commands from this application menu. So click on this application menu or the application button, and here you'll see a field. Now let's say that you want to locate a command on the UI of this AutoCAD. So for that you just need to type its name. So I'll type the name of the circle command, and now here we have the results. So in the first result we have it on home tab. As you can see here, the circle command is on home tab, draw panel, and the circle flyout. So let's check it. So here we have home tab, draw panel, and circle flyout, and here we have the result. So you can locate any command from AutoCAD on its UI or the user interface easily using that search field. And if you want to know more about any command, you can use this help field also. So from this help you can access more information about any command in AutoCAD, but you need to be connected to the internet in order to access this help. Or you can also download the help file for offline use using this drop down. So click on this drop down and select this download offline help and install the offline help files. So this was all about the user interface of AutoCAD. In the next video I'll tell you about the navigation tools in AutoCAD. So now let's have a look at some of the navigation tools available in AutoCAD. So in AutoCAD you need to use a 3-button mouse with left click, right click, and a scroll wheel for accessing the navigation tools. And in order to select or in order to activate any command, you need to select it from the corresponding tab and panel. So simply go to that command and left click, and the command will now be activated. And once the command is active, you'll notice that its name and also the instruction will be visible on the command line, and also the cursor will change into this point selection cursor or into a pick box which is similar to this. So when you select the corresponding command, it will return to this either pick box or a point selection cursor, and also the name of command will be active. In order to exit this, simply press the escape key. You can press escape multiple times also if you want, so that will not make any change to the drawing. And now in order to zoom in and zoom out from the drawing, you simply need to rotate the mouse wheel. So here we have these three objects. Let's say that we want to zoom into this area of the drawing on the lower left of this rectangle. For that, simply bring your cursor to the lower left of this rectangle and now rotate the mouse wheel. And when you rotate the mouse wheel, it will zoom in, and when you rotate it in the opposite side, it will zoom out. And the center of zoom will be the point where you put your cursor. So in this case, if I move my cursor to the top of this triangle, it will take this point as the center of zoom, and we can zoom in and zoom out like this. In order to pan this drawing or move this drawing in the drawing area, simply press and hold the mouse key and the cursor will change into this hand, and now you can move it in the drawing area like this. You can also access these navigation tools directly from the navigation bar. So here we have this pan tool. Simply select it. Now you'll be able to move it or pan it in the drawing. And in order to use the zoom tools, simply select this small arrow right under the zoom extents tool, and we have multiple options for zoom. So you can select any of these options. For example, in this case, the zoom extents is selected as default. So if you select zoom extents, the drawing will fit completely in the area provided. So wherever our drawing is, it hardly matters. When you select the zoom extent, it will fit in provided space. Also, we have some other options like this zoom window, which can be used for zooming on a particular object. For example, in this case, let's say that we want to zoom into this circle. Simply make a window around the circle and the circle will be brought into perspective. It will be zoomed in the current workspace. We also have some other options like zoom previous, that will return to the previous state of zoom. And also one of the option here, this zoom object. So select the zoom object, click on the object, and that object will be brought in the complete area of the drawing. In a similar way, you can also access all of these options according to your requirement or the requirement of a specific drawing. We can also access the 3D orbit tool, and using the 3D orbit tool you can see this drawing from X, Y and Z axis. So currently we are able to see this drawing from X and Y axis or from the top view only, that you can see here with the top view. But in order to see it from the 3 axis, or if you want to see the height of this drawing as well, simply go to this orbit tool from the navigation bar, select the orbit tool, and now orbit your drawing just like this. And now you'll notice that the triangle is actually a 3D shape with a certain height here also. So you can orbit the drawing to see it. We also have another orbit option, which is free orbit, that is useful for viewing our drawing more freely in different axes, and you learn about these tools in much better way in our 3D course. So let's press escape key, and now if you want to access the same tool using the mouse, you can do that as well. Simply press and hold shift key, then press the mouse wheel, and now instead of pan, that will convert it into this orbit tool, and now you can orbit the drawing in the free space. In order to return back to the original condition, simply click on the top of this view cube, and here we have it, the default configuration. Although the angle is not correct, that we can also correct using this small arrow here. So in this way we can navigate in our AutoCAD drawings. AutoCAD uses the very popular Cartesian coordinate system for making the drawings, and in Cartesian coordinate system we have x, y and z axis. Here we have this x axis represented with the red line, the y axis represented with the green line, and we also have a z axis which we cannot see because we are in the 2D plane. The z axis is pointing outwards from the screen right now. Now all the points in this Cartesian system are measured from this point, which is the intersection of x and y axis, or the intersection of x, y and z axis in 3D, and that point is taken as 0, 0, 0, and each 0 represents the x, y and z axis respectively. Now if you talk about 2D coordinate system, we only have x and y axis. So the first coordinate point will be the x axis and the second coordinate point will be y axis as shown here. Now if you could see the grids in this drawing area, you'll notice that I have divided this complete block into 10 grids in horizontal direction. So we have these 10 grids in the horizontal and 10 in vertical direction, and the size of each block of this grid is 1 by 1 unit. So the length and width of this block is 1 unit in each direction, and the size of this big block is 10 units in length and 10 units in width or height. Now, in order to find the coordinate of any point with respect to the origin, all we have to do is find out its x and y values. So let's say that we want to find out the coordinates of this point. So all we need to do is count the number of x blocks and then number of y blocks. So in this case we have number of x blocks as 10. So after 10 blocks we can make a line that will intersect this point. Now after 10 blocks along y direction, if we make a line, it will also intersect the same point. So the coordinate of this point is x10 y10, and that will be 10 comma 10. Now similarly in this case we have this point, and the coordinates of this point will be 10 in x-axis, because after 10 blocks along x-axis we have this point here, and the y coordinate of this point will be 4, because after 4 blocks we have this point. So the coordinate value of this point will be 10 comma 4. Now that's the simple Cartesian coordinate system. Now if you want to use the polar coordinate system, then you can do that as well, and I've made a geometry here. Now this line starts from the origin and the length of this line is 10 units. This line is also inclined to an angle of 30 degrees. So if you don't want to specify the end point of this line in terms of Cartesian coordinate system, and you want to specify it in other units, which is the polar coordinate system, then you need to represent the values as the length of line and the angle included here. So that will be the length, which is 10 units, and then the angle, which is 30. So this will be the value in polar coordinate system. So now we can represent this endpoint in terms of polar coordinates using this coordinate value, and we'll learn about this later on in this complete course. So now here we have a completely blank drawing area. So in the current drawing area we don't know the extent of dimensions. For example, if you make a line of length 10 units in this drawing area, we don't know how long it will be. So in order to set that limit, we can use the limits command. So type limits and press enter. So now this will prompt you to specify the lower left corner, which is 0 comma 0 in this case. So simply type 0 comma 0, or you can directly press enter, because the values in this angle bracket is the default value that will be accepted if you directly press enter. So you can also directly press enter. So I'll now press enter, and now you'll notice the upper right corner value, and the upper right corner value is simply the values of coordinate on this corner. So you can see that the lower left corner values are 0 comma 0 and the upper right corner values are 420 comma 297. That means the length of this screen should be 420 units and the height should be 297 units, whatever the unit of current drawing is. But that's not always the case. In this case, the height is obviously 297, but depending upon the aspect ratio or the screen resolution or the size of screen, your length may differ. So obviously we know that the length of upper right corner is 297. So if you want to accept the value, simply press enter, and if you want to change these values, you can do so by entering the new value. So I'll type 100 comma 60 and now press enter. So now we know that the height should be equal to 60 unit, and depending upon that height the length will adjust automatically. But before checking that, we need to ensure that the settings are applied, and the settings can be applied by using zoom all command. So type Z for zoom, press enter, and then type A and press enter. Now the settings are applied. So let's make a simple line. I'll go to this line command, and we'll learn about this line command later on in the next module. And now click at a point somewhere close to this bottom point, and now make a straight line of length 60 units and press enter, and you'll notice that the length of this line is equal to 60 units, which we have already set in the limits. So now we know the limit of this current screen, which is 60 by almost 100 or 120. Now we also need to know the unit of the current drawing, and for that you can check the display unit by clicking this application button, selecting the drawing utilities, and from here select the units. So now you can see the display unit or the units which will be displayed in the drawing area from this window. So right now the length has decimal type here, which you can change to architectural. If you want to see it in feet and inches, you can see the sample output here, and I'll change it to decimal again. Now here we have the precision. So currently the precision is set to 4 decimal places. You can change it to 2, 3, or whatever value you want. So this will not change the actual precision, but it will only change the precision of the values which are displayed on the screen. So I'm changing the precision to 2 places, and now the insertion scale, which will be the scale of external geometries which are inserted. It's set to mm. You can change it to any of these units, whichever you want. So you can change it to inches, you can change it to feet or something else. So I'll keep it at mm. And here we have the angle type, which is set to decimal degrees. You can also change it to degree, minute, second, grades, radians, or surveyor units. And here also we have the precision, which I'll change to 2 decimal places. If you want to reverse the direction of positive angle, you can click on this clockwise checkbox. So the anti-clockwise direction is generally taken as positive in AutoCAD, but if you want to reverse that, you can click on this checkbox to make clockwise direction as positive. So I'll keep it unchecked, and now I'll click on OK. So we have set the display unit for this drawing as well. We have also set the limits. In the next lesson, we will learn about saving these settings as a template file. In the previous lesson, we have changed the limits of our current drawing or the display area, and also we have applied the display unit format for our drawing. Now these settings should be saved as a template, because we obviously don't want to make these settings every time we start a new drawing. So you can save these settings as a template, and you can open that template to create the new drawing. So in order to save this current setting as a template, go to this application button and now go to save as and select drawing template option. So this will save our drawing as a DWT file or the drawing template file, and here we have some predefined templates here in this list, and you can see the location of template here. So it's located deep within the Autodesk installation directory. So if you want to save it in the same template folder or the directory, you can do that as well, or if you want to specify a new location, you can change it. So I'll change it to desktop here, and here on the desktop I'll save it with the name sample template. And now you'll notice here that the file is now saved as a DWT file or the file with DWT extension. Now click on save and click on OK. Here we don't need to specify any description. Click on OK, and now the drawing is saved as a template. So let's now close this tab, and if you want to open the drawing with the saved template, you can simply go to this open files, or you can also go to this open files and you can open the template, or you can also select the predefined templates from this list of templates, so which we obviously don't want. We don't want the predefined templates, we want the template which we have made. So click on open files, go to the desktop, change the format to DWT, and here on desktop we have the sample template, and now click on open, and we have the template here. Now you can start making a drawing here, and all the previous settings are completely restored in this template. So now we have completed the first module. Let's look at our first question, which is related to the topics which we have covered in this module. So we need to make a template in AutoCAD with name my template, and that template should have architectural unit display format. Also that format should be at a precision of 1/4 of an inch. Also ensure that inches is selected as the unit, and the limit of this template should be set at 50 units in vertical direction. So these are different points that you need to keep in mind. Now let's get back to AutoCAD. So when you launch AutoCAD, you'll reach this zero screen, and here in this zero screen you need to launch it with the default template. So I'll click on start drawing, and here we have it, the default template. Now let's check the unit. So I'll type dash DWG units, and press enter. Now here you can see that on command line we have 1 within angle brackets and also 1 is for inches. So we have this unit perfectly set, but in case the unit is different here, if it is set to 2, 3, 4 or any other value, then change it to 1 and press enter and keep rest of the settings at their default. Now I'll simply press escape here and now type UN for units and press enter. So here we need to make some changes. The first change will be the type of display format, which is set to decimal. We need to change it to architectural, and also the precision should be 1/4 of an inch, which is here. The insertion scale should also be set to inches, and we'll leave rest of the options. I'll click on OK. Now we need to make the third setting, and in case of third setting we were required to set the limits in vertical direction to 50 units. So I'll type limits and press enter. Now I'll select lower left corner as 0, 0 as specified, so I'll simply press enter, and the upper right corner should be whatever value. I'll type 100. In the horizontal direction that hardly matters, but in vertical direction I'll keep it at 50. And in both the cases I'll add this inch symbol, so 100 inches by 50 inches, and press enter. So we still have the old unit. The new units are not yet applied. To apply them, simply type Z for zoom and A for all. Now the limits are applied. So we have made all of these changes. Now we need to save it as a template. So I'll go to this application button, select save as drawing template. Now specify the location. I'll go to desktop, give it a name. So let's name it as my template, and you can see here DWT extension. Click on save, and with the default description, OK. Let's minimize it, and here we have it. We have this my template on the desktop. So let's start making drawings in AutoCAD, and we'll start it with line command. So you can start any command in AutoCAD by two different ways. So you can either select the command from the panels on these tabs, or you can use its command equivalent. So in this case, if you want to start the line command, you simply have to click on this line icon or the line tool. Alternatively, you can also use its command equivalent line or its command shortcut L, and you can simply press enter to start the command. So let's type L and press enter, and here also we have this line command. Now after starting a command, you'll notice that this command line will show in bold letters the name of the command or the command equivalent of that command, and also the instructions that you can follow to make the geometry. So in the first case, let's make a simple rectangle with a length of 10 units and a width of 5 units using the line command. So now here it's prompting you to specify the first point. So let's click anywhere in the drawing area to specify the first point. And here we have it. Now make sure that this polar tracking, object snap and object snap tracking is turned on for making this rectangle, and we'll learn about these status bar options later on in this course. Let's now move our cursor towards right side and enter a length of 10 unit and press enter. So now you'll notice that depending upon the current scale of a drawing, the line may be very small just like this, or it may be of very large size. So you need to zoom in and zoom out in order to fit that line in our drawing area. So now here we have it, the line of length 10 units. Now we need to make another line in the upward direction. So move your cursor in the upward direction and you'll see this green tracking vector. That simply means your line is completely vertical now, and enter the next distance, which is 5, and press enter. Now move it towards left and once again enter a distance of 10 units, press enter, and now you can move downwards and enter a distance of 5 units, and that will close the rectangle. Or you can simply type C on the command line for close and press enter, and this will close the complete rectangle like this. So using line command, we have made this rectangle of length 10 unit and 5 unit, and it's fairly simple to do this. But there is another method of doing this as well. So let's now erase this complete rectangle, and now we'll bring this UCS in the drawing area. And in order to bring it directly, you can click on this zoom extents option, and now you can bring it here. So now we will again make the rectangle, the same rectangle of length 10 unit and width 5 unit, but this time instead of using the direct distances, we will use the coordinates. So let's go to the line command. And now let's start the rectangle from the origin. So we need to specify the first point as 0, 0 and press enter. And now you'll notice that the cursor snaps automatically to the origin. Now we need to specify the second point, which will be somewhere at this place. And here we know that the length of the line should be 10. So the x value should be 10 and the y value is 0 because its distance in y direction is completely 0. So I'll type 10, 0, press enter, and here we have it, the line of length 10 units in this direction. Okay, now we need to make this line in upward direction and its length should be 5 units. So its coordinates will be 10, 5 because the value in x-axis is already 10 and we are taking it to a height of 5 units also, so that will also add up. So the total value will be 10, 5 for the coordinates. Press enter. Okay, now we need to go to this point and the coordinate for this point will be x0 and y5 because we don't have any value in the x, we only have a height here. So let's type 0, 5 and here we have it. Now we need to return back to the origin, and for that we simply need to type 0, 0 and press enter, and here we have it, the rectangle. Now press enter again to exit this command. So these are the two different ways of making the rectangle. Now this method will not work, the method of using coordinates will not work if you use any other point instead of origin as the starting point. So let's do this again, and in this case I'll select the line command once again, and now I'll click somewhere inside this rectangle. And now we need to make a rectangle of length 10 units, so I'll use the same coordinate value, which is 10, 0, and now press enter, and you'll notice that instead of making a horizontal line of length 10, the line is snapping to this endpoint, which is the actual 10, 5 value. So if you're not making any geometry from the origin, and if you're making it from anywhere randomly in the drawing area, then you need to use the relative coordinate system. And it's quite simple, you only need to add an @ sign before the coordinates. So if you want to make another rectangle, let's say that the rectangle should be somewhere over here, so for that start the line command, click anywhere, and now just type @10, 0. Now AutoCAD will assume this point, the starting point, as the origin, and now it will make a line of length 10 units. Now if you want to take this cursor upwards and if you want to make a line in upward direction, you can again type @0, 5 because in this case the origin will shift to this point. So whenever you will add an @ sign, the origin will shift to the previous point where you have clicked. So if this is origin and we want to make a line of length 5 units in the upward direction, so the coordinate of that point will be 0, 5. So let's press enter, and here we have it. Now we need to make another line here, and in this case we are moving in the left direction. So again I'll type @ and this time I need to enter -10 because we are making it in the left direction and the left direction is always negative. And we don't need to add any value in the y-axis, so I'll type y as 0 and now press enter. Here we have it. Now we need to move to this point, and in this case we need to move downwards in y-axis, and x-axis value is 0, so let's type @0, -5 and press enter to return back to the origin, and press enter again. So this system might be a little bit confusing to you, so don't worry about this. We'll practice this later on in this course, and you can always come back to this lesson after practicing some of the drawings, and then you will be able to use this relative coordinate system quite easily. So this was an introduction to the line command and also an introduction to making geometries using the absolute and relative coordinate system. In the next lesson, I will tell you about making the lines or making the geometries using the polar coordinate system. In the previous lesson, we have made a simple rectangle using the line tool, and we have used the simple Cartesian coordinate system, and we have also used the direct distance entry method and the relative coordinate system. So we have used multiple different methods to make the same rectangle. And now in this lesson, I will tell you about making lines which are inclined to certain angles, and for that we need polar coordinates. So let's say that we want to make a simple line which is inclined to an angle of 30 degree with a length of 5 unit. So there are a couple of methods for doing that as well, but we will use the simple polar coordinate method in this lesson. So let's start the line tool again. Click anywhere in the drawing area, and now as I told you that we need to make a line inclined to an angle of 30 degrees. For that, type this angle sign. Now this angle sign will be available on your keyboard right beside the M key. So type this angle sign and now type the angle which you want this line to restrict in, and then press enter. So now move your cursor and you'll notice that this line will be restricted to an angle of 30 degrees. Now you need to simply enter the length, and which is 5 in this case, and press enter, and press enter again to exit this command. And here we have it, the line of length 5 units which is inclined to an angle of 30 degrees with respect to the positive side of x-axis. Now there are also some other ways of making the same line. So I'll select the line tool again, click at any point here, and now if you want to make this line directly using a single command, then type at, and as you know that we have used the at symbol in the previous lesson also, so that will add a relative coordinate system. Now enter the length which is 5, and now type angle sign and enter 30. So this will be the angle. So the normal syntax of this command is at length of line angle sign and then angle value, and now press enter and press enter again, and we have this line directly using a single command. So in this way you can use both of these methods for making this line, and although this method, the second method, will be a little bit intimidating to you for now, but you will find it a lot easier when you'll become comfortable with some of the AutoCAD tools. So if you want, you can follow any of these methods for now. So let's erase these lines, and now let's make a few more lines. So I'll go to this line command, click at any point here, and now I'll make another line which is inclined to an angle of 45 degrees. So let's type at, and the length of line should be 5, so type at 5 and angle sign 45, press enter, and here we have it. Now let's make another line which starts from the same point, but this time it should be inclined to an angle of minus 60 degrees. So let's type at 5, the length of line, angle sign minus 60, and since we are entering a negative value of angle, the line should be made in this lower direction. So let's press enter, and yes, we have this line in this lower direction. You can also use a positive value, or you can also use 300 degrees for making the same line. So that will be 180 degrees plus the additional angle that will make 120 degree here, and that will be this minus 60 degrees angle. So this was all about using different distance entry methods in AutoCAD and making line with that, and from the next lesson we'll start making some of the other simple geometries in AutoCAD. In this video, I'll tell you about the circle command of AutoCAD. So you'll find the circle tool here on the draw panel of home tab, and when you click on this small arrow, you'll see the circle fly out with 6 different methods of making the circle. So the most basic method of making a circle is the center radius. Now in order to select the command, you can click on this center radius option, or you can also use its command equivalent circle or C. Now after starting the command, click at the point from where you want to start the circle, and in this case we want to start the circle from this midpoint of this rectangular geometry. So I'll click at this point, and this will be the center of our circle. Now look at the command line, and it prompts you to specify the radius of this circle. So let's enter the radius of this circle as 1 unit and press enter. So now here we have it, the circle with radius of 1 unit or a diameter of 2 units at the center of this line. Now let's look at the other method of making the circle. So go to this circle flyout and select the center diameter, and in this case we need to specify the center first, and obviously when you look at the command line, you'll notice that here we have the option. This option has been overridden, and we have this option now which says that we need to specify the diameter of the circle. So let's type 3 as the diameter and press enter. And now here we have it, the circle with a diameter of 3 units or a radius of 1.5 units. You can also start the diameter option from this center radius command. So click on this center radius. Now click at this point or any other point to start the circle, and now you can click on this diameter option on the command line to start the diameter, and now simply enter the diameter value. Let's say that we want to enter 4 as the diameter value and press enter, and here we have it, the circle with a diameter of 4 units or a radius of 2 units. So let's now erase all of these circles and now look at the remaining options here. So the next option is a 2-point circle. So what if we want to make a circle that connects 2 points, for example the end point of this line? So here we can click on this point and then click on this point, and here we have the circle, and this line will act as a diameter for the circle. Now let's click on this flyout again and select the 3-point. Now in this case we need to specify 3 different points. So I'll select here the first point. Now select the second point here, and now I'll select this point, and this is the midpoint of this line. So I'll click on this point, and here we have it, the circle on 3 different points. So this circle will essentially pass through these 3 points, and the radius of this circle will be decided based on the geometry here or based on the points on which we click. Now let's look at the remaining options here. So now we have one more option here, which is tangent radius. So I'll select this tangent radius, and now let's select any of the geometry for the first tangent point. So click on this circle. Now click on this line. So now the circle will be tangent on this circle and on this line, and now we need to enter the radius. So you need to enter a radius which will be appropriate for this geometry. So I'll enter 2 here and press enter, and now when you look here you'll notice that this circle is tangent on this circle, and this circle is also tangent on this line, and the radius of this circle is 2 units. Now what if we want to make a geometry in such a way that it's tangent on 3 different geometries? For that I'll first erase these 2 geometries, and now we'll make a single circle which is tangent on this line and on these 2 circles. So for that I'll select the last option, which is tritangent or tangent. Now click on the first circle, the line and the circle, and here we have it, this circle is tangent on both of these circles and also on this line. So these are the different ways of making a circle in AutoCAD. In this video I will tell you about the arc tool of AutoCAD. So here we have a simple square with 100 unit length and 100 unit width. Now when you go to the draw panel, you'll see this arc flyout, and when you expand it you'll see 11 different options for making the arc. So we'll start with the first option, which is 3-point arc, and as the name suggests, you need to enter 3 different points in order to make this arc. So I'll click at the first point, then second point somewhere over here, and the third point here, and here we have it. So in this way you can create the arc with 3 different points. Now let's look at the other option, which is start, center and end. So here we need to enter the start point at first, then the center point and the end point. So now let's start with the start point. So I'll click at this point, that will be the start point. Now I'll click at the center point, which will be the midpoint of this line, and now you'll notice that the arc is being formed in anti-clockwise direction, just like this. And now you only need to enter the third point. So click anywhere in the drawing area to apply the third point, and I can click here to make the arc, and here we have it. Now let's go to the other option here, and here we have this start, center and angle. Now before making this arc, I'll simply erase both of these arcs which we have made, and now select this start, center and angle. So once again we need to first click on the start point, then the center point, and now the angle. Now this will be the included angle of the arc. Now you can enter the included angle directly by clicking anywhere in the drawing area, or you can also type the angle. So in this case, let's say that we want to make an included angle of 30 degrees. So I'll simply type 30 on the command line and press enter, and here we have it. Now what included angle is actually, so let's make a line to show it more clearly. So click on the line tool, and now go to the center of arc and make this line. Now the angle which is in between this line and this line is of 30 degree, and you can verify it with this angle tool. So let's zoom into this area, and here you can see that the included angle is 30 degrees. So now let's remove it completely, and now let's look at other options here. So in a similar way, you can create an arc with a chord length. So here also we need to enter the start point, then center point, and then the chord length. So let's select it and click at the start point. And now the center point, which you can select at this point or any other point. Let's click here. That will be the center point, and now you need to enter the chord length, and in this case the maximum chord length can be equal to the diameter, and you cannot make a chord which is longer than the diameter, obviously, and depending upon the chord length the arc will be made. So let's say that we want to make an arc with a chord length of 60 units. So let's type 60 and press enter. So now in this case the length of this line, the line joining this endpoint of arc and this endpoint of arc, should be equal to 60 units. So that is the chord, and this is the chord length here in this case, and the length of this chord is 60 units. So let's erase it, and let's look at other options. So now we have these options in which we generally need an angle. So here also we have this start point, end point, and then angle. So let's click on this start point, then the end point, not the midpoint. So here I'm clicking for my endpoint, and now we need to specify the angle. Now this will be the included angle of the arc. So here also you can click anywhere in the drawing area to specify the angle, or you can also type the angle value. So I'll simply type the angle value, which is 90 in this case, and press enter. So now you must be wondering what this 90 angle is. So for explaining this, I'll make a line, and I'll click on this endpoint, and I'll join it with the midpoint or the center point of the arc, and I'll join it with the second endpoint of the arc. Now the angle between this line, let's erase this extra line. So now the angle between this line and this line should be 90 degrees, and again you can verify it with the same angle dimension, and we'll learn about these dimensioning later on. So here you can see the angle is 90 degrees. So let's erase these geometries, and let's look at other options. So now the next option is start, end, and direction. So once again here we have the starting point, then the end point, and now the tangential direction. So here you can simply see that as I move my cursor, the tangent line is moving, and also the radius of arc is changing. And here we can change it directly, but this line, the dotted one, is always tangent to this arc. Now if you want to change the direction, you can simply hold the control key, and the direction will change just like this, and this control key will also work for all the remaining arcs which we have drawn so far. So let's release the control key, and now let's click anywhere in the drawing area to make the arc just like this. Now let's look at the other option, which is start and radius. So in this case we need to first click at the start point, then we need to click at the end point, and now we need to specify the radius value. So that will be the radius of arc. So let's type a radius value of 60 units, and here we have it. Now this arc has a radius of 60 unit. So let's now erase both of these arcs, and let's look at other options. So now we have this center, start, and end. So obviously we need to first specify the center point, then start, and then end. So let's click at this point. So that will be the center point. Now the start point, and choose this point as the start point. And now you'll notice that the arc can be made in anti-clockwise direction. And all you need to do is specify the end point. So here I'm clicking to specify the end point. Now you can change the direction of this arc simply by changing the start point. So I'll select this option once again, and this time I'll select the same center point, but the starting point will be this one, and now the arc will be made in opposite direction. You can also change this direction by simply holding the control key as we have done in the previous case. So I'll just release it, and I'll click here. So let's now erase it. And now let's look at the other options. So now the next option is center, start, and angle. So here obviously we need to specify the center point, and then the start point, and the included angle. So here we have the center point, the starting point, and now we need to specify the included angle as we did in the previous case. But the only difference is that we are specifying the center point instead of the start and end points. So here also you can click anywhere to specify the angle, or you can simply enter the angle value just like this. So here I'm entering 90 and the arc is made with an included angle of 90 degrees. So if you make a straight line here, the included angle will be 90 degrees. So let's erase it now and let's look at this option once again. So here we have this center, start and length. So obviously you need to specify the center point and then the start point and the length of chord, and which is very similar to the arc which we have already made. So you can click anywhere to make this arc, and the length of this chord will be the length which you specified by clicking in the drawing area. Now the last option is a little bit different, the continue arc, and for this you need to make an arc, then only it will work. So we need to make an arc here. So I'll select this 3 point, now click at this point, now click somewhere around this point, and now click at the middle point somewhere around this. So here we have this arc. Now let's go to this flyout and select the continue option. Now as soon as you click on the continue option, you'll notice that another arc will be formed, and that arc will be tangential, or the geometry will be completely continuous in between these two arcs. And if you select the continue option once again, the next arc will follow the previous one, and in this case also the geometry will be completely continuous, or the arcs will have a completely tangential geometry at the point of contact, just like this. So this was all about creating arc with different options of the arc flyout. So you can use any of these options depending upon the geometry which you want to make, but the most frequent one are the 3 point arc, the start end radius, and the center start end, which I mostly use, but you can obviously use other options depending upon the situation. In this video, I'll tell you about making ellipses in AutoCAD. So ellipse is a simple mathematical curve, and in AutoCAD you can make it directly with the ellipse tool. So on the draw panel, when you expand this flyout, you'll see that we have this ellipse tool, and you can make it using these two options. We also have an elliptical arc that also will look in this video. So I'll start with a simple ellipse. Now as you can see that in this ellipse, we need to enter 3 different points. So for making this ellipse, we need to start with the center point. That will be the first point as mentioned in this flyout here, and then we need to enter the second point, that will be the end point of one of the axes, and then the third point, which will be the end point of another axis. So we'll do this on this geometry. So I'll select this center end ellipse. Now obviously we need to specify the center point as mentioned on the command line. So we need to specify the center of ellipse. So that center point will be point B in this geometry. Now we need to specify the end point of ellipse, and we can take the end point as point C or point A. So let's take this point C as the end point of one of the axes, and now you'll notice that our ellipse is changing shape along with the cursor, and you can simply specify the next endpoint of the minor or major axis. So here we can specify the next endpoint of the axis as this point, or we can also specify this point as the axis endpoint. But first we'll click at this point here, and that will be the axis endpoint, and here we have it. So now the A, B, C are the points on the major axis, where AC is the major axis and these 2 points are of minor axis. Now if major axis and minor axis have equal length, then that will make a simple circle. So now let's erase this ellipse, and let's select the second method, which is axis end. Now in this case we need to specify the 2 endpoints of the axis. So I'll select the A point as first axis endpoint, and then point C as the second axis endpoint, and now we need to again specify the endpoint of another axis. So here in this case I am again selecting this point, and here we have it. So the only difference between these two ellipses is, in the first case we need to specify the center and then endpoint, but in the second case we have to specify the 2 endpoints. So now let's erase this one as well. So now let's have a look at the elliptical arc. So for that I'll once again go to the flyout, and here we have this elliptical arc option. So let's select it, and now in this case also we need to first make the ellipse and then we'll convert it into an arc. So here as you can see that we need to specify the end point of the ellipse. Alternatively, you can also click on the center option here on the command line to start the ellipse from the center point. So I'll click on the center and then click on the center point, and now the end point of one of the axis, and here we have the ellipse. So now we need to specify the second end point, and now the ellipse has been made, but in this case the command is still active. And now you need to start the angle for elliptical arc. So click anywhere in the drawing area, and that will be the starting point for our elliptical arc. And as you can see that now our elliptical arc is being made from that point, and now you can click at any other point to end the elliptical arc, or you can also add the included angle directly on the command line. So I'll simply click here, and here we have it, the elliptical arc, which is simply a part of this complete ellipse. So in this way we can make ellipses and elliptical arc in AutoCAD. In this video I'll tell you about making rectangles in AutoCAD. So we've already seen the simple methods of making rectangle using the line tool, but we have a direct method of making rectangles in AutoCAD as well, and that's using the rectangle tools. So here we have this rectangle tool on the draw panel, and when you expand the flyout you'll see the rectangle tool here. Now select the rectangle tool, and now you need to specify the first point for making the rectangle, and you can specify the first point as 0, 0. That will be the origin in this case, and you can see that the rectangle starts from the first point at origin. Now look at the cursor, which is at this vertex of the rectangle, and now when you look at the command line you'll see that it's prompting you to specify the other corner point, and that is this corner point on which we have our cursor right now. So all you need to do is enter the coordinates of this point. So let's say that we want to make a rectangle with length 10 and width 5. So in that case the coordinates of this point will be 10, 5. And now press enter, and here we have it, the rectangle with length 10 units and width 5 units. So now in this case we made this rectangle from the origin, that's why it was very easy for us to make a rectangle with this kind of length and width. But what if we make the same rectangle not from the origin? So I'll start the rectangle and click anywhere in the drawing area to make the rectangle, and that will be the first point. Now we again need to make another rectangle with length of 10 and width of 5 units, but in this case I'll simply enter 10, 5, and now look at the results. And instead of making a rectangle with length 10 and width 5, the next rectangle simply snapped to the same point, which was 10, 5. So in this case we need to change some parameters. So now I'll erase this rectangle and I'll start the rectangle tool. Now again I'll click anywhere in the drawing area, and now obviously if you want to make a rectangle with length of 10 and width of 5 in such a way that it does not start from the origin, then you need to add this add sign. So this add sign will tell AutoCAD that the origin point is this one, the original point on which we have clicked to start this rectangle, and now simply enter length, 5, that is width, and press enter. And here we have it, the rectangle with length 10 and width 5 units. So whenever you need to make a rectangle, you need to simply enter add sign and then length and then width. So that will make the rectangle of desired value. Now we can also add some properties to this rectangle, and one of the property is fillet or the rounded edges. So let's start this rectangle, and now look at the command line. So we have these multiple options here. I'll select the fillet, and now I'll enter 1 as the fillet radius. So we'll learn about fillets later on in the next module, and for this example I'll simply make a normal rectangle with a fillet of 1 unit. So now we have specified the fillet value, simply specify the first corner, and now when you start making the rectangle you'll notice that the rounded corners will be formed automatically, and the radius of these corners or the vertices will be 1 unit, and that's the fillet which we have applied. So you can click anywhere in the drawing area to make the rectangle, or once again you can enter add length, width to make the rectangle of desired value. So I'll simply erase it, and I will change the values once again. So I'll go to fillet again, and I'll change the value back to 0, and now I'll make another rectangle like this. So if you want to make a rectangle with some width, that also you can do. So for that I'll select the rectangle tool again, and now here we have an option of width. So let's select this width and apply a width of 0.5 units, and now click at a point to start the rectangle, and then click at another point to end it. And now here we have this rectangle with some thickness or some width, and we'll also learn about this polyline width later on in this course. So we again need to start the rectangle tool, select the width option and change the width value back to 0, and here we have the normal rectangle. So let's now erase it. So in this way we can make a rectangle with variety of different options in AutoCAD. In this video I will tell you about the polygon tool of AutoCAD. So a polygon is simply a closed geometry which is made up of a minimum of 3 line segments and a maximum of infinite number of line segments. So technically a circle is the largest polygon with infinite number of sides, and a triangle is a smallest polygon with 3 sides. So in AutoCAD you can make a polygon with a minimum of 3 sides, which is a triangle, and a maximum of 1024 sides. And I guess 1024 side is more than enough for making any kind of polygon in AutoCAD. So we can start making polygon from the tool here on the draw panel. So when you expand the flyout, you'll see this polygon tool here. Now after starting the polygon tool, you'll see on the command line we have an option here which says we need to enter number of sides. So you can enter any value between 3 and 1024. So let's enter 5 and press enter. So we are making a pentagon now, and now you need to specify the center of polygon. So click anywhere in the drawing area to specify the center, and now look at the command line. And command line now prompts you to choose one of the options, either inscribed in a circle or circumscribed about a circle. So if a polygon is inscribed in a circle, then that polygon will look something like this. So here we have this circle, and the polygon will be included in the circle in such a way that the vertices of polygon will touch the circumference of the circle. But if the polygon is circumscribed about a circle, then the polygon will be outside the circle, and the midpoint of the line segments of polygon will touch the circumference of the circle. So in the first case I'll select this inscribed in a circle, and now here we have it. So in this case you can simply see that my cursor is on one of the vertex of this polygon, and the imaginary circle is passing through all of these 5 vertices of this polygon. So now we need to enter the radius of that circle within which this polygon is inscribed. So I'll enter 10 as the radius and press enter. So here we have this polygon. Now the circle which is passing through all of these vertices is the circle with radius of 10 unit. So now let's move it here, and now let's select the polygon tool again, and once again I'll enter 5 as number of sides, and now specify the center point, and now I'll select circumscribed about circle in this case. And now you'll notice that instead of vertices, the cursor is now at the midpoint of the line segment, or you can say that the cursor is at the midpoint of one of the sides of this polygon. So now you need to click anywhere to specify the size of this polygon, or you can also enter the radius. So in this case also let's enter 10 as the radius, and now we are entering the radius of this circle which is inside the polygon, and the midpoint of the sides are touching the circle. So here we have the same polygon which is inscribed in a circle of radius 10, and here we have the polygon which is circumscribed about a circle of radius 10 unit. So we have one more method of making the polygon, and using that method you can make a polygon with a known value of its side length. So let's say that we know the length of the side of this polygon, and we want to make a cyclic polygon in such a way that all the sides of that polygon are of that length which we specify. So for that you can select the polygon tool, and now once again enter number of sides, and let's say that in this case we want to enter 6 as number of sides and press enter. Now specify the center of polygon to make either inscribed or circumscribed polygon, or you can simply click on this edge option, and using this edge option you can make the desired polygon. So now you need to specify the first point of the edge, and now you need to enter the second point of the edge length, and now let's type 10 and press enter. And in this case, as you can see, that we were not required to add either inscribed or circumscribed option, we simply entered the length of one of the edge of this polygon, and now all of the edges are of same length, which is 10 units. So in this way you can make an inscribed circumscribed polygon, or a polygon with a known value of its edge length. In this video I will tell you about polylines and splines. So let's start with the polyline tool. So here on draw panel you'll see this polyline tool, and when you select it you'll find its behavior is very similar to that of a line tool. So let's make a geometry with this. So I'll click at a point to start the polyline, and then click at the next point, and then the next point, and then the next point, and press enter to exit this command. So now in this case you can see that we have this geometry which is very similar to the line tool. But now let's look at this line command. So select it, now click at a point, and then make a similar geometry, but this time I'm using the line tool. And now let's see the difference between these two geometries. So in the first case, when you click on any of the segment, the complete segment will be selected. But in the second case, selecting the segment will only select that segment. Also, we have this additional grip which is quite different from the grips which we have here on the polyline. And when you hover your cursor over the polyline grips, you'll see this additional menu, and we'll learn about this later on in this course. So that's one of the basic difference between a polyline and a simple line. So in this case the lines are quite separate from each other, and in case of polyline they are combined into a single unit. Now let's erase them. Polyline has also many other properties. So let's start this polyline, and now I'll click at a point to start the polyline, and now look at the command line. Here we have some other options related to the polyline. So I'll just click at the second point somewhere over here, and now I'll select the arc option. So now once I select the arc option, you'll notice that the polyline now changes into an arc, and we can directly make an arc shape with this polyline, and now it's still in the form of an arc. So we'll return it back to the line, and for that you need to click on this line option from the command line, and now it's back to this line shape. So once again I'll just drag this point and click here, and now click here, and here we have it. So using a single command we can make this kind of geometry which has this little segment, the line segment, and also the arc shape, and the polyline tool can be used to make it. So now let's select this polyline tool, and let's look at other options related to the polyline. So now I'll click at a point, and now look at the command line. So here we have this option of half width. Let's select it, and now let's apply a starting half width of 10 unit and press enter. And now here we have an option for ending half width. Let's select 10 also in this case, and now look at this shape. So now we are able to make this polyline but with certain width, and this is the final shape of polyline. So now the half width of this complete polyline is 10 units. So the complete width of this polyline will be 20 units. So now let's erase this geometry, and I'll select the polyline tool again, click at a point, and now I'll change the half width value to 0 for both the cases, for the starting and end width. And also we have an option of width here. So using the width option you can enter the complete width of the polyline. So let's say that we want to enter a width of 20 units, so simply type 20, press enter, and the ending width also 20, and now we have the same results here. So using half width we have applied a width of 10 units in between the center line and the periphery or the extreme end of this thickened polyline, but in this case we were applying the complete thickness or the complete width of this polyline, which was 20 units in this case. And here we have the final geometry. So here also you need to change these values to their default in order to have a normal behavior of the polyline. So now here we have the normal polyline. Now let's look at the spline tool. So using splines you can create some very organic shapes, and when you expand the draw panel you'll see we have two spline commands here, the spline fit and spline with control vertices. So let's select the spline fit. Now we can click at a point to start the spline, then click at the second point, third point, and so on. So this is the spline shape which can be used to make many organic shapes in AutoCAD. And now press enter to exit this command, and when you click on this spline, you'll notice that the points where we clicked, we have these grips. So at every point where we clicked, we'll have this grip on the spline. Now let's make another spline with spline control vertices. So let's select this flyout and select the second option, which is spline CV, or spline with control vertices. Now in this case, I'll again click at a point and I'll make the spline. But in this case, if you look closely, you'll find that the spline is made in a slightly different way. So now let's press enter and let's zoom into this spline, and now you'll notice that all the points where we clicked will see this grip, and the spline is not touching the points where we have clicked, except for the starting and end point. So we have clicked at this point, then this, and then this point. Now if you want to change the type of this spline, if you want to make it a spline of this type, then you can change it using this grip. So click on this down pointing grip and change it to fit, and here we have it, this spline fit. In a similar way, if you want to change the type of this spline using this down pointing grip, you can change it to control vertices, just like this. If you want to change the shape of this spline even further, you can use these grips to change its shape, and using this control vertices spline, you'll have more control over the curvature or the geometry of this spline. And in this case also, you can select these grips to further modify the shape of these splines. So this was all about polyline and spline command of AutoCAD. In this video, I will tell you about the point and revision cloud tools of AutoCAD. So I'll start with the point tool, and in order to make a point in AutoCAD, you need to use its command equivalent, which is PO or point. So let's type PO on command line and press enter. Now click at a point, and here we have it, the point is made. Now in order to make another point, simply press enter or spacebar to repeat the last command and click again, and you can repeat this process a couple of times to make multiple points here in the drawing area. So now we have a couple of points here in this drawing area, but the points are very small, almost they are of the size of a single pixel, and they are not clearly visible. In order to make them visible, you can change their style or their type, and you can change that using the p type command. So let's type p type on command line and press enter. So this will open this point style window, and from here you can change the type of point. Currently we have the single pixel type of point selected. Let's change it to this one, and now click OK. Don't change any other variable here, and simply click OK, and now here we have it, the different point styles, and now they are quite visible. So let's now move to the revision clouds. So revision clouds are the geometries that are used in the drawing to indicate the revision areas. And in AutoCAD, you can make revision cloud with couple of different ways. So here we have this rectangular, the polygonal, and the freehand revision cloud. So you can use any of these options. So I'll start with the rectangular revision cloud. So let's select it. And now let's say that we want to make a revision cloud somewhere over this area of the drawing. So for that, I'll click at this point, and now I'll make a simple revision cloud just like this here. So now here we have this revision cloud. Although the arcs are very small in this revision cloud, that will also take care of. And now after adding the revision cloud, you can add any node. So in this case, as you have seen that the arc length is very small, we need to modify it. So let's do this with another revision cloud. So I'll click on this draw panel to expand it, select the revision cloud, and now look at the command line. So here we have an option of arc length. So let's select it, and now the minimum length of arc is set to 0.5. So let's change this value to 2 units, and now specify the maximum value as 5 and press enter. Now we'll make another revision cloud. So here we'll add it. So let's click at this point, and now you can see the clear difference. So the arcs in this revision cloud are quite visible, and the minimum size of the arc is 2 unit and the maximum size is 5 unit as we have specified. So let's now erase both of these revision clouds, and let's look at other options of revision cloud. So once again, I'll go to this draw panel and I'll select the same revision cloud option. Now here we have some other options. For example, we have the rectangular, which we have already seen. We also have a polygonal revision cloud. So let's select this polygonal. Now let's assume that we want to include this object and this object in our revision cloud. So for that, we can make a polygon just like this. So click at a point here. Now click at this point, then this point, and make a revision cloud to include only these two objects. And in this way we can make the revision cloud. Now press enter, and here we have the final revision cloud. We also have one more type of revision cloud, and that's a freehand revision cloud. So let's press enter to repeat the revision cloud command. You can also go to this draw panel and repeat the command, but the quick way is simply pressing enter key or the space bar, and it will repeat the last command. So now we have already seen the polygonal. Let's look at the freehand, and in this case you can make a freehand sketch and click at a point to start the freehand cloud, and now make a sketch just like this, and when you reach the starting point the cloud will automatically finish and the completely closed loop will be formed just like this. You can also change the type of revision cloud using the same option. So let's press enter, and now here we have a style option. So let's click on style, and we have already selected the normal, and these are the normal revision clouds. Let's select calligraphy, and here we have a different kind of revision cloud, the calligraphy type of revision cloud. So let's now press enter again, and let's select the modify option. So now using this modify option you can modify any existing revision cloud. For example, let's assume that in this case we want to include these two objects as well in our revision cloud. So for that I can select the modify, and now I'll select the polyline which we want to modify. So obviously this is the revision cloud which we want to modify, and the revision clouds are made up of polylines. So I'll click on this revision cloud, and now let's start making another one. So I'll click at this point, and then I'll click at this point. So now we have included both of these, but we also need to remove this part. So simply click on this part and the part will be removed, and now we have it perfectly in order, and we don't want any changes. So simply press enter, and here we have the final revision cloud. So in this way you can make many revision clouds, different kind of revision clouds in AutoCAD, and even you can modify them and change their type. In this video, I will tell you about the construction line and array command of AutoCAD. So construction lines are simply lines which are used for helping to make other geometries, and they are infinite lines. So to make the construction line, go to the draw panel, expand it, and now select this option here. So here we have this construction line. You can also use its command equivalent X line. Now in order to make this construction line, simply click at a point to start it, and now click at the second point. So in this case you'll see that we have an infinite line, and you can click at any point to add this line. So I'll click at this point, and once again I'll click at this point. So now we have these two construction line. Now press enter to escape this command, and here we have a vertical and a horizontal construction line. Now let's assume that we also want to add a ray here, and a ray is simply another construction line, but it only starts from a point and goes in a direction. And in case of construction line, it starts at a point and goes in both the directions. So let's now expand the draw panel, select the ray tool, click at this point, and now you'll notice that this ray is going only in one direction. So you can click at any point to place it, and now press enter again to escape this command. These kind of geometries are quite helpful in making walls or the exterior boundaries of certain objects, and after making the geometries you can trim the remaining portions to make the geometries. So when you select the construction line tool, you'll see there is an option of offset. So selecting this option will allow you to create another construction line at certain distance from the original one. So let's say that we want to make another construction line at a distance of 10 units. So let's type 10, press enter. Now select the first construction line and click on the direction on which you want to make another construction line, and here we have it. So now we have another construction line in the upper direction. So in a similar way, if you want to make the construction line in this direction, simply select it and now click downwards, and here we have it. So in this way, using this offset tool, you can make multiple construction lines at certain offset distance from the original one, and we'll learn about this offset tool later on in the next module also. Okay, so now let's look at the question which is related to this module. So here in this case, you need to make this drawing using only the commands which are taught in this module. I will start with the circle command. So let's go to circle and click anywhere in the drawing area and make the first circle with radius of 2 units. So let's type 2 and press enter. Now press enter again to repeat the circle tool, and I'll go to the same center point. Now I'll make another circle with radius of 5 units and press enter. Now we have these two concentric circles. Now let's start with the line tool. So I'll click on line and now click at this quadrant, and if the quadrant is not visible, then you can click on this object snap option, and right beside that there is this small arrow. So just click on it and turn on this quadrant. Although this is a tool which we'll learn later on, but a little bit of knowledge of this tool is very helpful in making these kind of drawings. So you can turn on quadrant to see that point. Now we need to incline this line at an angle of 45 degrees. So let's type angle sign, and since this line is inclining in the downward direction, we need to enter -45 and press enter. Okay, so there we have it. Now the length of this line is 20 units, so let's type 20 and press enter. Now move it in the downward direction and enter a length of 5 units and press enter. So there we have it. Now let's press enter to exit this command and repeat the same process for the second side. So I'll press enter, I'll go to the next quadrant, and in this case I'll again type angle sign, and now I'll type an angle of 225 degrees. So let's type 225 and press enter. So there we have it. The angle inclined to 45 degrees with respect to the horizontal line. Once again we need to enter a length of 20 units, so type 20 and press enter. Now move downwards, enter a length of 5 and press enter. Now join it with this existing point and press enter again. Now press enter again to repeat the line tool and join these 2 points. There we have it. Now we only need to add these 2 small circles, the circles which were here and here. And in order to do that, I'll start with line and click at a point, move it in left direction and enter the length 6 and press enter. Press enter again to exit it and press enter again to start it. Now click at this point and make another line with length 6 and press enter twice. Now go to the circle tool, click on this end point and make a circle with radius of 1 unit. Press enter again, go to this point, make another circle with radius 1 and press enter. Now we can erase these 2 lines, these are no longer required. And there we have it, our final geometry as per requirement. In this video, we will learn about making selection sets in AutoCAD. So in AutoCAD, you can make selection of objects in many different ways, and we have been doing it in the previous lessons also. So the most basic way of selecting objects is by a simple window and a crossing window. So here we have some objects here in the drawing area. Now let's say that we want to select objects here now in this part. So in order to make a selection, you can click on the left side of the screen. So I'm clicking on the left side of the screen and I'm stretching my cursor towards right, and now in this case we have this solid window, and everything which is included in this solid window will be included in our selection set. Now if you expand this window, you'll notice that we are trying to include more objects, but when you look at this rectangle here, you'll notice that it is not included in our selection set even though this window is touching it. So the only criteria for objects to be selected with this window is it should be completely included in this window, which this rectangle is not fulfilling, and that's why it's not added to our selection set. So let's now click here, and everything has been selected except the rectangle and the text because they were partially inside and partially outside. Now let's repeat the process, and we'll repeat it with another window. So now I'll click on the right side of the drawing area and I'll move my cursor towards left, and now we have this dashed window, and in this case you'll notice that everything which is completely inside this window is obviously selected and it is included in our selection set, but also the objects which are touching this window are selected, and this rectangle and the text here are also included in the selection set, although they are partially inside and partially outside, but still they are selected because they are touching the window. So this is the second way of selecting objects. So you can use either of these options, and we have many other options also for making selection. So the next one is window polygon, and to make a window polygon, click at any point to start the selection set, and now look at the command line. Here we have this window polygon option. So click on this window polygon, and now we can make a polygon to include some selective objects. For example, let's say that we want to include only L4 and L7 in this case here, just like this. So we can make this kind of selection window, and if you want to include ACV block also, so you can make this window something like this. And now in this window ACV is also included, but we are obviously leaving the L1 geometry here. So in this way you can create different kind of selection windows. Now press enter and the objects will be selected just like this. In a similar way, we can make a crossing polygon also. So click anywhere in the drawing area to start the selection set, and now click on this crossing polygon option from the command line. And now we can make a crossing polygon which is similar to the window polygon, but in this case all the objects which even touch the boundaries of this crossing polygon will be included in the selection set. And obviously in this case the ACV text and this block are simply touching the boundaries, and they are also included in the selection set. So now press enter, and here we have it. The objects are now selected. So we have one more selection set here, and for that I'll again click at any point here to start it, and we have this first option, fence. Now using fence you can create a fence, and whatever object is touched by this fence will be selected. So in this case you can see that this fence is simply touching the objects, and all of these objects are now included in our selection set. Now press enter, and here we have it. The objects are included in the selection set. In the AutoCAD 2018 version, AutoCAD added an off-screen selection, and the off-screen selection is helpful for selecting this kind of long geometries. So let's say that we want to make a selection by zooming this drawing, and we just want to include our selection somewhere from here. Now we are including the objects in our selection set, and along with inclusion of objects we are also moving the drawing towards right. So now we are scrolling it, we are panning it here, and now we are including many objects. Now let's click here. Now all of these objects which are present in the screen are obviously selected, but in the previous versions of AutoCAD, if you would have panned your drawing, you will find that these objects would be removed from the selection set, but not anymore with AutoCAD 2018 version. So with AutoCAD 2018 version, all the objects which are not present in the screen will also be selected if you have included them in the selection set. So now when you zoom out, you'll notice that the complete set of objects are included in the selection set even when they were not present on the screen while making the selection. So that's a new enhancement in AutoCAD 2018 version. So this was all about creating selection sets in AutoCAD, and using these selection set you can make some intelligent selections even in the crowded drawings. In this video I will tell you about move and copy tools of AutoCAD. So here we have this rectangle and we have a circle here on one of the vertices. Now let's say that we want to move this circle on the second vertex here. So for that we can select the move tool from the modify panel. So select the move tool, now click on the circle, press enter, and now specify the base point. As you can see here, the command line prompts you to specify the base point. So the base point will be the point from where the object will be picked. Now click here and you will notice that the object will now move along with our cursor. Now look at the command line, and it now prompts you to specify the second point. So the second point will be the destination point where you want to move it, and click there to move the object. So that's quite simple. Now we have a copy tool here. So using the copy tool you can make copies of this original object. Now let's say that we want to make copies of this circle on the remaining 3 vertices. For that simply select the circle, press enter, and once again select the base point. So the base point will be this midpoint in this case as well, and now click at the destination point, which is this one, and now click again on the destination point and click again on the destination point. And now when you want to exit this command, simply press enter, and here we have it, the copies of the original object on these 3 vertices. If you want, you can also make multiple copies of a single object using the copy tool. So let's make a simple rectangle here just like this. And now let's assume that we want to make 6 copies of this rectangle at a particular distance. For that, I'll select the copy tool and now select the object and press enter. Now specify the base point, so this will be the point from where we want to pick the objects. And now as you can see that we only have a single copy of this object. Now you can make multiple copies using the array tool. Here we have this array tool, so click on this array and now enter number of items. So we'll add 6 as number of items. Now press enter and here we have it. We have 6 objects instead of 1 as copies. And now you can click at any point to place all of these objects and they will be placed at uniform distance. Now if you want to apply the complete distance, the distance between the first and the last object, then simply select this fit option. And now you can see that our cursor moves to the last object and we can apply the complete distance, and based upon that all the objects will be equally placed. So I'll click somewhere at this point and here we have it. Now simply press enter to escape this command, and here we have it, the multiple copies of a single object. So in this way you can use move and copy tool in AutoCAD. In this video I will tell you about the rotate command of AutoCAD. So here we have this simple line object. So let's first look at this line object, and if you want to rotate this object to any particular angle, you can do that with the rotate command. So on the modify panel here you will find this rotate tool. So click on this rotate and now select the object which you want to rotate and press enter. Now the command line will prompt you to specify the base point, and the base point will be the fixed point or the pivot point about which the object will rotate. So in the first case let's select this corner as the base point, and now you'll notice that the object will move along with our cursor. So you can click anywhere in the drawing area to place this object and it will be rotated to that angle, or you can add an exact value of angle using the command line. So let's say that we want to rotate it to an angle of 30 degrees. So for that I'll type 30 and now press enter. And here we have it. The object is now rotated to an angle of 30 degrees. And the rotation simply means that if you draw a single line, then the angle between this line and this line will be 30 degrees in anti-clockwise direction. So that's the direction which is always positive in AutoCAD. Now let's say that we want to make this line in the downward direction. So for that I'll simply add -30 instead of 30. So let's press Ctrl Z for a couple of times and now select the rotate tool and click on this line, press enter, select the same base point, and instead of 30 let's enter -30, press enter, and now you can see that the line is rotated to this angle which is below the horizontal line. So let's press Ctrl Z to get back to the original condition. Now in both of these cases you have noticed that the original line is removed and it is rotated to that angle. Now what if we also want to retain this line and we also want to make a copied line at the required angle? For that we can select the rotate tool, select the object, press enter, specify base point, and now select the copy option from the command line and now enter the angle. So let's say that we want to enter 45 and press enter. So in this case the original line is also retained and a copy will be rotated to the required angle. Now let's look at one more case, and in this situation we'll change the base point. So let's select the rotate tool, select the object, press enter, and now in this case I'll select the midpoint as the base point, and now you'll notice that the object will be rotated from that point, and you can obviously add the angle, let's say 60, and here we have it, the rotated line. Let's now erase it. So now let's look at this case. In this situation we have this line which is inclined to this horizontal line and we don't know the angle to which this line is inclined. Now if you want to rotate this line to an angle of let's say 60 degrees with respect to this line, so that the final angle is 60 degrees plus whatever angle this is, then we can use the reference option, and for that select the rotate tool, select the object, press enter, select the base point, select the reference tool, and now specify the reference angle which is 0 in this case. So let's type 0 and press enter. Now we need to enter the final angle, which is 60, and press enter. So now the final angle for this line will be 60 degrees plus whatever the angle of the original line was. So in the initial case, the line was inclined to an angle of 16 degrees. So the final angle will be 76. Let's check it. So I'll select the angle tool, click on these two lines, and yes, we have this inclined to an angle of 76 degrees. And if you want to verify that, let's press Ctrl Z for a couple of times and let's check the original angle. So I'll click on these two lines, and yes, we have this line inclined to an angle of 16 degrees. So even without knowing the angle of these lines, you can change its direction, or you can rotate them to whatever angle you want from their own position. You can use this reference option to rotate this line to any final angle also. For example, in this case, we again don't know the angle of this line. Let's assume that we don't know, and we want to rotate this line to a final angle of 30 degrees with respect to this horizontal line. For that, I'll select this rotate command. Now select the line and press enter. Now specify the base point, and now once again select the reference option, but in this case we will specify the reference angle, and for that I'll click at this point and then click at this point. Now you'll notice that the cursor will move along with this line, and now we need to enter the final angle up to which you want to rotate it. So we want to rotate it to an angle of 30 degrees, so type 30, press enter. So now the line has been rotated to an angle of 30 degrees with respect to this horizontal line, and it hardly matters whatever the initial angle was. So we can also check this. So let's select the angle option, select this line, and yes, we have an angle of 30 degrees here. So in this way you can rotate a line to any final angle even without knowing its initial angle with respect to the positive side of x-axis. In this video, I will tell you about the offset command of AutoCAD. So here we have these two simple geometries, and we will use offset command on them. So from the modify panel, select this offset tool. Now look at the command line. It prompts you to specify an offset distance. So let's select 2 as the offset distance and press enter. Now you need to select the object which you want to offset. So in this case, I'll select this line. And now look at the second line. So now a copy of this line has been made here on this direction because our cursor is towards this side, but if I move my cursor here, a new copy will be made on this side. So you can simply click on this side of the line and a copy will be made like this. Now if you want to create another copy of this object, simply click on this line and click here. In a similar way, you can keep creating copies of this line on either side using the offset tool, and the gap between all of these lines is 2 units. So let's now press escape key and press Ctrl Z. Now let's say that we want to make multiple copies of this line without selecting the offset tool again and again. For that, select the offset tool. Now specify the offset distance, which is 2 in this case, and now select the object, and from the command line select this multiple option. Now you can see that our command is still in continuation even after clicking. So I clicked and still we have this command, and now you can keep on clicking on the side where you want to create multiple offsets. You can repeat the process for this side as well. So now let's press escape key again and let's press Ctrl Z. Now if you don't want to specify any particular distance for offset, you can use the through option. So select the offset tool, and now here we have this through option. So let's select it and now select the object, and now you'll notice that the offset geometry will follow our cursor. So we can simply click here to make the geometry, and you can select it once again and make another copy at some random distance dynamically by clicking anywhere in the drawing area. Now again press escape key to exit the command and press Ctrl Z to get back here. Now if you want to create an offset by erasing the source object, that also you can do, and for that once again select the offset tool, and now from here command line select this erase option, and here you'll notice that erase source object after offsetting option has been set to no. That's why the copy of the original object is made and without erasing this object. So I'll select yes in this case, And now once again I'll repeat the process. So I'll type 2 as the offset distance, click on this object, and now click at particular distance, and here we have it. The original object has been deleted and an offset copy has been made here. So you can again go back to the offset command and go to the erase and change it to no once again. And now if you offset, the original object will also be retained. You can use offset command on this geometry as well, and for that I'll once again select the offset tool, and now here also I'll specify the distance. So let's specify 1 as the distance, the offset distance, press enter, and now click on the object, and now click outside, and you'll notice that a copy will be made outside. And now let's select the original object and click inside. So we have two copies, one outside and one inside, and the distance between all of these objects is 1 unit. So the distance between this rectangle and this one is 1 unit on all the sides. Similarly, the distance between this line segment and this line segment of the rectangle is also 1 unit. So let's now erase both of them. And now let's look at some other options related to the offset tool. So here the offset is making the similar geometry which we have made here, but if you want to apply rounded corners on the offset geometry, you can do that by changing the offset gap type system variable. So let's type offset gap type and press enter, and now here you'll notice that the default value of this offset gap type variable is set to 0. Let's change this value to 1 and press enter. Now we will again make the offset. So select the offset tool, specify offset distance as 1, press enter, and now click on the object, and now click outside, and now we have a different geometry here. In this case, the fillet has been applied, or the rounded corners are applied with a radius of 1 unit. So that's the same radius which is equal to the gap of this object, or the offset gap. In a similar way, you can also apply a chamfer, and chamfer is simply a straight line. So let's erase this geometry, and let's change the value of offset gap type system variable. So let's type offset gap type, press enter, and now change this value to 2 and press enter. Now once again I'll select the offset tool, again I'll select 1 as offset distance, and now in this case, instead of fillet, a chamfer has been applied. So I'll once again type offset gap type system variable and change its value to default 0. And now we can make the normal geometries using the offset tool. So once again I'll select offset, I'll select the through option, and now click on the object, and now you can see that we have a normal geometry here, just like this. In this video, I will tell you about mirror and scale command of AutoCAD. So here in this case, we have the simple geometry and a text here, and you can create the mirror image of both of these geometries in AutoCAD. So I'll start with this simple geometry here. So in order to create a mirror image of this geometry, select the mirror tool from the modify panel, and now look at the command line which prompts you to select the objects. So select the object and press enter. Now the command line prompts you to specify the first point of mirror line. So click anywhere in the drawing area, that will be the first point, and now click at the second point of mirror line, and now you can see that a mirrored copy of original object will be made. And now click here, and now look at the command line. So now it prompts you to specify whether you want to erase the source object or not. So we don't want to erase this source object, so I'll select no, the default value, and simply press enter. So here we have the mirrored image. Now let's say that we want to make a mirror image of both of these objects on the upward side. So for that, I'll once again select the mirror tool. Now select both of these objects, press enter, and now specify this as the first mirroring point and this one as the second mirroring point, and simply press enter. Here we have it, the geometry as per our requirement. Now in case you want to make a complete mirror image of all of these 4 geometries somewhere over here, for that you can again select the mirror tool, select the complete set of objects, press enter. Now again you need to specify the mirroring line. So I'll select this as the first mirroring line and this point as the second mirroring line. And now let's erase the source object in this case. So I'll click on yes, and the source object is deleted and a copy of that object is made here. So now let's press Ctrl Z a couple of times to return back to the original geometry. Now we'll try the mirror tool on this text also. So select the mirror tool, select the text, press enter, and now click at a point and then click at second point. and press enter. But in this case you'll notice that the mirror copy has not been made. It is simply a copy of this original object, and these two objects are not laterally inverted as it was in case of this object. So in order to make a mirror image of text, you need to ensure that the mirror text system variable is set to 1. So I'll make a copy of this object here, and now I'll apply the mirror tool once again on this text. So before that I'll change the system variable. So let's type mirror text and change its value to 1 and press enter. Now select the mirror tool, select the text, press enter, specify the first point and the second point and press enter. Now we have it as a mirror image, and you can compare it with the original copy or the original mirror image which we have made without using the mirror text system variable. So in this case the mirror text system variable was set to 0, in this case it was set to 1. So I'll once again type mirror text and I'll change its value to default 0. Now let's look at the scale tool. So here we have a simple geometry, and now let's assume that we want to increase the size of this geometry. So in order to increase the size, you can use the scale tool. So simply select the scale tool here on the modify panel, select the object, press enter, and now look at the command line. It now prompts you to specify the base point. So base point will be the point which will remain fixed when the object will be elongated or contracted. So when the size of this object will change, the base point will remain fixed. So I'll select this lower left corner as the base point, and now you'll notice that the size of object changes along with our cursor. So you can either select the cursor, or you can dynamically apply the size using the cursor, or you can also enter a scale factor. So in order to increase the size, simply add a value which is greater than 1. So if you add a value 1.5, then the size will increase to 1.5 times of the original value. So if you type a scale factor of 2, it will make a geometry which is twice the size of original object. If you type 3, it will make a geometry of thrice the size, and so on. Similarly, if you type 0.5 as a scale factor, it will decrease the size to half of its original value, and so on. So I'll type 1.2 in this case and press enter. And here we have it, the larger geometry has been made. So now let's press Ctrl Z to get back to the original geometry. Now in case you want to make a copy of this object after scaling, then you need to select that corresponding option. So I'll select the scale tool again, select the object, press enter, specify the base point, and now here we have an option of copy. So let's select this copy option, and now let's reduce its size to half of its original value. So I'll type 0.5, press enter, and now you'll notice that we have a copied image. Let's select and move it outside. So the size of this object is half of the size of this object in all of these dimensions. So let's now press Ctrl Z to return back to the original geometry. Now in this case the size of this object is somewhat close to 950 units, and let's make a line which is equal to 1000 units. So I'll make a line of length 1000 units. And here we have it. So now you can see that there is a slight gap between this endpoint and this line. So let's assume that we want to scale this drawing in such a way that the base length becomes 1000 units and all the remaining length stretches in the similar proportion. For that we can use scale reference option. So once again go to the scale tool and now select the object and press enter. Now specify the base point which we have specified in the previous case also, and from the command line select this reference option. Now we need to specify the reference length, which is the length of this line from this point to this point. So I'll simply click at this point, and now I'll click at this point. So that's the reference length. Now you need to specify the new length, and the new length is 1000 units. So simply stretch it and click at the end of this 1000 unit length line. So click here, and here we have it. So now the base length is equal to 1000 units and the remaining lengths are proportionally changed. So you can now erase that original line. It's no longer required. So in this way you can use mirror and scale command in AutoCAD. In this video I will tell you about the trim and extend command of AutoCAD. So let's select the trim tool from the modify panel, and here we have this trim tool. You can also expand the flyout and select the trim tool. Now after selecting the trim, simply press enter, and now click on the segment which you want to remove. So in this case we have made all of these objects with rectangle, which is a polyline, and let's now assume that we want to remove some of the segment. For example, we want to remove this segment from this boundary to this boundary. So now when I move my cursor on this segment, the transparency of this segment increases and it becomes dull, and also a preview is shown that shows the part which will be trimmed. So let's click and the part is trimmed. Now let's move to this part, and here also it will be trimmed from this boundary to this boundary. In a similar way, you can click on any part of this geometry. For example, if you click here, it will trim this object from this boundary to this corner. And similarly, you can trim this part, and you can keep on trimming as long as there is a boundary. Now here also you can click here, and that will trim the geometry from this corner to this corner. Now let's press escape key, and this trim tool is helpful not only for trimming these line segments, but it can trim arcs, circles and other geometries also. So basically all of the geometries can be trimmed using the trim tool. So now let's press Ctrl Z a couple of times to get the original geometry here. So now let's select the trim tool and let's look at other method of trimming the objects. So now I'll select the trim, and once again I'll simply press enter. Now after pressing enter, look at the command line, and it now prompts you to select from multiple options. So let's select fence. In the previous case we have not selected any of these options, but in this case I'll select the fence option. And now using the fence option, you can create fences, and all the parts which are crossed by the fence will be trimmed. For example, you can see that the line segment is crossing that fence, so it has been trimmed. This part is also trimmed, so let's now click here. Let's trim this one also. Let's trim this fence, and let's trim this one, and let's trim this one. So now you can see that all the line segments which are crossed by this fence are trimmed. Simply press enter to apply the change, and here we have it. So all of those segments are now trimmed. So let's press escape key, and let's press Ctrl Z to get back the original geometry. Now let's go to the trim tool again, and now don't press enter. So in the previous cases we have directly pressed enter, and by pressing enter we have selected all of the objects in the drawing area, and by selecting the objects we were essentially allowing the trim tool to trim objects with the very next boundary. But in this case we can select the boundaries which will be selected for trimming. So let's assume that we want to trim our objects only with respect to this red boundary. So I'll select this red object and now press enter. Now when you click on the objects, it will only be trimmed up to the red boundary. So here we have this white rectangle. So let's now click on this portion here, and now you'll notice that the complete portion will be removed which is outside this red rectangle. Similarly, if you click on this one, the complete portion which is outside this rectangle is removed. If you select the green rectangle, the complete portion which is inside this red rectangle is removed, and if you select this yellow one, there will not be any change because it's completely inside. It's not touching the boundary here of this red rectangle. But in this case it will be trimmed, in this case it will not be trimmed. Now in this case you can see that we don't have any boundary, any object outside this red box, and that is why it's a single segment and that cannot be trimmed. So let's now press escape key, and let's press Ctrl Z a couple of times to get back the original geometry. In trim tool you can trim any object as long as there is a boundary. So if you create an object, let's say that we create this 3-point arc somewhere inside this object here, just like this, and we want to trim this object. So this will only be trimmed if a next boundary is found. So let's select the trim tool, press enter, and now I'll click somewhere inside this geometry and I'll click this part, and the part has been removed. Now let's click on this part and let's click on this part. Now if you click on this part, it won't be trimmed because there is no boundary after that. So we have this one as the last boundary. After that we don't have any boundary. Now let's click on this part here, and now we have these two segments here. So let's now click on this part here, and now this is once again a completely single segment with no boundary. So here we have a boundary but we don't have any object on this side. Here we also have a boundary but we don't have any object. So this is a single segment and it won't be trimmed. Similarly, for all the remaining segments also the same rule applies. So let's press escape key and Control Z a couple of times. The extend tool is completely opposite of this trim tool and it will extend the geometries to the next boundary. So for selecting the extend tool, I'll make a line here just like this, and also I'll make a 3-point arc. Now go to this flyout and select the extend tool. Now once again press enter and that will select all the objects in the drawing area, and wherever the next boundary is found the object will be extended. So in this case I'll click on this line and you'll notice that it will be extended up to the next boundary, which is the arc here. And now I'll click here. Once again it's extended to next boundary, to next boundary, and to next boundary, and the same system will follow. If you select on this arc, it will also extend to the next boundary, but if you click on it now, there will not be any change because it cannot extend and it cannot make a complete circle. Now let's press escape and Control Z once again. Now let's say that in this case also we want to select a particular boundary for the extend tool. We can do that. So I'll select the extend tool again and now I'll select this yellow boundary and press enter. Now click on this line and you'll notice that it will bypass all the extra geometries which are present before this yellow rectangle. So it will directly extend the object up to this yellow object and it will bypass these three geometries. Now if you click on this again, it will extend it up to the next boundary of this yellow rectangle and it will bypass both of these objects. So by making a selection for extend, you can create extended geometries which behave in a particular way. So let's press escape key and Control Z a couple of times. The trim and extend tool can be used using a single command also. So in the previous case we saw that we can toggle this trim and extend tool from the flyout, but you can select the trim tool and use it for extending the object. So right now you can see that I've selected the trim tool, but now I'll press enter and now I'll simply press and hold my shift key. So pressing and holding the shift key will change the command to its next counterpart, and now I'll click on this line segment and now you can see that it's extending it even though we have the trim command active, and the similar condition will apply on the extend tool as well. So let's press escape key and get back to the original geometry, and I'll also erase both of these objects. So this was all about the trim and extend tool of AutoCAD. In this video I will tell you about erase, explode and overkill command of AutoCAD. So here we have these two geometries. In the first case we have this as a block, and we'll learn about blocks later on in this course, but for now just assume that a block is a single entity here and it is made up of many different drawing objects which we have seen so far. We have this arc here, we have the line segment, and all of these objects combine together to make a single block. But in this case we have this object made up of simple object. In this case we have this rectangle, we have these line segments and an arc, so they are completely separate from each other. Now if you want to break any object and if you want to convert it into its simplest form, then you can use the explode tool. In this case we have this block, and when you click on this block we'll find that here we have a single grip and it's completely behaving as a single object. In order to break it into different parts, simply select the explode tool, and here we have this explode tool. Select the explode tool, click on the object and press enter, and now move to this object and you'll notice that now it has been reduced to its separate units. We can now select all of these objects separately even though it was a block initially. In a similar way, if you click on this rectangle, you'll find that it's completely a single polyline and it has 4 different line segments, but you can also explode this geometry to reduce it into its simplest form. So once again select the explode tool, click on this rectangle and press enter. And now when you click on this object, you'll notice that it's a single line segment, and similarly all the objects have been broken down into their simplest segments. In order to erase any of these objects, you can select the erase tool from the modify panel and then select the complete set of objects and press enter. So that will erase the objects. Or you can also use the alternate method, which is selecting the objects and pressing the delete key on your keyboard. There is also one more method, and that's simply selecting the object and deleting it from the right contextual menu. So you can select any of these options for erasing an object. When making any drawing, there will be conditions when you'll make some overlapping geometries. For example, in this case we have the simple geometry which is made with single segments everywhere. But what if we need to make some overlapping geometries? For example, I've selected the line tool and now I've clicked at this point, and now I need to take reference of that point, so that's why I click there. And now from that point I need to select a distance of, let's say, 60 units. So I'll type 60, press enter, and now I need to move upwards and I need to enter a distance of 150 units, press enter, and now I need to join it with this point. So now in this case, you know that we have an overlapping line here which is above this line, and in a similar way there may be situations where you need to create many overlapping geometries. So you can manually remove those overlapping geometries, but that will take time. But there is a direct method in AutoCAD that can be used to remove all the overlapping geometries, and that's overkill. So go to the modify panel, expand it, and select this overkill option. You can also use its command equivalent, which is overkill, and then select the complete set of objects and press enter. Now don't change anything in this window, simply click OK, and now we don't have any overlapping object here. So now if you click here, you'll see that we only have a single line. And similarly, if there would have been any object which are overlapping any other object in this drawing, that would also have been removed. So this was all about erase, explode and overkill command of AutoCAD. In this video, I will tell you about the stretch command of AutoCAD, and using the stretch tool, you can change the shape of geometries in very particular ways. For example, in this case, we have this bathtub, and let's say that we want to increase the length of this bathtub. For that, we can use the stretch tool. So select the stretch tool from the modify panel, and now select the objects. But in this case you need to select objects in a very specific way, and if you expand this command line, you'll notice that it's also prompting you to select it with only crossing window or crossing polygon. So now in order to make a crossing window, I'll click on the right side and I'll move my cursor towards left, just like this, and here we have this crossing window with dashed boundaries. Now in this case also, I'm not selecting the complete bathtub, instead I'm selecting it only partially. Now all the objects which are completely inside this crossing window will remain unaffected, and all the objects which are completely outside this stretch window will also remain unaffected. So in this case, this line segment, this complete arc, and this line segment, this part of geometry will remain completely unaffected, but the length of these four lines will change, because in this case only these four lines are partially inside and partially outside. So now simply click at any point to make this stretch window and press enter. Now click anywhere and click on any side where you want to stretch it. So in this case you can see that the length of only those four line segments which were partially inside and partially outside our window is changing, and rest of the geometry is completely unchanged. So you can decrease or increase the length here, just like this. Now similarly, if you want to change the geometry here also, you can do that. So I'll once again select the stretch tool, and now in this case let's assume that we want to increase the height of this panel here, and we want to keep this panel unchanged. So for that we need to make this stretching window in a specific way, just like this. Now in this case we have these 6 line segments which are crossing this crossing window, and they are partially inside and partially outside. Rest of the geometry will remain completely unchanged. So let's click, press enter, click at a point, and now move upwards, and you'll notice that only the 6 line segments which were partially inside and partially outside have changed their length, and rest of the geometry remain completely unchanged. Now let's assume that we want to change its length even further, and we want to increase its length in horizontal direction. For that I'll select this stretch tool, click at a point here, make this window like this, and obviously now you understand that which part will be affected. So in this case, all of these segments are partially inside and partially outside, so only the length of these segments will change. So now press enter, click at a point and stretch it just like this. So in this way we can use a stretch tool in AutoCAD to change the shape of geometries or stretch them in a particular way. In this video, I will tell you about break and join command of AutoCAD. So I'll start with the break tool, and you can find the break tool in the expanded modify panel. So select that arrow to expand the modify panel, and here you will find this, the break tool and break at a point tool. So we have these two break tools. So I'll select the break at a point tool in the first case, and now using this tool you can break any object in two different parts. So in this case we have this line segment, which is completely a single segment. As you can see that when I hover my cursor over this object, the complete segment is selected. Now let's say that we want to break it in two different parts from its midpoint. So for that I'll select the object and now specify the first breakpoint as mentioned on the command line. So let's now click on this midpoint, and now the object is broken into two different parts. So let's select it, and now you'll notice that we have this as a separate segment, and you can obviously move it. So using the break tool you can break any segment in two different parts. Now let's say that we also want to create a gap in between these segments just like this. So for that I'll press Ctrl Z so that the object now combines into a single segment, and I'll select the break tool once again. So in this case, instead of selecting the break at a point tool, I'll select this normal break tool, and now once again select the object. And now don't select the second point. The command line is obviously prompting you to select the second breakpoint, but don't select it. Click on this first point option and now specify the first point. So I'll select this one, the point somewhere around this, as the first point, and now I'll select second point somewhere around here. And now you can see that the object has been broken into two parts, and also there is a gap. So let's now press Ctrl Z to get back to the original geometry, and I'll select the break tool once again. So let's select the break tool, and now in this case I'll once again select the object, but in this case you need to select the object in a specific way. So let's say that we want to break this object in such a way that the gap is created of this length. So the gap should be equal to this length which we have here, approximately equal to this one. So for that select this object, but make sure that you click at a point which is close to this point. So I'll click somewhere over here, and by this click the object is selected and also the first point is assigned here. Now you simply need to select the second breakpoint as mentioned on the command line. So now you need to click close to this point. So let's now track it and click here, and here we have it. So in this way you can create the gap of approximately same size on this segment. So I'll press Ctrl Z again, and now I'll select the break tool for this circle. So once again expand it, select the break tool and select the object here. Now we want to break a single quadrant here, and for that I'll select the first point and now click at this quadrant point and then click at this quadrant point. Now you can see that this quadrant is removed. So in this way you can use break tool to remove some of the segments from the circle, line or any other geometry. The opposite of this break tool is obviously the join tool, and using the join tool you can join broken objects into a single entity. So first I'll press Ctrl Z to return this object to its normal shape, and now I'll expand this modify panel and select the join tool. So here we have this join tool. Now select it, and now here we have a gap. In order to fill this gap we can select the join tool. So click on this point here close to this gap and click on this line segment close to the gap and simply press enter. And now the gap has been filled and also the object is joined as a single entity. But in this case the objects need to be collinear, or they should be on a single line. If the objects were not collinear, the join tool will not work. For example, if I move it a little bit upwards and then I'll try to join it, it won't join the objects. And as you can see that it failed to join these objects. Now for these situations we have a different tool. If you want to blend this gap, you can use the blend curves. So here we have this blend curves. Select the blend curves and now click close to this endpoint and click close to this point, and the gap has been filled with a spline about which we have already learned. So in this way you can fill the gap using the blend tool. So let's press Ctrl Z a couple of times and let's look at this geometry. So now in this case we have this object as completely separate unit. So we have these line segments and we also have this arc here. So all of these objects are completely separate. Now if you want to join them into a single unit, you can do that with the join tool. So once again, expand the modify panel, select the join tool. Now select complete set of objects and press enter. Now click on this object and you'll notice that the complete object is converted into a polyline and it's acting as a single unit. So using join tool, you can join objects which are already connected from end to end. And this was all about the break and join tool of AutoCAD. In this video, I will tell you about the fillet and chamfer tool of AutoCAD. So using the fillet tool, you can add rounded corners on the sharp edges, and using the chamfer tool, you can add a straight line at the vertices or sharp corners. So I'll start with this geometry here. And now go to the modify panel and select the fillet tool from this flyout. So here we have this fillet tool. Now expand the command line and you will be able to see the current settings of the fillet. So currently the mode has been set as trim mode and the radius is set to 0. So obviously we cannot make a fillet with 0 radius. So we need to change the radius first. So click on the radius option and now change the radius. So I'll type 1 as the radius for this fillet and press enter. Now look at the command line. It prompts you to specify the first object. So click on this line segment and that will be the first object. Now click on the second one and the fillet will be applied automatically. And as soon as the fillet is applied, the command will also end. Now if you want to repeat the fillet tool, simply press enter and you'll notice that the last settings are applied. So in this case the radius is 1 and the mode is trim mode. So you can again apply the next fillet simply by clicking on the two line segments. After applying the fillet, the command automatically exits, and if you don't want the command to exit automatically, you can select the multiple tool. So once again I'll press Ctrl Z a couple of times to return back to the original object, and now select this fillet tool. Now I'll select radius and change it to 1. Now here we have an option which is multiple option. So let's select this multiple option. And now select the first segment and second segment, and now you can see that the command is still active. So using the multiple option, you can create fillets on multiple edges without repeating the command again and again. So let's press escape key and press Ctrl Z. Now there is also a direct method of applying fillets on this kind of geometry. So in this case, if you click on any of the segments, you will notice that the complete geometry is selected. So this complete rectangle is made with a single segment. If you find this kind of geometry, you can apply fillet on all of these edges directly using single click. So for that, I'll once again select the fillet tool and I'll go to radius, select the radius of 1 unit, press enter, and now select the polyline tool. So in this case we know that our object is a polyline and it is completely connected. So select the polyline tool, click on the object, and the fillet will be applied on all of these 4 vertices. So let's press Ctrl Z to return back to the normal geometry. Up to this point we have seen that after applying the fillet, the extra portion is automatically chipped off. It's automatically removed. Now if you want to keep that extra portion, for example in this case, let's apply the fillet first. So I'll select the fillet tool, select the radius, select 1 as radius, and I apply fillet on this corner. Now the extra portion has been removed. Now what if you want to keep that extra portion also? For that you need to change the trim mode. So select the fillet, and here we have this mode as trim. So obviously we need to change this mode, and for changing this, click on this trim option and change it to no trim, and now apply the fillet. So I'll select this line segment and this line segment, and here we have it. The fillet has been applied, but this extra portion is also retained because we have changed the mode. And now you can apply the fillet by retaining the extra portion or the extra segment here. So obviously we do want to select the trim mode. We don't want this mode, so I'll go to this fillet option, click on this trim option, change it to trim mode. And now if I apply the fillet, it will remove the extra geometry. Now let's look at this condition here. Now in this case, both of these objects are not joining each other, but when we extend them somewhere, they connect each other. Now you can apply fillet on these objects as well. So select the fillet tool and now select the radius option. And in this case, let's select a radius of 2 units and press enter. Now select the first object, select the second object, and we have the fillet here. So obviously the fillet is applied and the extra part of this line segment is also removed. Now press Ctrl Z, select the fillet tool, and in this case let's change the radius to 0 and press enter. And let's try to apply the fillet here. So I'll select the first line segment and the second one, and in this case you'll notice that the objects will connect at their apparent point of intersection. So here the radius has been set to 0, and by setting the radius to 0 you can extend the objects to intersect at their apparent point of intersection. So you can do that with fillet tool. Now all of these things can also be done for chamfer tool. So I'll press Ctrl Z a couple of times to get back the original geometry, which is this one, and I'll start the chamfer tool from the first rectangle here. So once again, go to the flyout, select the chamfer tool, and now look at this mode here. So we have this trim mode obviously, but we have the chamfer distance as 0 for distance 1 and distance 2. So we need to change these parameters. So select the distance option and enter 1 as the first distance, and now enter 2 as second distance. And now I'll click on this line segment first, and then I'll click on this line segment as second distance. And now this chamfer has been applied. So in this case we have applied the first chamfer distance as 1 unit, which will be this distance, the distance between this endpoint and the original vertex. The second chamfer distance was 2 units, which is the distance between the vertex and this endpoint. So the first and second distance is selected based on the point on which we click. So in this case I clicked on this line segment first, so that became the first distance, and I clicked on this line segment, so that became the second distance. Now here we have the normal geometry. So in this case also, if you want to apply chamfer on all of these vertices, you can use the polyline option. So select the chamfer tool and select the distance, and I'll select 1 as the chamfer distance for first distance and also 1 for second distance. So in this case we will have a completely uniform chamfer, and in this case also we have a multiple option. So using multiple option you can repeat the command, and the chamfer command will not exit even after making a chamfer. And you can select the polyline option if you want to apply the chamfer on all of these vertices at once. So simply click here and the chamfer has been applied on all of these vertices directly. In this case also you can change the trim mode to retain the extra segment, and in this case also you can apply chamfer on this kind of geometry. So I'll select the chamfer tool and I'll select the distances here, and now I'll apply it in between these two segments. And here we have it, the distance 1 applied in between these two segments. So this was all about fillet and chamfer tool of AutoCAD. In this video I will tell you about the lengthen and reverse tools of AutoCAD. So here we have these 3 simple geometries, and we'll start with the lengthen tool here. So you can use lengthen tool to find out the length of different objects in the AutoCAD drawing, and you can also use it to increase the existing length of the objects. For example, here we have a line and an arc. Now using the lengthen tool we can increase their length, and here also we can increase the length of this arc or the circumference of this arc, so that will affect the included angle. So to start the lengthen tool, expand the modify panel and select the lengthen tool from here. Now select it and click on the object whose length you want to find. So in this case I'll click on this line, and here we have the length of line, which is 100 units. Now let's assume that we want to find the length or the circumference of this arc, so click on it and we have the circumference of the arc along with the included angle. So in this way you can use this tool to find the length of different geometries. Now using this tool you can also increase its length. So as you know that the length of this line is 100 unit, as shown here. Let's say that we want to change its length to 120 units. For that, I will select this delta option first. Now using delta option, you can change the length to any value. So here we want to change its length by 20 units. So type 20, press enter. Now click on the side on which you want to increase the length. So I'll click close to this endpoint and the length will increase by 20 units towards right side. You can now also click on this left side to increase it by 20 units here, and you can keep on clicking if you want to increase length even further. Now let's press enter to exit this command. Now I'll press enter again to repeat the command, and now once again I'll change the length of this arc. So in the previous case we have changed the length of this line, now we'll change the length of this arc, but in this case instead of using the delta option I'll select the percent option. So let's select this percent option. Now using the percent option you can also change the length of existing objects, and for that you can enter a value which is greater than 100 and also less than 100. So if you enter a value which is less than 100, for example 80, that will decrease the length, and it will decrease the length by 20%. And if you enter a value like 120%, it will increase the length of the existing object by 20%. So obviously entering a value of 100% will not make any change. So in this case I'll enter a value of 70% and now press enter. Now click on the side of arc from where you want to decrease the length, and here we want to decrease it. So you can see that the length will be reduced. So let's click, and the length has been reduced to 70% of its original value. Again press enter to exit this command. Now you can also press enter to repeat it, and now we have a total length option here. So let's select this total length, and now you can enter a total length for the object. So in this case we know that the length of this line is now 140 units because we have increased the length by 20 units towards right and left side. Now let's say that we want to decrease its length and we want to make it equal to 60 units. So I'll type 60 as the total length. Now press enter, and now click on the side from where you want to decrease it. So if you click on the right side, the length will be decreased from this side. If you click on the left side, the length will be decreased from there. So I'll click on this left side. And now here we have the line with a length of 60 units. You can also check it using the lengthen command. So again press enter and click on this line, and here we have this 60 unit length. If you want to change the length of this line now or the length of this arc dynamically by using your cursor, then you can select this dynamic option, and now you can click on the line and you can move your cursor to change the value. Similarly, you can also click here and change the length of this arc just like this. So now let's erase both of these geometries. So now let's have a look at the reverse tool. So using reverse tool you can reverse the direction and also orientation of the object. So here we have a polyline, and in this polyline we have this starting width of 0 unit and an ending width of 10 unit. Now let's say that we want to reverse its direction. For that we need to expand the modify panel and select the reverse tool. So select it. Now select the object and press enter. Now although you may not see the change in direction, but when you look on the command line, just let's expand it, you'll see that the object direction has been reversed. So obviously the object direction has been reversed, but we are not able to see any change here in this polyline because it has not reversed the order in which the polyline has been made. And in order to apply the change on the order of this polyline, you need to change p line reverse width system variable to 1. So let's type p line reverse widths and press enter. So now you can see that its default value is set to 0. Let's change it to 1 and press enter. Now we'll repeat the command. So let's go to this modify, select the reverse tool, select the polyline and press enter. And now the direction has been reversed and also the orientation has been reversed in this case. This reverse direction tool is especially helpful for this kind of cases, and it's also helpful in the situations where you have a line type containing text and when the direction of text is not appropriate or not according to your requirements. So you can use this tool to reverse the direction of polyline or reverse the direction of line type to make it appropriate as per your requirement. So let's now once again change the system variable back to 0. And let's erase this object as well. So this was all about lengthen and reverse tool of AutoCAD. Okay, so now we have completed this module. Now we need to make this drawing using all of the commands and tools which are taught up to this point. I'll start with the polygon tool, and here on the draw panel expand this flyout and select the polygon. Now we need to select 3 sides because we want to make a triangle, so select 3 and press enter. Now we don't need to specify any center point, rather we need to specify the edge length, so select edge and click at any point and then the next point. The next point will be of 9 unit length, so type 9 and press enter. So there we have it, the triangle. Now we need to start with the circle tool, so go to circle, click on this point here and make a circle with radius of 3 unit and press enter. Now press enter again to repeat it, and now click on this point and enter a circle of radius 2 unit and press enter. Now you can make another circle at this point or you can copy the existing circle. So I'll select copy, select the circle, press enter, click on the midpoint and move it on this one. Now press enter or cancel. Now we need to join both of these circles with the help of a circle which is tangent on both of them, and we can do that using tangent radius because the radius is also provided here. So go to the flyout and select tangent radius. Now click at the approximate points where they are touching, the first and the second point, and enter radius of 3 unit and press enter. There we have it. Now we can repeat this command and we can do it here also, or we can make a mirror image. So I'll make the mirror image, but before that I'll trim this. So I'll go to trim, press enter and now trim this portion. Now we can make the mirror image of this small arc. So select it, click on mirror, now click on this center point or the end point of triangle and join it with this midpoint and press enter. So now it is joined. Now for this side we need to join it with a straight line. So I'll go to line tool, I'll go to this quadrant and I'll join it with this quadrant and press enter. Now we only need to trim all the extra portions. So the first thing is this triangle which we need to delete. So I'll delete it and I'll go to trim, press enter, trim this and these two portions. There we have it, the final drawing as per our requirement. So in this module we'll start looking at the options of this status bar, and we'll start with the first two options, which is grid and the snap mode. So here in this drawing area you'll notice that by default it's completely blank, or in your case it may have a grid, and we have the UCS and the normal objects here. Now you can also add grid if it is not present in your drawing area directly by clicking this first icon, which is grid mode. You can also turn it on by pressing the F7 key on your keyboard. So here we have a grid which is mostly like a graph paper. So you can zoom in and zoom out to see its individual blocks, and now here we have these individual blocks. Now currently there are 5 blocks in horizontal and 5 blocks in vertical direction, and after every 5 block there is a major line in both the directions. Now these grids are helpful in creating lines and other drawings in AutoCAD, but you can also change the settings of these grids. So in order to change its setting, simply right click on the grid mode and select this grid settings. So now on this drafting settings window we have lots of options. We'll simply select this grid spacing option. So currently you can see that the grid X spacing is set to 10 unit. That means the single box or the single grid here has a length of 10 unit in X direction, and also in Y direction it is 10 unit. Now here we have this major line every 5 blocks. So that simply means that after every 5 block in both the direction we have this major line. Now if you want to change these settings you can do that, so we'll change it for now. So I'll change the grid X spacing to 1, and also the grid Y spacing will change to 1. Now we want major line after every 10 blocks, so we'll change it to 10. And now let's click on OK. So the settings of this grid has completely changed, and now if you'll zoom in you'll find that here we have these new settings. So now we have each block with length of 1 unit in horizontal and 1 unit in vertical direction, and also after every 10 block we have these major lines. Now there is one more option, which is this is snap mode. So you can turn it on by pressing the F9 key, the function 9 key on your keyboard, and by using this snap mode you can snap at particular points on this grid. So we will once again change the settings for this snap mode as well. So I'll just click on it to turn it on, and now right click and select this snap settings. So now here we have the settings related to the snap, and in order to have a uniform value for snap and grid, we need to change the values for both of these properties. So in this case we have changed the X spacing to 1, and in this case it's set to 10. So let's now change it to 1 in this case also. Press tab key and the Y spacing will also change to 1. We'll see what this means in a moment. So now change these values and click on OK. Now select any command. For this case I'll select the line, and now you'll notice that our cursor behaves in a very random way. So even though I'm moving my cursor uniformly in the drawing area, it will only snap to the intersection of grid lines, as you can see here, and after every one grid line the cursor will snap because we have changed its value in that way. Now let's say that we want this cursor to snap after every 2 grid lines or after every 2 grid blocks. So we can right click, go to snap settings and change it to 2, and now click on OK. And now after every 2 blocks you can see that it's snapping in horizontal as well as in vertical direction. So in this way you can change these values. Now how are these helpful? So first let's change it to 1 so that it has a uniform value. And now we'll make a simple geometry. So I'll make a simple rectangle in this case with a length of 10 and width of 5 units. So I'll click on this point, and we don't need to be concerned about the point because it's exactly clicking at the intersection of the grid lines. So now click here, that will be the 10 length, and also we have this 5 length, the 10 length and 5, and now press enter. So we can easily make this kind of geometry directly taking the reference of these grid lines or the background grids here. So it's quite helpful in making these kind of geometries. But for most of the cases I keep these settings off, and I also keep the grid off, and I prefer to work without these grids. But it's completely up to you how you use these grids. So that was all about the grid and the snap mode settings. In this video I will tell you about the polar and ortho mode of AutoCAD. So on the status bar you'll see here this ortho mode, and you can turn this ortho mode on by pressing the F8 key on the keyboard. So let's click on this ortho mode, and when you click on this ortho mode you'll notice that the polar tracking will automatically turn off. So for now we'll just keep this ortho mode on, and now let's go to the line tool and click at a point to start the line, and we have a completely horizontal line here. Now even if I move my cursor way beyond that horizontal line, it is still remains horizontal. Even if I move it to this direction, it will remain horizontal. Now if I move it close to this point, it will become vertical. So as long as ortho mode is on, the lines will always remain either horizontal or vertical. But you can obviously snap to any existing point. For example, if you move your cursor close to this point, the end point, it will snap to that point. But as long as there is an absence of snap point, it will always make your geometry in either horizontal or vertical direction. So using this ortho mode you can make these geometries quite easily. Now let's erase it, and let's now turn on this polar tracking option. So you can obviously use F10 function key to turn it on, and as soon as you turn it on, the ortho mode will be off. Now using this polar tracking you can create your geometries in any direction. So here also I've started the line, and I can create it in horizontal direction, and also I can create it in any direction. But there is a slight advantage in this case. In this case, when you move your cursor to the 0-degree angle, you'll see this tracking vector. Now this will help you in creating a completely horizontal line, because in the absence of this tracking vector you won't be able to, or at least it will be very difficult for you to make a completely horizontal or vertical line. So let's now turn it off, and now let's try to make a completely horizontal line, and now you won't be able to make a completely horizontal line, or even if you will be able to make it, it will take some time. So this Polar tracking will help you in making lines inclined to particular angles, not only in horizontal and vertical direction. So now let's turn it on, and now here we again have the tracking vector. So in this case you can see that the tracking vector is only in this horizontal or in this vertical direction. Even if you move to any direction, we have it after the interval of 90 degrees, but you can change that. So let's say that we want this tracking vector to appear after an interval of 30 degrees. So for that, click on this small arrow right beside this polar tracking and change it to 30. And here we have this 60, 90, 120, 150 and so on. So let's click here. And now we have the first angle at 0, then the second tracking vector at 30, then at 60, 90 and so on. So after every 30 degrees we have this tracking vector, and that will make the drawing workflow very easy, and you will be able to directly snap to those angles easily using this polar tracking tool. So when you go to this polar tracking, you'll see that you'll have lots of other options also. For example, the 45-degree multiples, the multiples of 23 and 18, 15, 10 and 5. So these are more than sufficient for your requirement. But if you want to add any custom angle, for example, let's say that we want to add an angle of 17.5 degrees, so that also you can do. So for that, click on this tracking settings, and now here click on this additional angles, click on new and add the additional angle. So we need to add 17.5. Now press enter and our new angle is added. So let's now click on OK, and now click on this arrow again, and you'll see that here we have this 18, 36, 54 and 72 angle. Although currently you won't be able to see the exact 17.5 degrees because precision of angle is set to 0, and we need to change that precision value in order to see the decimal points. So I'll just change that value. So for that I'll press escape key and I'll type UN for units. And we have already seen this drawing units window. From here you can see that the precision for angle is set to 0. Let's change it to 2 decimal places. Click on OK. Now let's look at the angle value, and here we have the 17.5, 35 and its next multiples. So once again I'll go to this line tool, click on any point, and from here I'll make sure that this option is selected, and now after every 17.5 degrees we have this tracking vector. So let's make a line to an angle of 52.5 degrees and press enter. Now if you want to remove that value, you can again go to this tracking settings, and from here select the value, click on delete and now click on OK. So in this way you can use ortho mode and also the polar tracking to make your drawings according to your requirement. I prefer to keep this polar tracking on, and I only keep ortho mode on in specific cases. So once again I'll remove these geometries, and that was all about the ortho mode and polar tracking status bar options of AutoCAD. In this video I will tell you about dynamic input status bar option. So up to this point we have been using command line for entering all of our inputs, whether it's the distance, angle or the coordinates. But there is an alternate method of doing this, and you can do that using the dynamic input, which is simply a small command line on your cursor. So here we have this dynamic input option on the command line, and you can activate it by clicking on this option, or you can also use a din mode system variable. So you can change the value of this din mode system variable to 1 in order to make it active. Now once this is active, go to any command and now click, and now you'll find a slight difference. Now we have this cursor, and along with the cursor we have the command line input here. So the same input which is on command line can now be seen directly on the cursor, and along with that we have a dynamic coordinate here. So you can see that this coordinate display changes according to the movement of cursor. Now let's click at any point in the drawing area, and now the cursor again changed and it's now reflecting a new value here. So now wherever possible the cursor will show this distance value and also the angle value, and as far as possible it will show other values also, for example radius or the arc length depending upon the geometry. So now let's say that in this case we want to make a line with length of 100 unit incline to an angle of, let's say, 45 degrees. So for that, simply type 100, and now you'll notice that that value will be entered on the line field. Now simply press tab key and the distance will be logged and the input field will jump to this angle value. Now enter the angle, which is 45, and press tab again. And here we have it. So now the geometry is logged to a distance of 100 unit and also to an angle of 45 degrees. Now press enter and the final geometry is here. So this is a little bit simple method of making the geometries, which you can use obviously, and depending upon the geometry or your preferences, you can either prefer this method or the direct command input from the command line. So I'll now press escape key and I'll look at other options which are available with this dynamic input. So let's now move this geometry here, and now I'll go to this polyline. Now I'll click at any point in the drawing area and look at the command line. So on the command line we have some other sub commands or some extra options which are related with this commands. For example, arc, half width, length, undo and width. Now these options are also available on the dynamic input, and you can access these information or these options simply by pressing this down pointing arrow. So click on this down pointing arrow as mentioned on this tooltip also here. So click on it, and now all those options are available as a list. Now you can simply keep pressing that down pointing arrow, or you can also press the up arrow and choose the desired value. So I'll select this width option and now press enter. Now let's change the starting width to 10 unit and the end width to 10 unit again. Press enter. And here we have it. So now you can see that we can apply the same value directly from the command line. So once again, let's change the width to 0. I'll select the width value, enter 0 as the starting width and ending width also as 0 and press enter, and we have the normal polyline here. So let's now join it with the starting point and press enter. When making drawings with this dynamic input, there might be situations when this would create a little bit of distraction for you. For example, in this case, let's say that we want to make a circle at this point, but we don't want this dynamic display to be visible at this drawing area. So you can hide it also temporarily by using the F12 function key. So press the F12 function key while your command is active, and that option will hide temporarily. And now you can enter the values if you want, or you can again release the F12 key and enter the value. For example, here I'll enter 60 as the radius, and here we have the final geometry. So in this way you can use the dynamic input option for bringing your command line directly on the cursor. So that will decrease your dependency on the command line, but obviously it is not a replacement for your command line. Command line will be required for many other situations also, but you can use it wherever you find it most helpful. So I'll just click on this option once again to turn it off, as I prefer working with the command line only. In this video I will tell you about simple object snap tools. The object snap option comes into picture when you want to make geometries with respect to the existing geometries or their points. For example, here we have these geometries, and now I'll select the line tool, and let's say that I want to start this line from this endpoint somewhere here. So when I move my cursor close to this endpoint, this small endpoint box will appear, and also on the tooltip you'll see that its name will appear here as endpoint. Now even if I don't click on this exact endpoint, the cursor will still snap to that endpoint, and that's because we have this object snap option active. Now you can turn it off by simply pressing the F3 key, and when this option is off there will be no point at all on any of these existing geometries. So now I'll simply click on this to turn it off, and now I'll click anywhere in the drawing area, and now I'll move my cursor close to the next endpoint, and now we don't have any endpoint or any midpoint or any other point here for the reference, and it will be very difficult for us to exactly click at the point. Let's say that I have clicked at this point. Now let's see how accurate I am. So I'll zoom into this area, and absolutely this drawing is not correct. We want to click at this point, but our geometry is here, which is not the correct one. So we need to ensure that object snap is always on to make accurate drawings. So now I'll zoom out, I'll remove these geometries, and now I'll click on this object snap option to turn it on. As I already mentioned, you can also turn it on by pressing the F3 key. Now there are a couple of points which are recognized by this object snap, and you can see all those points in this menu. So click on this small arrow and there will be a list of points, and all of these points are recognized by the object snap. So there are check boxes or check mark in front of some of these icons, and some of the icons are without these check marks. So currently the object snap will only recognize the points which have these check marks, and it's always advisable to keep only the required number of checkboxes active. So don't make all of these checkboxes active, otherwise there will be a conflict of different object snap points. So for now we have this endpoint, midpoint, center, node, quadrant, intersection and extension points active, and currently all of these points can be recognized by the object snap. So let's now go to another line tool, and now I'll move my cursor close to this circle, and here you'll see that we have this quadrant visible. Not only the quadrant, we also have this center point visible. Now all of these points are visible only because object snap is active. So let's turn off this center and I'll repeat the command, and now I don't have any center point here. So obviously after turning it off we won't find that, but still we have the quadrant and all the other points here like endpoint and the midpoint here, which is indicated by this triangle. So you can keep other options active as well here. Now there is one more option here, which is a geometric center. So using this geometric center option, you can snap to the geometric center point of any closed geometry. So here we have a pentagon, and now when I move my cursor close to this point, you'll see that there is a new point here, which is the geometric center. So it's simply the centroid of this geometry, and you can find the geometric center for very irregular kind of geometry also. For example, here I'll make a drawing with polyline and I'll make a very random geometry just like this. Now in this case also you can find the geometric center using that object snap, but the only condition is it should be closed like this and it should be a single unit. Now I'll go to the line tool and move my cursor here, and we have this geometric center here. So in this way you can find the geometric center quite easily using this object snap tool, and you can also see some of the other object snaps like the node, which is simply a point which we have already seen. So you need to make sure that point or node is active in order to snap to it. We have the quadrant option, which is the quadrant of this circle or an arc, and we have the intersection. So intersection is simply the point which is something like this. So in this case we have these two lines intersecting, and if you want to snap to this intersection point, make sure that intersection is active. And now when I select any command and I move close to this intersection point, there will be this intersection object snap. Now let's look at some other options here, and we have the extension here. Now using the extension you can create any line or even an arc in the same direction, or you can extend that geometry. So I'll select the line tool for explaining this, and here we have this polygon. Now let's say that we want to extend this line, and for that I'll just click at any of its endpoints and I'll move my cursor in its direction, and you can see that we have this extension on the tooltip, and also the cursor is moving exactly along the direction of the line. So that's simply extension. You can also use this extension for an arc. For example, I'll select the arc tool here, click on this point, and now let's see here. So we can see that this geometry is extending exactly along the circumference of this arc. You can access these object snap options directly from the right contextual menu as well. So in the situations where there are plenty of object snap points and it becomes a little difficult to select the exact snapping point directly from this object snap menu, then you can use the alternate method, and that's the right contextual menu. For example, here we have this circle. Now let's make a line also in this case. So I'll click at this point, quadrant, and I'll join it with this point. Now in this case we have the midpoint of this line exactly on the center of the circle. So I'll simply move this line a little bit towards left, just like this, and now the center of this point is very much close to the center of this circle. So now I'll go to the line tool and now I'll try to snap to this point, and now if I move my cursor I can only snap to this midpoint. Although I don't want to snap to the midpoint, I actually want the center of this circle. Let's now check whether we have the center active or not. Yes, we don't have it active. Let's make it active. Now move here. Now again we have the midpoint here, although I have turned it on, but still we have the midpoint here. So in these situations you can use the right contextual menu. So for that, simply press and hold the shift key and then right click. Now you'll see all the object snaps on this list. From here, select the object snap which you want to choose. For example, in this case I want center, and simply go to that point, close to that point, and it will snap only to that point, ignoring all other points. So in this case I am now able to snap to the center, and here we have the geometry. In the previous video we have seen some of the basic object snap points, and in this video we'll explore some of the advanced and typical object snap points. Now here we have this object snap active, and if it is not active you can click on this status bar option to turn it on, and we have the list here. You can also turn it on by pressing the F3 key. So now in this list we have seen up to the extension snap points. Now we have this insertion point, which is simply the base point of our blocks and the external references, and that we'll see later on in this course. We have the perpendicular object snap. Now for accessing rest of these options I will not select this menu, instead I'll select it from the right contextual menu. So let's look at the perpendicular tangent options now. So I'll select the line tool for this, and now click anywhere in the drawing area to start this line. Now let's assume that I want to make this line exactly perpendicular on this line, but I don't know the point where it will be perpendicular. So in order to find that point, simply press and hold shift key, then right click and select the perpendicular option. Now move your cursor on this line, and here we have it. So click here, press enter, and now this line is perpendicular to this line. So in this way you can use the perpendicular object snap. Obviously you can use this perpendicular object snap also from this menu if you want. Now we have the next one, tangent. So here in this case, let's say that we want to make a line which is tangent on this circle or on this arc and also on this circle. So we want to make a single line which is tangent on both of these geometries. For that I'll select the line tool. Now I'll press and hold shift key, then right click and select the tangent, and now click anywhere on this circle. So here we have this line. Now once again press and hold shift key, then right click, select the tangent. Now click on this circle, and here we have it. So we have a single tangential line which is tangent on this and this geometry. Similarly, let's assume that we want to make a line which is parallel to any existing geometry. So in this case I'll erase these two geometries and also this one, and now we want to make a line which is parallel to this one, starting somewhere from inside this polygon. For that I'll select the line tool. Now click at the midpoint here, or let's say that we don't want to click at the midpoint, we'll click at some other point randomly somewhere here. Okay, now we don't know the exact direction of the parallel line, so we want to make this line exactly parallel to this one, and for that I'll select the parallel object snap. So press and hold shift key, right click, select the parallel. Now we want to make it parallel to this line, so go to this line but don't click, and now move back your cursor. So when you move it back, you will see this small plus sign, the green plus sign, that indicates that a reference has been taken from this line. Now move your cursor, and when the line becomes parallel, this green tracking vector will appear. Now you can click anywhere to make this parallel line, or you can also enter the distance. So let's say that we want to make it of length 50 units, so I'll type 50, press enter and enter again, and we have this line exactly parallel to this one. So we have some other options also, let's see that also. So here we have this nearest option, which should be turned off in most of the cases, and the nearest option is helpful if you want to click at any point on the curve. For example, in this case we have an arc, and on this arc we have some well-known points like the quadrant and the center. But what if you want to click somewhere in between the quadrants? For that you can select the nearest option. So obviously I'll select the line or any other tool here for now. Now shift and right click, select the nearest option, and now move your cursor and you'll see this nearest marker, so that will follow your cursor, and on this curve you can click anywhere and it will exactly snap to this geometry. Now click here and the geometry has been made, and the end point of this line always lies on the circumference of this arc. So in this way you can select object snap points to snap to any point in the geometry, and if you want to track your existing snap points you need to ensure that this object snap tracking is on. So for now we have this option off, and now I'll select this line tool, and now let's say that we want to make a line by taking the reference of any existing object snap points. For example, here we have this endpoint. Now we want to make a line which is somewhere over here but which is along this line in the horizontal direction. But now when I try to take reference of this endpoint, I don't have any reference here. I'm not able to make any line exactly in this direction unless I make a line here. So if you want to take reference of this, simply click on this object snap tracking, move back to this point, and now move in this direction and you'll have this tracking vector. So that will take reference of the existing object snap. So you need to ensure that object snap tracking is on if you want to take its reference. Now here also I'll press enter again. I'll go to this midpoint or the center, but I'll not click, and here we have the reference. You can click here, you can take the reference in vertical direction or in any other direction. So always make sure that this object snap tracking is on whenever you want to take reference of the object snaps, and you can turn it on by pressing the function 11 key on your keyboard as well. So let's move back to the drawing area and press escape key. In this video I will tell you about the from snap option, and this from snap option may look a little bit intimidating to you in the beginning, but with practice you can use it in a variety of situations and it will really be helpful in improving your productivity. So here we have a simple geometry. Now in this case the length of this drawing is 10 units, the height is 10 units, we have this of 5 unit, 5 unit, and the remaining length of this slant line. Now let's assume that we want to make a circle somewhere over here and we want to take the center of this circle in a predefined way. Now we want the center of this circle to be exactly at a distance of 10 units from the midpoint of this line, and that line, the 10 unit line, should be inclined to an angle of 30 degrees. Now for that obviously we can make a line here, so we can start a line from the midpoint, we can make it of length 10 units and we can incline it to an angle which is required, so let's say either 30 or 45, we can do that, and then we can make the circle at its end point. So that's one way of doing that, but there is also an alternate method which is from snap, which does not require you to make any helping line. Now to do that I'll select the circle tool directly, and now press and hold shift key, then right click and select this from option. Now we need to specify the base point. So here you can see that we have a base point option. From base point we need to specify that, so we need this base point here, the midpoint. Now we need to specify the exact location of that point. So in our case the point is located at a distance of 10 units and it is inclined to an angle of 30 degrees, and now press enter. And here we have it, the exact point. So now you can enter the radius directly. So let's say that the radius will be 5, press enter. Now let's verify the results. For that I'll select the line tool, I'll click at this midpoint and I'll join it with the midpoint. Now we need to check two different things. We need to check whether the length of this line is 10 units or not, and also the angle which this line is making with respect to the x-axis is 30 degrees or not. And we can do that directly with a single command which is di, distance, and we'll learn about these inquiry tools later on in this course. So I'll select this command, now click at the first point and the second point, and now here we have this. The distance is obviously 10 unit. Let's expand this a little bit to see it more clearly. The distance is 10 unit for this line and the angle in xy plane is 30 degrees. So obviously our results are accurate. So in this way you can use from snap to make these kind of geometries quite quickly. So let's repeat this process, but this time instead of making the circle here, I'll make the circle somewhere inside this geometry. So once again, Let's assume that we want to make a circle on this side, and in this case we want the distance to be equal to 3 units from this point, or let's make it 5 units from the midpoint, and it should be in this direction, and the angle which it should make with respect to the x-axis should be 235 degrees. So for that I'll select the circle tool, and once again press and hold shift key, then right click, select the from snap option. Now click on this midpoint, and now obviously we need to specify the exact location of that center point, which is at a distance of 5 units. So I'll type at and then distance. We are entering at because we are using the relative coordinate system, and in relative coordinate system we have already selected this point as the origin, so we are entering the end point with respect to this origin. So now the distance is 5 and we need to enter the angle, which is 235 in this case. Now press enter and we have our midpoint. Now only we need to enter the radius, which is 2 in this case. Press enter. Here we have the geometry. So without taking any reference of any line or any other geometry, we can make these kind of geometries quite quickly using the from snap tool. Now let's have a look at some of the remaining status bar options. So I'll start with the selection cycling option, which is quite helpful in selecting the overlapping geometries. Now in this case we have this drawing, and in this drawing there may be certain geometries which could be overlapping. So I'll zoom into this area, and now if you notice clearly we have some overlapping objects here. So some of these objects are overlapping on each other. Now in order to clearly identify that, you can take help of selection cycling. So you can click on this selection cycling option on the status bar to turn it on, and if you're not able to see this option selection cycling, then click on the customization and click this selection cycling option. So make sure that this selection cycling option is active. Now once it is active, go to the status bar, turn it on, and now move back to the drawing area. Now whenever a overlapping object will be found in the drawing, you will see this overlapping square icon right beside the cursor. Now simply click and you'll see a list of all of these overlapping objects. So you can move between the first and second object, and if the list has more objects you can select those objects also, and a preview will be visible in the drawing area also, as you can see here also. So you can select the objects and you can either erase them or you can do other modifications. In this case I'll simply erase it, and now we can join both of these endpoints. So I'll use line tool and I'll join these two endpoints. Now we have a clean geometry here. Now similarly, let's move to this part of the drawing, and here we have this circle. Now obviously when I move my cursor to this circle, there is no overlapping icon of selection cycling, but when I move it to this circle we have this overlapping icon. So that indicates that we have two circles or more than two circles on the same center. So let's click here and we obviously have these two arcs or the circles. So I'll select the second one, which is obviously not the full arc and it's completely redundant geometry which is not required. So let's erase it, and here we have it, a clean geometry. So in this way you can use selection cycling to make selections of overlapping objects. Now let's have a look at other status bar options. So I'll go to this customization and I'll select this coordinates option. So as soon as we activate the coordinates option, you'll see on the status bar here we have these three coordinates visible: the x coordinate, y coordinate and the z coordinate value, and these values will change with the movement of your cursor. So whenever I move my cursor, the coordinates will update itself and you can see the real time coordinate values from the drawing area. So in this way you can make a clever approximation of the coordinates simply by moving your cursor to that area. Now let's look at the next option, which is units. So once again I'll go to the customization and I'll activate this units status bar option, and I'll also turn off this coordinates. Now when you turn on this units option, you'll see this unit status bar which shows the current display unit, which is decimal in this case. So right now all the dimensions will be shown in decimal units. So that simply means whatever the geometry you make, it will be shown as decimals. So I'll check some of the properties of these objects. So I'll select this circle here and now right click and I'll go to properties. And now let's have a look at this property palette. Now here we have some of the properties related to this arc or this geometry. For example, we have the radius as 120, 188, start angle, that will be degrees, and the area in square units, and total arc length. So all of these values are currently shown as decimal values. Now let's press escape key and let's change this decimal to architectural. And now let's click on this arc again. Let's look at these properties, and now they are shown as architectural values. Obviously there will be no change in the angles, it's still shown as decimal. And here we have this arc length, area, and all the remaining values. So in this way you can toggle between the decimal, architectural, or any other remaining options like the engineering, fractional, or scientific, and you can view the values in that unit format. So this is not changing the unit of your actual drawing, this is simply changing the format in which the unit will be displayed. So now let's close this properties palette and I'll go to the customization and I'll deactivate this units option, and let's click on this quick properties option now. Now using this quick properties option you can bring a small property palette for every object. Now let's say that we want the property palette for all of these objects which we select. So for that, simply click on this quick properties and that will activate the quick property option. Now click on any of the object and this small property palette with some of the important properties or frequently used properties will get listed here. For example, the radius, the coordinates of center point, layer, and all the other information. So you will learn more about this property palette later on in the upcoming modules. So let's close it once again and let's deactivate this quick properties option, and I'll press escape key. So that was all about the selection, cycling, and other status bar options, which are really helpful and they can be used according to your preferences to make your drawing workflow easier. So now let's have a look at some of the drawing tools of AutoCAD, and we'll start it with the rectangular array command. So here we have a set of objects which is the desk arrangement of an office chair and PC, and we want to make multiple copies of this object in such a way that it looks like the floor arrangement of an office space. For that I will select the array tool. So go to the modify panel, select the rectangular array. Now select the complete set of objects from which you want to create the array. Now press enter, and here you will see a default array which you may or may not want. Now in this case you can increase number of objects in the row as well as in columns, and you can do that dynamically by using these multi-function grips. So here we have these grips. Now let's select this end grip in the horizontal direction and I'll move it towards right, and you'll notice that number of objects will increase along with this grip. Similarly, you can increase number of objects in the column or in the height direction using the same grip. So let's now move it upwards, and here we have it. So now more objects are added here. Now what if you want to change the gap between these rows and columns? For that you can use these grips. So here I can click on this grip and move it closer and the gap will decrease. Similarly, I can click on this grip and I can decrease or increase the gap. So that's a dynamic way of changing the values, but you can also do it accurately using the array creation tab. So you'll see this array creation tab as long as the command is active, and here we have some of the options, like we have number of columns, rows, and level. So let's start with number of columns, which is currently 7. So let's change this value to 8. Now press tab key. Okay, now after that we have the spacing between these columns, which is set to 2387 units. Now what if we want these objects to remain very close to each other? For that we need to change this value, we need to decrease it actually. So I'll change it to 1500. Now press tab key again, and now they are touching each other. So that's the arrangement which I want. Now the total distance will automatically adjust depending upon the number of objects or number of columns here. Now let's move on to rows. So here we have these 4 rows. Let's change it to 3. And now we have here the gap between different rows, which is 2696 units. So let's increase it a little bit, and I'll change it to 3000 units. Press tab key and the total distance will change accordingly, and here we have the new gap here. Now we have the levels, and levels are simply the number of objects in the z-axis which will not be visible as long as you are in this 2D space. And we have this associative option, so you can keep this option checked if you want to keep this array editable, and if you want that the array should not remain editable, then keep on this option unchecked. But now I'll keep it checked, and let's now click on close array. So here we have this complete set of objects as a single array. Now even when you click on any of these objects from this array, the complete set will be selected and the array tab will appear with these options. Now you can again modify the values in this row and column, and you also have some of the additional options here. So using these options you can even modify it further. For example, let's say that we want to add some extra part in this source object. So for that we can select this edit source option and now select the item on which you want to make the modification. So I'll select this object here and let's click on OK. So here we have this array. Now we can modify it. So in order to modify it, I'll select the circle tool and I'll make a small circle here. So that will act as a small gap here which is used for the cables in the table, and I'll copy it over here as well. Okay, now this is the final geometry and the same set of object will be visible here. So as soon as you add any modification in the source object, the change will be propagated in all the arrayed objects here everywhere. Now in order to save this, go to this last panel and click on save changes, and here we have it. The changes are saved and now all the arrayed elements are now similar. In these cases, the gap between the array row and array column is simply the gap between any two corresponding points. So in the initial case we have applied an array row gap of 3000 units, which is the gap between any two corresponding points. So for example, if you take this top left point as any reference point, then the distance between this top left and the second top left point will be 3000 units. Similarly, for the columns, the corresponding distance between the points will be equal to the gap which you have specified. So here we have this top left corner, so the gap between this top left corner and the top left corner of the second object will be equal to 1500 units, which we have specified. So this was all about the rectangular array tool of AutoCAD. In this video, I will tell you about the polar array tool of AutoCAD. So in the previous case, we have seen the rectangular array, and using the rectangular array, you were able to add objects in the rectangular direction in the horizontal and vertical direction. Using the polar array, you can add objects along a circular circumference. For example, here we have this circular table and we have this chair. Let's say that we want to add multiple chairs along the circumference of this table. For that, we can use the polar array. So on the modify panel, expand the flyout, the array flyout, and select this polar array. Now you need to select the objects. So here's the object, select it, and we want to make an array from this object. So select, press enter. Now you need to specify the center point of array. So the center point of array will be the center point of this circle. And now here we have it, a default array in this case. So again we need to change the objects, and here in this case we have these 6 objects, but we want 8 objects. So let's click here and let's now change it to 8 objects and press tab key. Now we have 8 objects here in this case. Now the angle between all of these objects is automatically calculated, and here it is 45 degrees, and also the total angle is 360 degrees, but you may or may not want this value. Let's say that we want to fill this complete set of chairs in between the 3 quadrants. We don't want any chair in this quadrant, let's say, and for that I'll simply change this value to 270 and then press the tab key. And now here we have it. So now the chairs are arranged, all of the 8 chairs, but they are arranged in between the 270 degree angle, and we don't have any chair in this quadrant. If you want to change this value back, then simply select 360-degree angle. Now they are completely filled here. Similarly, we have the number of rows, which is 1. You can change it to 2 or 3 or whatever value you want, but obviously in this case we don't want these many rows, so I'll simply change it to 1 once again. And the level is simply the number of objects in the z-axis, which will not be visible in this case. Now if you recall the previous case, we have made an associative array in case of rectangular array, and using the associative option we were able to modify the array even after creating that. So we will again keep this option checked. In this case we will make it associative, and later on we will modify some of the objects in this array also. Now we have an option here which is rotate items. So currently the objects are completely aligned towards center, so all of these objects are simply rotating. But what if you don't want that? For that, simply click on this rotate items, and now you can see that the original object and its configuration will be retained for all of its arrayed copies. So if you want this kind of array, you can keep this unchecked, but we don't want this, so I'll keep it checked so that the chairs are aligned towards center. And now click on close array. So now we can again modify this set of array, and for that I'll select the array and click on edit source. And once again I'll click on this object, select the array, click on OK if this message appears, and let's modify it. So I'll add a circle here, and you'll see that the same circle is added on all its copies. Now I'll save the array. And here we have it. Now even if you want to change any single object from this array, you can do that also. So I'll select the array once again, and now I'll select this replace item. And now we need a replacement item for this, so we need to first insert an object. So I'll select this block here. Now we'll learn about these blocks later on, and for now just make a mental note of this. So here we have this object. Now once again I need to go to the array, so select the array, again go to this replace item, and now select the replacement object, which is this one, and now press enter. Now you need to specify the base point of replacement object, which is somewhere in the middle here. Now we need to specify the array object which you want to replace. So let's replace this chair, so I'll select this chair and select the array, and here we have it, the replacement object is added. Now simply press enter and press enter again to exit this. You can also close this array. Now we have two objects here, and we need to delete the original arrayed object, so I'll select this one, erase it, and now here we have it. So now this copy is a part of new array, and it has been added as a replacement. We can now erase this object also, it's no longer required. So in this way you can replace any copy of this array from the complete set. Now in this case, if you select any single element of this array, all the objects will be selected, because while making the array we kept it as associative. Now if you want to make these objects completely separate from one another, then you need to explode the complete array, and you can explode it simply by pressing the X key on the command line and then pressing enter. So that will explode it, and you can also use the explode tool here, so that will also explode the same set of array. So both are simply same tools. You can use the command equivalent X, or you can use this icon here. Now if you click on any of the object, only that object will be selected, and also this array is no longer associative, and hence we cannot modify it further. But you can obviously replace objects, you can remove them, you can add extra objects if you want, for example here, but it will not remain a part of an array. So this was all about the polar array tool of AutoCAD. In this video I will tell you about the path array tool of AutoCAD, and for explaining this I'll use this geometry. Now here we have this simple spline, and that will simply represent the horizon of our ground, and here we have a palm tree block. Now if you want to make multiple copies of this palm tree along this path, then you can use path array, and for similar conditions also you can use the path array. So when you expand this flyout, you'll see this path array tool. Now select it and select the object, which is this one, and now press enter. Now you need to select the path, and here we have this path, so select it And here we have it, all the objects are now added along that path. Now once again, here also we have the similar options which we have seen in the rectangular and polar array, but in this case there is a slight difference in this number of items. Now here you'll see that number of item cannot be changed, and here it is set to 14 by default, but we can change the distance between number of items. So let's now change this distance value to 4000 and press tab key. So now we are able to change the distance between items, but what if we want to change number of items? For that, simply go to the properties panel, select this measure flyout and change it to divide. And now you will see that number of items can be changed, but the gap between items cannot be changed. So you can keep any of these options active at a time. So if one of the option is active, the second one will automatically become deactivated. So in this case we have total number of items as 10, so let's now change it to 8 and press tab key. Here we have it. Now we have number of rows which is set to 1. Obviously in this case also, if you want to add more rows you can do that. So let's type 3, press tab key, and here we have it, which is quite confusing. In this case we don't want these many rows, so that will simply make it look very unnatural. So I'll type 1 again, and here we have it. Again, the levels that can be added in the Z direction, and we have the associative option. So as long as you keep this associative option checked, you will be able to modify this array even after making it, but in this case I'll keep it unchecked. Now again we have the align items option, and using this align items option you can align all of these objects according to the geometry of this curve. So here let's say that we don't want to align these objects, we want the same orientation of this initial object or this primary object for all of our copies of this array. For that, simply click on this to uncheck, and now we have all of these objects in the same alignment as the primary object. But if you want to align them according to the geometry, then click on this align items, and here we have it. So I'll keep it aligned, that looks a little bit better. And now I'll close the array. So here we have the final array. Now if you click on any of these objects, they will be individually selected and they are no longer a part of an array because we have not selected the associative option. So if you want to keep it modifiable, if you want to modify these arrays even after making them, then ensure that associative option is checked. So I'll press escape key, and that's the final array. So this was all about the path array tool of AutoCAD. In this video, I will tell you about the divide and measure tool of AutoCAD, and using these tools you can divide the object in equal number of parts or at a particular distances. So here we have these two simple geometries. The first one is a line and this one is an spline. Now let's assume that we want to divide this line at first in equal number of parts, and we'll divide it into 6 equal segments. For that, go to this draw panel, expand it, and select the divide tool. Now select the object which you want to divide, in this case the line. Now look at the command line which prompts you to specify number of segments. So we want to divide it into 6 equal segments, so type 6 and press enter. And now the object has been divided into 6 different parts and they are all equal, but we are not able to see any change. We still have a single line. Actually, the object is divided using the points, and the points are not visible in this case, so we need to change the type of points in order to see them clearly, and the point type can be changed using the p type command. So type p type, press enter, and now change it to any other visible type of point. So I'll select this cross point type. Now click on OK, and here we have it. So now you can see that 5 points are added to divide this complete segment into 6 parts. So we have the first, second, third, fourth, fifth and sixth segment here. So it is divided into 6 different parts. Similarly, if you want to divide this spline, you can select the same command. So I'll expand it, select the divide tool. Now select the object and enter number of segments. Let's add 9. Press enter. We have here 9 equal segments. So although in line we can measure the complete length of line and then we can manually calculate the distances, after which we need to add the points, but in case of a spline the same calculation will become very tedious, and for these situations this command will become very helpful. Now let's press Ctrl Z to get back to this original geometry. So now what if instead of number of divisions we want to divide this object at equal intervals? So For that, we can select the second option, which is measure. Select this tool and now click on the line. Now the command line will prompt you to specify the length after which you want to add the division points. So let's assume that we want to add the points after every 40 unit on this line. So type 40 and press enter, and now here we have it. So the line is divided into as many parts as possible by creating segments of 40 unit length. So the first segment is of 40 unit, 40, 40, 40, 40, but the last segment will be of the remaining length, and whatever that length might be. Now in this case, while selecting the line, I have clicked at a point which is close to this end. That's why the measurement is started from this point. Now if you want the measurement to start from this point, so that the first segment over this side is of 40 length and the rest of the thing will follow in this direction, and the last segment will be of any residual length, then you need to ensure that you click somewhere close to this point. To make this clear, I'll erase all of these points, and now once again I'll select the measure tool. And now I'll select this object, but this time while selecting the object I am clicking close to this endpoint. Now the measurement will start from here, and enter distance as 40, press enter, and now you can clearly see that the measurement started from this side and this segment is of any residual length. Similarly, you can use the same method for this spline. I'll expand the draw panel, select the measure tool, select this object, and this time I'm selecting a point which is close to this endpoint. So obviously the measurement will start from here. So click here and now enter the distance as 60, press enter. And now the first distance is 60, 60, 60, but this segment will be of any remaining length. So in this way you can divide AutoCAD objects in equal number of segments or with a specific distance using the divide and measure tools. In this video I will tell you about the multifunction grip tool of AutoCAD. So up to this point we have made many drawings, and whenever we select any drawing or any object in AutoCAD, we were able to see these grips. So these are the different points on the geometry and which are represented by these blue dots, and they are visible on almost all of the geometries. Here also when I select the circle we have these different grips, and using these grips we can make multiple modifications in the geometry. For example, here we have this rectangle which is made with a simple polyline, and I'll select it so that the grips are visible. Now go to any of these grips, the end grips, and when I hover my cursor there, you'll see these extra options which are available in the menu. Now you can use this stretch vertex. You can stretch it just like this, or you can even add a vertex. So select this add vertex and add a new vertex here just like this. Now let's say that we want to remove this one so that this vertex and this vertex joins with a single line. So again I'll hover my cursor, select the remove vertex, and here we have it. Now if I move my cursor to this grip, I'll have even more options. So we have this stretch, the obvious one, and also we have the add vertex option which we have already seen. But we also have a new option which is convert to arc. So let's select it, and now we can convert this object or this polyline into an arc. So this part of polyline is now converted into an arc. Now we can again go to this and we can convert it to a line again. So we have this convert to line, select it, and here we have it. Now that is not all about the multifunction grips. You can select multiple grips in a drawing using the shift key. So let's say that in this case we want to select two grips on the end of this rectangle. For that I'll select this rectangle, and now we'll select both of these grips directly. So for selecting them, simply press and hold the shift key. Now click on the grip which you want to select. In this case I've selected this. Now its color changes to red. Now click on the second grip which you want to select, and now both of these grips are selected. Now release the shift key, click on any of these grips, and you can now modify them like this. Similarly, you can also directly click on the grip and modify the geometry according to your requirement. So I'll press Ctrl Z to get back to the original geometry. Now using grips, you can also modify your geometry in many different ways. For example, on the modify panel we have multiple tools like scale, stretch, move and copy or rotate, and we have used these tools from modify panel, but instead of selecting them from modify panel and using them from here, you can directly use the grips and use them. Now in this case we have this complete geometry. Let's say that we want to modify it using the grips. For that I'll select it. Now select the grip which you want to make as a base point. So I'll select this grip as the base point and now click on it. Now as soon as you'll click on it, you'll see on the command line here, let's expand this command line to see it even more clearly, that we have an extra option here is stretch, which is enclosed in these star symbols. Now the current command which is active in this case is stretch, and you can obviously see that we can stretch the object. Now press space bar or enter and the command will change to move, as you can see here on the command line, and now we'll be able to move the object. Now I'll once again press enter and it changes to rotate, and the grip on which we have clicked will become the base point for rotation. Press enter again and now we can scale it. You can enter the scale factor right now on the command line in order to change its size, and press enter again. We have the mirror tool, so now we can mirror it along this mirroring line or whatever the mirror line which you specify. Press enter again and we are back to stretch. Now in this case we were able to change the geometry for this rectangle only. What if you also want to change the geometry for the circle along with this? For that you need to select the complete set of objects and now select the grip. So let's select this grip in this case, and once again we have the stretch. Press enter, we have the move tool, but in this case the complete set of object will move. We have the rotate, and complete set of object will rotate, although the change in the rotation for this circle will not be visible. Press enter, we have the scale, and now we can scale the complete set of geometry. We have the mirror tool, we can obviously mirror it. We have again the stretch, which is back to the first condition. So in this way we can use these modify tools directly using the multifunction grips as well. And obviously we have the option of changing the geometry directly by clicking the multifunction grip also. So this was all about the multifunction grip tool of AutoCAD. In this video I will tell you about the align command of AutoCAD, and using the align command you can move an object and also align its geometry according to your requirement. Now in this case we have this simple geometry here and we have this door block. Now let's say that we want to move this door block on this part of the geometry, and we want to move it in such a way that it completely aligns with this wall or this geometry, and it also remains inside this geometry. So obviously we can do that using the move and rotate tool, and that will take a couple of steps, but you can do that directly using a single command. So expand the modify panel, select the align tool here. Now select the complete set of object which you want to move and press enter. Now specify the first point on the source object. So here the first point is this one, this end point here. So I'll select this one. Now specify the first destination point. So we want this point to touch this point on the geometry. So now obviously that is the first point, it will move to this point. Now we need to specify the second source point. Now the second source point is this one, and we want this to touch this line. So you can select any other point on this line. So I'll select the midpoint. You don't need to be very concerned about the point here. I just simply need to click at a point on this line. So now this point will end up somewhere on this line. Now we need to select the third point, which is, let's select this one as the third point, and you need to specify third point here. So the third point will decide the direction. So we want to place it inside. So I'll click somewhere inside, and here we have it, the final geometry. Now in this case you can clearly see that the first point is here where we clicked. The second point was the midpoint, and obviously I said that by clicking the midpoint we are essentially assigning this line as the second point. So here the second point has been assigned, and the third point decided the direction, whether inside or outside. And here we have it, the object not only moved but also properly aligned according to the geometry. And using this tool you can also align similar kind of geometries on different objects. So that was the align tool of AutoCAD. In this video, I will tell you about finding distance, radius, angle and coordinates from the simple AutoCAD geometries. And for that, I will use this simple 2D drawing. Now here in this drawing, we have the circle, arc, simple lines and also the slant line. And we will find different properties of this geometry using the inquiry commands. The inquiry commands are simply the commands which can be used to find these values, and you can find those commands here on the utilities panel. So go to this utilities panel and here you will see this flyout. From this flyout, select the distance option first. So you can also start this distance tool from the DI command. Now once the command is active, click on the first point from where you want to start distance measurement, and in this case we want to start distance measurement from this point. Now click on the end point, which is this one in this case, and we have our results over the command line. Now expand this command line and here you'll see that the distance is 28 units. Also the angle in XY plane is 35 units. That means the angle which this inclined line is making with respect to the positive side of x-axis. So if a line is drawn here in a completely horizontal way, then the angle which this line is making with that line is 35 units. Also we have some additional values like the delta value, the delta x, y and z. So that simply means that the coordinate value of the final point when subtracted with the coordinate of the initial point will have this result. So the x coordinate of this point minus x coordinate of this point will be 22.9363 unit. Similarly, the y coordinate of this point minus y coordinate of this point will be of this value. Now to exit this command, simply press escape key. In a similar way, you can use other options of this flyout to find other values. For example, here we have the radius. Select the radius and now select an arc or circle. So here we have the circle. Let's click on it and we have the radius, and not only the radius, we also have the diameter of this circle. Similarly, you can repeat the radius tool simply by selecting the radius option from the command line here also. And now click on this arc and the radius is 6 unit, the diameter is 12 unit for this arc. So let's now press escape key to get back to the geometry, and now we'll go to the utilities panel and select the remaining options. So the next option is angle. Now when you want to find only the angle of any line, then you can select this command. Now in this case you can select the geometry, and I'm selecting this line, and select the second line or the second geometry with respect to which you want to find the angle. So I'll select this one, and now the angle in between these two geometries is 125 degrees as mentioned here. So the included angle on this side, the smaller side, will be 125 degrees. Now let's repeat it once again. So I'll select this angle, now I'll select this line and I'll click on this line, and here in this case the included angle here will be 145 degrees. So in this way you can find angle between other geometries as well. Now using the inquiry commands, you can also find the coordinate values of any geometry. For example, in this case we don't know the coordinate of the center of this circle, and if you want to find that out, simply go to the utilities panel and select this ID point option. You can also use its command equivalent, which is ID, and now click at the point for which you want to find the coordinates. So click here, and now here we have the coordinate value, the x value, the y value, and obviously the z value will be 0 as we are dealing with x and y axis only in this case. So in this way you can find distance, radius, angle and coordinate values of any geometry using the inquiry tools. Finding area from your AutoCAD drawing is one of the frequent tasks which is always done by almost everyone, and in AutoCAD you can find area of different objects in many different ways, but in this video I will tell you about finding areas using the inquiry tools. So here we have these two simple geometries, and now we'll find the enclosed area of this complete shape and also this one using the inquiry tool. And for that, once again I'll go to the utilities panel, and from here I'll select the area tool. So in the previous video we have seen these inquiry tools, and now in this video I'll tell you about this area tool. So select this area tool, and now you need to specify the area in your drawing. So here I'll select this geometry first. Now let's say that we want to find the area of this complete geometry, and for that I'll start with any point. Now click at the second point, then the third point, fourth, and the fifth. Now we have this green window, and the complete area which is enclosed in this green window can be seen directly using this command. So now let's press enter, and here we have it. So the area is 6896.7586 square units, and the perimeter is 330.7268 units. So whatever the unit you are using, if you are using mm, that will be millimeter square. If you are using inches, that will be inches square. So the area will depend upon the unit which you are using. Now in this case the geometry was quite simple, so we selected the coordinate points and we found out the area. But in this case we cannot find the area simply by clicking, because we have an arc here. Now let's ignore this circle for a moment. I'll press escape key and I'll try to find the area of this complete outer geometry. We will simply ignore this circle for now. Now once again I'll go to utilities panel and I'll select the area. Now instead of selecting the points from this drawing, select this object option. Now click on it and simply click on the object. Now for clicking on this object, you need to ensure that this complete object is made with a single unit, a single polyline or region, and it should be connected, because you cannot use this tool for finding area of this geometry, because in this case obviously we have these connected lines, but this line is not connected, and hence we won't be able to find the area in this case. So simply click on this geometry and the complete area is selected, including the circle. Now we have the results here. So the area is 1179.5179 square units, and the perimeter is here 433.9930 units. Now obviously there must be situations where we don't want to find the area of this circle. We want to exclude the area of this circle from this complete area. In those cases you can use the subtract tool. So let's press escape key, and once again I'll go to the area. And now here look at the command line. So we have some options here like add area, subtract area. So select this subtract area first, and now click on object and click on this circle. Now you'll see that the color of this circle is different, and whenever you'll find the complete area, the area of this circle will be removed from that. Now press enter. Now go to the command line and select this add area option, and once again click on object and select this object. So now the final area can be seen here. So the total area was this, and the area of the circle has been removed from that, and the remaining area is 8828.9054 unit, which is the area of this green portion, excluding the area of this circle. Now press enter. So in this way you can find area of different geometries using the area command or the area inquiry tool of AutoCAD. In this video I will tell you about making isometric drawings in AutoCAD. And isometric drawings are simply 2D drawings, but they look like a 3D drawing, and generally the angle on which the axis is inclined for making an isometric drawing is 30 degrees. So in this case we have this drawing, which is an isometric drawing obviously, and although it looks like a 3D drawing, it's actually a 2D drawing, and we'll learn about making this same geometry here. So for making the isometric drawing, it is always advisable to keep the grid on, and you can click on the first object snap option here to make the grid on. Now this is the normal grid here, the orthographic grid, and in order to convert it into an isometric grid, or in order to convert the drawing area into an isometric drawing area, you need to select the ISO draft option. So you can select the ISO draft option and select the appropriate value, or you can simply click on this ISO draft or isometric draft mode from the status bar. So now click on it and the grid will change to any one of the isometric planes. So just right beside this ISO draft status bar option, you'll see these three planes. So we have the ISO plane right, the top and left. Now depending upon your selection, the ISO plane may look like any of these three. So we will first start with this isoplane top and make sure this isoplane top is selected. So you can change these isometric planes from this status bar option, or you can also press the F5 function key to change them, just like this. So now we are on the isoplane top. Let's start making this geometry, and for making that I'll select the polyline tool. Now click anywhere in the drawing area to start this geometry and make sure it goes towards this direction. The 30-degree angle should be visible on the tooltip. Now enter the length, which is 50, and press enter. Now move your cursor towards this side and once again a distance of 100 unit and press enter. Now move it towards left again, type 50, press enter. Now join it with the starting point here and press enter. So now we have this closed rectangle. So let's select it. Now go to the copy tool, click on any of its vertices, move it downwards and enter a distance of 40 unit and press enter. Now press enter again to exit the command. Now I'll select the line tool and I'll join all of these vertices. So join these vertices, press enter and repeat it. Go to these vertices, join them and join these vertices. Okay, so now we have these geometries. Now we will make this part of this isometric drawing, and for that I'll once again select the line tool and I'll click on the midpoint of this line. Now move it towards this direction and enter a distance of 30 unit and press enter. Now move it towards this side and click at this intersection point. Now move it downwards and enter a distance of 20 unit, press enter, then move it towards left and join it with this point. Okay, so here we have these geometries. Now we need to clean this drawing a little bit, and for cleaning that we can use the trim tool. So go to the modify panel, select the trim tool, press enter. Now we'll remove this part and this part. Also we'll remove these parts of the drawing carefully and just like this. So we have cleaned most of the drawing. Now we need to add these two lines. So again I'll go to the line tool and now click on this point and move it downwards, but don't click on any of these points. Now move your cursor on this point, this end point, but don't click, and now move it once again back to that point and you can zoom into this area now to see it more clearly. So let's move it down, then go to this point, then move backwards, and when the intersection point appears for both of these directions, click and click on this point. So here we have it. So we have added this geometry as well. So the basic structure of our 3D drawing is complete, or the 3D isometric drawing is complete. Now we need to add this cylindrical structure, and we can add this cylindrical structure only after changing the plane. So we need to make this plane, the isoplane, parallel to this plane because that structure is made on this plane. So for that I'll press the F5 key and it will change to isoplane right, and that will be the plane on which we will draw this geometry. Now this may look like a circle, but actually it's not a circle. For making this geometry we will use the ellipse tool, and for isometric drawings you need to use the ellipse tool. So go to this ellipse flyout and select this axis and ellipse. Now look at the command line and we have an option of iso circle. So select this iso circle and now specify the center of this circle, which will be at the exact center of this square or this rectangular shape. So I'll go to this midpoint and track it downwards, but I'll not click at any point. Now I'll move to this center point and track it on the left side, and here we have the center point. Now click and enter the radius, which is 15 in this case, and press enter. So we have added the circle. Now we need to make a copy of this circle. For that I'll go to the copy command, select the circle, press enter, click on the center point, move it in this direction and enter a distance of 50 unit, press enter. Press enter again to exit this command. So we have added both of these circles, but now we need to add these two lines, and for adding these two lines select the line tool and go to this circle. Now you'll see this quadrant, and if you're not able to see this quadrant, go to the object snap and make sure that this quadrant option is checked. Now click on the quadrant and click on the corresponding quadrant of this circle and press enter. press enter again to repeat the command and go to this quadrant, then this quadrant, and press enter. Now obviously we need to trim the remaining portion of the geometry, so I'll select the trim tool, press enter, and trim these geometries. These are no longer required, and here we have the final isometric drawing. So in this way you can create isometric drawing by changing the iso plane in AutoCAD. In this video I will tell you about the center line and center mark tool of AutoCAD, and these are quite new tools which are added in AutoCAD 2017 version. So now here we have a circle, we have a set of parallel lines and a set of intersecting lines. We will start with this circle. Now you can find the center line and center mark tools on the annotate tab. So go to this annotate tab, and here you'll see these tools, the center mark and center line, on the center lines panel. Now click on this center mark and select a circle or an arc. So in this case we have a circle, so click on the circle and the center mark will be added directly. Now press enter to exit this command. Now the default center mark has been added, but you can still modify its settings. So select the center mark and you'll see these grips. Now using these grips you can change the length of this center mark along all of its four sides here, just like this. And when the radius of this geometry changes, the center mark will automatically change its size, just like this. Now in a similar way you can add a center line also. So here we have these two parallel lines. Now in order to add the center line, simply select the center line tool, click on the first line, the second line, and the center line has been added. And here also the center line will remain connected to its parent lines. So select any of the parent line and change its angle. But when you change its angle, the center line will also change accordingly. In a similar way, if you add a center line here on the intersecting line, then it will be added at the angle bisector. Now this will directly bisect the angle which this line is making here. And in this case also, if you change the angle of this line, or even if you change the gap between these two lines, the center line will change appropriately, just like this. Now in this case too, if you want to change the length of these lines, you can easily change it by using these grips. You can modify it just like this. And we also have one more command, which is ch property command, which can be used for changing the property of these objects. So type ch prop and press enter. Now select the center mark or center line whose property you want to change. So in this case I'll select the center mark and now press enter. So we have a set of properties here that can be changed, and you can use this chprop command on other geometries also, and we'll learn about this command later on in the next module also. So for now we will only change one of the property, which is line type scale. So here we have this line type scale. Let's select it and let's change this line type scale to 2. The current value is set to 1. Now press enter and press enter again. And you'll notice that the scale of this line now changes and it will now increase. You can compare its scale with these lines here. So you can change some of the properties related to this center mark, center line directly using the ch property command. If required, you can also change the properties of these center lines and center mark using the property palette. And the property palettes can be seen by selecting the objects and selecting the property option from the contextual menu. Here we have this property palette. So we'll learn about this property palette also later on in the next module. So you can modify its properties from here as well. So this was all about the center mark and center line tool of AutoCAD. So up to this point we have seen many simple 2D geometries in AutoCAD, for example line, polyline, arc, circles and ellipses. There is also a different kind of geometry in AutoCAD which is called region, and you can make region using the completely closed geometries. So let's make simple geometries here. I'll make a geometry with this circle tool and another one with this rectangle. Also I'll make a geometry using this line command here. Now in this case, if you select these geometries, you'll see the normal grips, and also the behavior of this object will be of a polyline because it's made up of a polyline. Now if you select the circle, here also we have the simple grips. You can modify these objects like this using these grips, and its behavior will be very much similar to that of a circle. In this case, obviously we have these separate lines. You can select them and their behavior will be something like that of a line. Now once we convert these objects into region, their behavior will completely change. And in order to convert it into region, you can use its command equivalent region, that's region, or you can go to this draw panel, expand it, and select the region tool. Now I'll select this region tool, and now click on this circle and press enter. So now this object has been converted into a region, although we still have the circle just right behind this, but we now have a new object also here. Now here in this case we have a simple polyline. Let's convert this one into also a region. So I'll select the region, I'll click on this and press enter. We again have a new region here. Now I'll convert this object into a region. In this case you can see that we can select it separately. Let's now go to region tool and select all of these objects and press enter. Now when I move my cursor, you can see that we have a region here as seen on the tooltip, and the complete geometry will be selected. So in all of these three cases we had completely closed geometry. That's why I was able to convert them into region, and that's one of the conditions which needs to be fulfilled for converting an object into a region. Okay, so now we have the regions. Let's look at the difference here. So I'll select this object, and obviously I select the region, and I'll simply move it from this point. So I'll select the grip and move it here. Now that's the region, and this is simple line geometry which we initially had. Now in this case the object will behave as a rigid geometry. As you can see that I can move it directly using my grips. Even in this case I have this region, and if I move it, I can simply move it using my grips. It's completely rigid shape. But in this case, the original rectangle, if you move it with these grips, it will deform, it will stretch, and it will behave accordingly. So that's one of the differences. Now another difference between a region and a common geometry is the ability to perform Boolean operations. So I'll explain it in a moment. For that I'll just clean this drawing area. So I have this region. Also I'll select this circle and I'll separate this region. Now I'll remove all of these geometries. They are no longer required. Now we have this circle which is a region, and also this rectangle which is a region. Now I'll move them one over another in this overlapping position, just like this. And let's make 3 copies. So go to copy tool, and the second copy and third copy. Now all of these objects are made with region. Now let's select the union tool, the first Boolean operation. So I'll type union and press enter. Now you need to select the first object and the second object and press enter. And look at the geometry now. So both of these geometries now combined, and they combine to form a single region like this, which is a completely rigid shape, just like this. Okay, now let's type subtract and press enter. So that's the second Boolean operation. Now for subtract, you need to first select the object which you want to retain. In this case we want to retain this object. Press enter. Now click on the object which you want to subtract. Now in this case, when I select the rectangle, this portion, the common portion of rectangle and circle, will be subtracted, and also this remaining part of the rectangle will be erased. So let's select it, press enter, and here we have it. Now this part has been removed, and also the remaining object has been removed because we selected the circle initially. Now let's reverse the process. I'll press Ctrl Z and I'll type subtract again. And now in this case I'll select this rectangle first. Now press enter, select the circle, and you obviously know what will happen this time. Here we have it. The circle will be removed from this rectangle or this rectangular region. Now in this case I'll use the third Boolean operation, which is intersect. So let's type intersect. Now in this case only the common portion of intersecting geometries will be retained. So I'll select the first object, the second one, both of them are regions, press enter, and we only have the common region. from both of these geometries. So in this way we can use the Boolean operations on the region objects, and that's all about the region tool. Okay, so now this module is complete. Let's make this drawing using all the tools which we have learned so far. And for making this, we are going to use the array tool. To be specific, we'll use the circular array which we have learned here. So I'll start with the circle command. So I'll go to draw panel, select the flyout and select the center radius circle. Now click at any point in the drawing area to start it and enter a radius of 2 unit and press enter. Now press enter again to repeat this command and go to the same center, and this time enter a radius of 5 unit and press enter. So there we have it, 2 concentric circles. Now we need to go to the circle tool again, click on this quadrant, and now again make another circle with radius of 0.8 unit and press enter. Now we need to trim this part, so I'll go to trim tool, press enter and remove this portion. Now we need to make the array, so go to the flyout here and select polar array. Now click on this part, press enter, and now click on the center which is here. So in this drawing we have 11 instances, and in total we need to make 12 instances because one of that is removed and the groove has been made instead of that. So I'll select here 12 as number of items and press enter. So here we have it. Now make sure associative is unchecked and then click on close array. Now we need to clean this geometry. So I'll go to trim, press enter and remove these portions. They are no longer required in this geometry. Okay, so now we need to make the final groove here. So I'll simply erase this portion. It is no longer required here. And here we have already trimmed this portion which we should not have trimmed. So in order to extend it, you can go to the modify panel and here select the extend tool and press enter. Now click on this portion and there we have it. It is now extended back. Okay, so now I'll go to the line tool, click on the center and make a straight line. It should be long enough to pass this circle completely. Now go to offset and enter an offset distance of 0.5 and press enter. Now click on this line and click upwards, then click on this line and click downwards and press enter. Now go to trim tool, press enter and remove this complete portion and this complete portion. Also zoom into this area, remove this part and remove this part. Now remove this line, it's no longer required. There we have it, the final geometry as per the dimensions mentioned here. So now in this module we will learn about applying the properties on the simple geometries, and I'll start with applying the properties such as the color and line type on our AutoCAD geometries. So here we have these two drawings and actually both of them are same drawings, but in the first case we have properties applied on some of the objects, and in this case we have a simple drawing without any properties. So here I'll start with the color property first. So in this case let's look at this part of the geometry, and here you can see that for all of these line objects the color has been assigned as yellow. Also there are some other different colors, but here I'll first start with applying the yellow color on this part of the geometry. Now in order to apply the properties there are two different ways. Either you can directly apply the property on the object, or you can apply the property on the layer and you can put those objects on the layer. We will learn about layer in upcoming modules, but in this module we will only stick with the direct application of properties on the objects. So now we need to apply the yellow color on the similar objects of this geometry. So I'll first select all of the geometries on which we need to apply the property, which is the color. So I'll select them just like this. Here we have it. Now we have made the selection. Now after selecting the objects, go to this properties panel and from here select this drop down, which is the color drop down. Now here you will see lots of different colors and you can select the appropriate color from this color box. Now if this color box is not sufficient, if you want even more colors, then you can select this more colors option. Now this will take you to index color, true color and color books tab, and you can select your color using any of these methods. So obviously we can use this index color tab and we can select our required color from here. So here we have the yellow color. Let's select it, click on OK, and the property is now applied here, as you can see. So now let's have a look at the line type property of AutoCAD drawings. So here we have this drawing, and here in this case if you look closely you'll find that these lines are quite different. Actually they are not separate units, it's a single line which looks like these broken lines. Now if you want to apply this kind of line type on the object here also, then you need to select the appropriate line type from the properties. Now this is the line type which we'll use here, and you can see this line type in this line type drop down. So let's click on this line type drop down, and here you'll see this hidden line type. In your case you will not find all of these line types in your list. In your list you may have by block, continuous, by layer. So these will be the three line types: the by layer, by block and continuous, that will be available in your list. The rest of the line types need to be loaded, and for applying the current line type here I will also load the line type. So let's go to other and click on this load option. Now here we have a complete list of line type, and you can select the appropriate line type whichever you want from this list. So I'll select this ISO dash line type. Now click on OK, and now the ISO dash line type is also added in our list. Now we'll apply this line type to our objects. Let's look at this drop down. We have the ISO dash line type here. So once the line type is added to your list, go to the objects and select them, the objects on which you want to apply the line types. So I'll carefully select these objects. Okay, so here's the selection. Now go to this drop down and select the line type here and press escape key. Okay, so now the line type is applied, but you'll not see any difference here, and you may find this situation in your drawing also. Although as you can see here we have this line type which is quite visible, but in this case even after applying the line type it may look something like this. So for these cases you need to actually change the scale of these line types, and to change the scale of these line types you need to select the lines first. So let's select the lines on which the line type has been applied. Okay, and now go to the property palette. So right click and go to properties. Now here we have this line type scale option which is set to 1. Now you need to ensure an appropriate value which can be greater than 1 or less than 1 depending upon the scale of your drawing. So I'll select a smaller value for this case. So let's click on this and let's change its value to 0.008 and press enter. Well, this is very small value, so let's increase its value to 0.02. Press enter. Now that looks appropriate. So I'll again increase this value to 0.05, and that's better, but still we can change it to 0.04 and that looks quite perfect. So I'll now close this property palette, press escape key. Here we have this line type. So now you can see the appropriate line type applied here with the correct scale. So in this way you can change the scale of your line types also, and depending upon the scale of this line type it will look either like this or like this. So this was all about adding colors and a line type with appropriate scale to the AutoCAD drawings. In the previous video, I've told you about changing the color and line type of an object in AutoCAD. In this video, I will tell you about changing the line weight and transparency. Here, let's look at this drawing, and you'll notice that in this drawing, we have this line with a different line weight. The width of this line is more than the width of its counterparts here. When you'll compare it, you'll simply see the difference. Now, let's look at this part of the drawing here. Here we have the simple drawings. Now in order to change the line weight of this part of the drawing, you need to apply the line weight property, and in this case a line weight of 0.3 has been applied. Now to change the line weight, go to this properties panel and select this line weight drop down. Here you will see different line weights starting from 0.00 mm. Obviously that will be the default line weight, and if you want to see the default line weight, simply go to this line weight settings and check it. So here we have the default line weight of 0.25 mm. So that's the default line weight which is currently applied to all of these objects. Now let's click on OK. Let's go to this drop down, and now if you want to even thicken the lines, you can select the respective options, or if you want to increase the thickness, you can select 0.335 and all of these line weights. So in this case we have a line weight of 0.30 applied on this line, and we'll select the same line weight for this part. So let's now select the geometries on which you need to apply the line weight. So carefully select these lines. Now the lines are selected. Let's go to the drop down and select the 0.3 line weight. Now press escape key. So here we have this line weight. Now in this case you can simply see the line weight here, but in most of the cases the line weight will not be visible even after applying the line weight, and in order to make it visible you need to ensure that this line weight status bar option is activated. So in this case we have this LW display active. Now you may or may not find this LW display or line weight display option on the status bar, and if this option is not available on the status bar, then go to this customization and select this line weight. So make sure that a check mark is visible along this line weight option. Now once the line weight display is here, click on it to activate it, and then you'll be able to see the line weights. Now let's go to the original drawing and let's look at this part. Here we have transparency applied to this part of the geometry. Now if you compare it with this part of the geometry, you'll notice that this one is quite bright with 0% transparency, and here a transparency of nearly 70% has been applied. So that's why the object look a little bit dim than these objects. Now in order to apply the transparency, again you need to go to the properties. So in this case I'll first select the objects. So here we have it, these objects are selected. Let's select these two lines as well, and let's make the selection here also. So now the objects are selected. Let's go to this properties panel, expand it, and here we have the transparency option. Now you can increase this transparency here simply by entering the value, and this value ranges from 0 to 90. So 90 is the maximum transparency that you can apply. So let's type a transparency value of 70 and press tab key. So here we have it. Now you can apply the transparency in this way, or you can also move this slider in order to apply the transparency, and in this case I'll obviously keep the transparency value to 70. So let's type 70 and press tab or enter key. Now let's look back in the drawing area, press escape. Here we have it, the transparency has been applied. In order to see this object properly, just like this one, you can also change the color. So you already know how to change the color, so let's select all of these objects. Let's change its color to yellow. Okay, now you can compare it with this object, and obviously we have the transparency, but here in this case also you need to ensure that this transparency status bar option is active, because if you turn it off just like this, even after applying the transparency will not be visible. So if you don't find this transparency option here on the status bar, go to the customization and make sure that this transparency is checked. Once this is checked, you'll find this option and click on it to activate it. Similarly, you need to ensure that line weight display should be checked and it should be on here. So if you turn it off, line weight will not be visible even after applying the line weight. So let's go to this option and turn it on. So this was all about line weight and transparency option of AutoCAD. So far we have applied different properties in our AutoCAD drawing, and in order to check the properties which are applied on the objects, you can take help of property palette. So the property palette can be accessed simply by right clicking anywhere in the drawing area and selecting the property option. So obviously we don't have the property option here as none of the object is selected. Now in order to make the property palette active, you need to select the object first. So in this case I'll select the object, this part of the object, then right click, select the properties. Now we have the property option. So this is a simple property palette, and you can obviously stretch it, contract it. You can change the size of this property palette. Also you can scroll it down here to see even more values, and if you want you can even dock it to the side of this window. So when I move it towards this side, you'll notice that it will automatically dock here. Now we have the property palette always available here. Now this property palette is displaying the line properties of 7 lines which we have selected, as you can see here. So we have these 7 lines selected, and all of these properties are related to those 7 lines. Now let's press escape key, and now we don't have any selection here. So let's select any other object, and in this case I'll select this object here, and now this is displaying the property of this particular line. Similarly, if you change it to, let's say, this circle, it will only display the properties of that circle. As you can see here, we have the circle now. So in this way you can check the properties of different objects using the property palette. Now you can also undock it here, just move it outside this corner, and here we have it. Now let's look at the properties which can be seen using this property palette. So in the first situation, we'll have a look at this part of the drawing. So here we have applied the yellow color. So let's select these lines. Okay. Now let's look at the property palette. So we can see that the color has been applied as yellow, and here using this property panel we have applied the yellow color, so that's the same property. Now if you want to change the property from here, you can do that directly. So let's click on this, and there will be a drop down menu just like this, and you can see the same drop down menu here also. So when you click on it, you have the same drop down menu. Now we have an option of more colors here. Select color, and we have the select color window which was also available here. Now from here let's change this color to green. Click on OK, and you can see the change here. The green color has been applied. So you can change the properties of any of these objects directly using the property palette and also using the properties panel. Now let's press Ctrl Z to get back to the original properties. Now we have also changed the properties of these lines. So here we have this line, and we have changed the line type of this line. So let's select this line, and now here on this line type option you'll see this AutoCAD dash line type. So let's click on this drop down, and now you can again change the line type if you want from this list. But in this list obviously only those line types will be shown which are loaded in the drawing. So if you want to load any other line type, click on this other and you can load it. Also we have the line type scale of 0.04, which we have already seen. You can obviously change this value if you want according to your requirement. We also have some other properties, for example the layer, which we will look in a moment. So you can change the layer of this line from this drop down, and there are also other options, for example the layer panel, from where you can change it, and we'll obviously look at this in the upcoming modules. Now let's look at one more option here. So let's press escape key, and here we have the line weight. We have applied the line weight, select it, and now we have the line weight option, which is 0.3. Obviously you can change this value also. So let's change it to some other line weight, and we have it here. So this line weight is now changed. You can compare it with the remaining line weights. So we not only have these many properties, we also have some additional properties here. So let's now change it to once again back to 0.3 line weight. So I'll scroll it upwards, change its value to 0.3. Now we can also see some other properties related to these lines or other geometries. For example, let's zoom into this area. Now here we have a circle. Let's select it. We have all the properties now which are related to the circle. Now let's scroll it down, and now let's look at the geometry panel here. Now in this geometry panel we have some very important information here. For example, the radius, which is 57.5 for this circle, the diameter, circumference, and the area. So these informations can be directly accessed from the property panel. You can not only access these options, but you can also change these values. So for example, in this case, let's say that we want to change the radius of this circle from 57.5 to, let's say, 50. So let's type 50, press enter, and you'll notice that the radius of this circle will change in this drawing also. Similarly, if you change the value here, the new property or the new value will be updated directly here in the property panel. And also when you change the radius, the diameter and all the related values will get updated automatically. So let's press escape key and press Ctrl Z. Now this is one way of accessing the properties of any object. There is also one more method of accessing the properties, and you can do that by list command. So here also I'll select the same circle. Now let's assume that we want to find its properties. You can simply select the object, go to this properties panel, select the list option, and here we have it. Almost all of the properties which are quite important, for example the radius, circumference and area, and you can see these properties. Obviously you cannot change these properties from this list, but you can take a reference of these values when required. You can also match properties of one object from your drawing to the other object. For example, in this case we have this transparency applied on this part of the geometry. Let's assume that we want to apply the transparency, the same transparency, same color and all the other properties on other part of the geometry, and in this case we will apply it on these lines. So for that you need to use the match properties command, and the shortcut for match properties is MA. So simply type MA, which is short for match attributes or match property you can say. Now press enter. Now select the source object, which is this one obviously. Now select the destination object and click on the destination object, and the properties will get applied on those objects. Simply go on and click on those objects and the properties will be applied just like this. Press enter when you want to exit the command. In a similar way, let's say that we want to apply the same line type here, the line type which is applied here, and with the same line type width and the line type scale and everything, all these properties you want to copy from here and you want to paste it on this line. For that again we can use MA, the match properties command. So type MA, press enter. Now click on the source object, which is this one, and now directly go to the destination object and keep on clicking, and the same properties will be applied here just like this. It's quite easy and also a very handy tool if you want to apply lots of properties. So in this way you can transfer the properties of one object to another very easily using the match property command. And that was all about the property settings of AutoCAD drawing. So in the previous video we have seen some of the methods by which we can change the properties of objects in AutoCAD, and this video is about changing the properties using a simple command which is chprop. So using this command you can change some of the most frequently used properties directly for any object. So let's assume that we want to change the properties of this part of the geometry, and for changing it we will use the chprop command. So let's type chprop, press enter, and now select the objects for which the properties needs to be changed. So in this case I'll select all of these objects including this line and this line, and now press enter. Now we have many options here like the color, layer, line type scale, line weight, and all of these options. So you can select any of these options, but in this case I will select the transparency because here the transparency is dim. You can see that the transparency has been changed to 70. So let's change the transparency first. So I'll select the transparency value, and you can see the current value of transparency in this angle bracket, so which is set to 70. Let's change it to 0 and press enter. Now press enter again to apply the settings, and here we have it. The transparency has been restored here. You can compare it with this drawing. So if you want to change even other properties, let's press enter to repeat the command. Once again select the objects, and in this case I'll select only these two objects. Now press enter. Now let's change the line type. So select the L type option here and enter the name of new line type. So we have the current line type as bilayer, so let's type its name, which is hidden in this case, and now press enter. Now press enter again to apply the settings, and here we have it. The new line type, the hidden line type, has been applied here. In a similar way, you can even apply different settings or you can change them. So I'll press enter again to repeat the command. Once again, I'll select these two line types, press enter. We have now line weight, line type scale, and all the other options that you can obviously change. For this case, I'll select the line weight, which is now set to by layer. Let's change this value to 0.5 and now press enter and press enter again, and the new line weight is here. So this is quite an easy way of changing the properties without using the property panel, obviously. So even if you don't want to use the property palette or the property panel, you can use this ch prop option to change the properties of different objects in AutoCAD. In this video, I will tell you about model space viewports. So here, this is the model space and the drawing area also. Now currently we have a single drawing area in which we can obviously make any drawing, but you can divide it into multiple parts, and that will help you in viewing the same drawings from different perspectives. Now to make things clear, I'll start with the view tab. So go to this view tab, and now here we have this model viewports panel. Now from this model viewports panel, click on this viewport configuration and you'll see a long list of viewports. So these are the different kind of viewports that you can make here. So I'll select this 4 equal. Now as the name suggests, it will make these 4 viewports. Now they are simply the same viewports, but they are divided into 4 different parts. To make things more clear, I'll select a new drawing. So I'll go to 6.5a, and here we have this simple tree in our drawing area. Now once again here, I'll go to the viewport configuration and I'll change it to 4 equal. Now you can see that in all of these viewports we have the same tree. Now obviously we have one special viewport here which has this blue boundary, and that is the active viewport. So in rest of the viewports you will see this simple cursor, but in the active viewport you will see normal AutoCAD cursor. Now if you want to make any other viewport active, simply click on that once and that will become active as shown by this blue bounding box and also these navigation tools. These viewports are resizable, so if you want to change the size of this viewport, you can simply click on this boundary right at the center, and when this double-sided arrow appears, move it and that will change the size of the viewport. If you want to change the size in the horizontal direction, select it, move it like this. If you want to change the total size of viewports, click on this center, the intersection of all of these viewport line, click here, and now you can dynamically change the size of all of these viewports like this. You can not only change the size of these viewports, but you can even make more viewports. Now to make more viewports, go to this simple plus icon. So you'll see this plus icon on the top of this boundary line between the viewports, and when double-sided arrow appears, click and bring this green line. So that will be the partition line for your new viewport. Click here and we have 2 more viewports here. Similarly, if you want to add a viewport here, click on this plus icon and add it like this. Now we have lots of viewports in the drawing area. Let's say that we want to merge some of them. So to merge them together, select this join tool from the model viewports panel, and now click on the first viewport, click on the second one, and they are now joined together. Similarly, if you want to join both of them, select join, select the first one and the second one, and they are joined, and the final viewport will take the configuration of the initial viewport. So wherever you clicked first will become the view of our final joined viewport. In this case, if you want to make any viewport final and if you want to make a full screen viewport, then select it. So here we have it. Now let's say that we want to make this as the final full screen viewport. I'll bring this object here in the center, and now double click on this plus icon. So that will make it completely full screen viewport. To restore it back, double click on this minus sign icon, and here we have it. The viewport is now restored again. In order to save the configuration of these viewports, you can create a named viewport. So go to the named option here and go to new viewports and give this viewport a name. So I'll name it as our viewport and click on OK. So now this condition or this configuration of viewport is now saved. In order to restore the viewports, you can click on this restore, and here we have it, the normal default viewport. And if you want to go back to the same viewport, obviously you need to go to this named option, and from this named viewports select our viewport, click on OK, and here we have it, the viewport is now restored. This model space viewport is especially helpful for 3D drawings where you want to view the same 3D drawing from different perspectives. So to explain that, I'll select this tab. Here we have a 3D drawing, the 3D USB plug. Now let's say that we want to view it from different angles. For that, I'll go to this corner and I'll simply double click on this viewport controls, the minus sign. And now we have the same drawing but from different angles. So we have the front view, the left view, and obviously the isometric view, and you can even change this view to top view or whatever view you want. So if you make changes in any single viewport here, the change will also appear in the rest of the viewports, and that's quite a great way of editing your drawings if you want to see the results directly in other planes also. So once again, I'll go back to the original tab, and that was all about model space viewports in AutoCAD. In this video, I will tell you about creating views in model space of AutoCAD drawing. So right now we have this drawing, and in order to see certain part of the drawing, you can simply zoom into that area and you can see that part in detail. But when you zoom out again, that view is permanently lost and there is no way by which you can directly move into that particular view. But using named views, you can save those views, and whenever required you can recall those views. So in order to save these views, you need to access the view manager, and for that you need to use the view command or its shortcut V. So type V on the command line and press enter. So this will open this view manager, and here you can create your views. So right now we are in the model space, so the model views will be created, and for that I'll click on this new. Now give this view a name, so I'll name it as room 1, and now here in the boundary panel click on this box. Now specify the area which you want to include in your view. So I'll select this area and I'll click somewhere over here, and then I'll click somewhere over here. So that will be the area which will be shown in our view. And now press enter and simply click on OK. And here we have the preview of view and all the properties related to the view, and the view name can be seen here in this model views tree. Now similarly you can add more views to this drawing. So I'll go to new again and now give this a name. So I'll name it as kitchen. Again, make sure current display selected, click on the box and select the area. So this is the kitchen area. I'll select it completely just like this. Now press enter and we have the kitchen. Click on OK, and let's add one more view. So I'll click on new and this time I'll select hall, and now here we have the current display. Let's click on this define window, and this is the hall area, and now press enter again and click on OK. So now we have these three views included in our drawing. So let's click on apply and click on OK. So the views are added in the drawing, and in order to access those views you can go to this option on the top left. So here we have this view controls, and when you click on this you'll see a long list of pre-made views, and these views are especially helpful in the 3D workspace. Since we are in the 2D workspace, we'll look into the views which we have created, and those can be seen here in this custom model views. So here when you click on this you'll see all the views which we have made. So we have the hall, kitchen and room 1. Let's select this kitchen and the drawing will zoom into that area. Similarly, you can click on this view, change it to something else, for example room 1, it will shift there, and in this way you can add as many views as you want in your drawing. You can not only add these views, but you can also modify the existing views. For example, let's say that we want to modify this hall view. So I'll go to the hall view first, and now currently you can see that this part of the hall is selected. Let's say that we want to include this hatched area also in the hall. So for that I'll select the view command. So I'll type V, press enter, now select the hall, And now here select edit boundaries. And now once again create a new boundary for this view. So I'll click here and I'll drag it up to this point. Now press enter and click on OK. Now let's zoom out and go to the view. So I'll click on Hall and here we have it. Now the hatched area is also included in our view. So in this way you can create different views and you can access them whenever required. Okay, so once again it's the question time, and here is our question. You need to make a rectangle with 7 by 3 unit as the dimension, and this unit can be anything. It can be inches, or whatever unit your drawing is in. And then assign hidden line type to the rectangle and a 0.5 line weight, and ensure that these properties are visible in the drawing area. So here we have this drawing, and I'll start with the rectangle. So I'll go to rectangle tool, click at a point. Now I'll type add on the command line and then 7, 3 and press enter. So there we have it, the rectangle. Now we need to assign hidden line type, and to assign it we need to first add it in the list. So when I go to properties and I click on the drop down, you'll notice that we don't have the hidden line type, so we need to add it here. And to add it, I'll select other. Now click on load and select the hidden line. So let's scroll down. There we have it, the hidden line. Let's click on OK, and now it's added to the list. Click on OK again. So now it is added. We can assign the property. So I'll select the rectangle, click on the drop down and select hidden, and there we have it. Now the properties are also visible clearly, but in case the property of this hidden line type is not visible even after applying the hidden line type, in your case if it is looking like a solid line, then you can select it, then right click and go to properties, and from this property panel you can change this line type scale value. So you can either increase it or decrease it to give it a proper look. So I'll close it for now. Now we need to change the second property, which is the line weight of 0.5. So here we have the line width. Click on the drop down, change it to 0.5, and there we have it, the 0.5 line weight. Now here we have a problem. Even after applying the line weight, it's still showing the line weight of original rectangle. So in order to see the change line weight, click on this line weight display option on the status bar. And there we have it, the changed line weight is now visible. And if this line weight display option is not visible on the status bar, you can go to the customization and add this line weight from here. So that's the final geometry as per our requirement. So let's start adding hatches and gradients to our drawing, and we will start with the simple hatch pattern. So here we have a simple drawing, and in this case we have this drawing divided into many different parts using the geometries, and we will apply different patterns of hatches on different areas. So I'll start with the hatch tool here on the draw panel. So click on this hatch tool, and that will open this hatch creation tab. So this tab will remain active as long as the command is active, and here we have all the options which are related to hatch. So let's start with the first option, which is pick points. So select this pick point, click on it once, and the cursor will change into this point selection cursor. By default also the cursor will look like this point selection cursor, but if your cursor is different, if it is like this, the pick box type, then click on this pick points to change it to this point selection cursor. Now let's move to the drawing area, and when you'll move, you'll notice that whenever the cursor finds an island, the hatch pattern will be applied there. So as I moved my cursor here, the complete area got highlighted and the hatch will be applied here. Now let's move my cursor, I'll move it to this area, and now the hatch will be applied here. So you can see that the hatch pattern will change depending upon the area where I am clicking. So in this case the hatch pattern will be applied here, and you can see the preview here. So let's now select this area for applying our hatch. Okay, so now our pattern is applied and the default pattern of NC31 is here. Obviously this is not looking like this NC31 pattern because the scale is not correct, which will change. But first we need to look into other patterns also. So we currently see this solid angle NC31 and NC32 patterns, but there are a lot more patterns available in this hatch tool. So let's click on this small arrow right beside this pattern panel, and it will show all the remaining patterns which are available here. So you can select any of these patterns from this list, and you can even create your own pattern if you want. So I'll select this gravel pattern for this case, and even when I change my pattern to gravel, still it's looking like a solid pattern. Obviously we'll take care of this also. So let's first move to the next option here. So here on the properties panel, we can change all of the properties which are related to the current hatch. And the first property that we need to change is the scale. Obviously the scale is not correct, that's why we are seeing this as a solid hatch. So here we have the scale option, which is set to 1. Now let's change the scale value to 100 and press enter or tab key, and now the hatch pattern is visible. So we need to change scale to even higher value, so let's change it to 200, press enter, and now this looks appropriate. So I'll keep this scale. So now the scale has been applied. Let's look at the other options here. So obviously we have applied the pattern. You can select what we want to apply, for example either solid, the gradient, which will learn in a moment, and also the pattern. Obviously we have some user defined patterns also, and if you have defined you can select that as well, but that we are not going to select for now. Now here in this drop down we have an option of changing hatch color. So currently by layer is selected, so that simply means the color of layer will be applied to the hatch, but you can select any of these colors, and obviously you can go to more colors if you want to select from any of these tabs. So obviously we don't need to change the color as of now. And here we have the background color for our hatch. So if you want to change the background color for your hatch, you can select this option here. So obviously in this way you can select the background color. So we are not going to change that also. Now we have the option of hatch transparency, which is set to 0. So obviously in this case also you can change this transparency value from 0 to 90, 90 being the highest value, and that will make your hatch pattern a little bit dim. So you can move this transparency slider towards right, and as you can see that the transparency is changing and it's making our hatch pattern more dim, and you can move it here to keep the default value. Also we have an angle here which is set to 0, so you can change this value, and this angle will rotate the pattern, the current pattern of your hatch. So you can change that value. For example, let's enter 45, press enter, and you can see there is a rotation in the pattern of these hatches. Although it won't be apparent or very much visible in this gravel pattern, it will be very much visible with other straight line pattern, so that also will look. For now I'll change this value back to 0. Okay, so now we have changed these properties. Let's expand this properties panel and look at one more option here. Now here we have an layer assignment. So currently you can see that the hatch pattern is assigned to this line layer. So if you want to assign it to any other layer, you can select it from here. For example, I'll select this hatch layer, which is already made for these hatches. So now only these hatch patterns will be assigned on that hatch layer, and obviously we'll learn about layer in the next module. So once these settings are done, simply click on close hatch creation, and here we have our final hatch. Now that's not the only way of making hatches, and there are also other ways of making it. So I'll simply select this hatch pattern and I'll delete it. Now let's go to this hatch tool again, and once again we'll select some areas. So first I'll select this area, and then I'll select this area, this one, and this one. So in all of these areas we need to change the pattern. So obviously this gravel pattern is not required here, so I'll click on this arrow to expand this list of hatches, and I'll select the NC31 pattern. So that's the pattern which is applied here. Now if you want to add more areas, you can obviously select it by simply selecting the island here, or you can also select this option, the select option, and that will allow you to select the boundaries. So now you'll see that your cursor changed into a pick box, and you can simply click on the boundaries now, and that area will be selected for your hatch. You can simply repeat the process for this side as well, and here it is. So these are two different ways of selecting hatches, either with a pick point or with the pick box. Obviously, if you need to remove some of the boundaries, you can select this remove option, click on the boundaries to remove the hatch patterns. So here we have it. So now we'll apply this hatch pattern and we'll change the angle also. So in this case you can see that the angle is 45 degrees, but that will be the default angle of hatch. Now let's move on to this angle option, which is set to 0. So now you can change this angle, and when you'll change this angle, so let's now change it to 45 and press enter. You'll notice that the lines will become completely vertical. So in this case, the angle measurement will start from the current angle of your hatch. Initially the hatch was inclined at an angle of 45 degrees, so changing its angle to 45 degree will add 45 degrees more. So that will become a 90-degree angle with respect to the positive side of x-axis. That's why we have this vertical angle here. So I'll change it back to 0. And we have many other options here, like the origin, associative hatch, and there are some other options in this options panel, so that will look in upcoming videos. For now I'll simply uncheck this associative option and I'll not change any of these properties, and simply I'll select this close hatch creation, and here we have it. The hatches are now applied. So in this way you can create simple hatches in AutoCAD. Okay, so now let's have a look at some of the other options of hatches, like set origin and associative hatches. So here we have these two simple rectangles and both of them are of same dimensions. Now let's move on to this hatch tool and I'll select this NC31 pattern. I'll keep this pick points active and now click on this area. So in this case I've selected this area of the rectangle, and here make sure this associative option is checked. Now I'll simply close this hatch. Now we'll create a new hatch pattern here, but this time we'll make it non-associative. So once again I'll go to this hatch tool, same settings in this case also, but simply uncheck this associative option. So now click on this area and close hatch creation. So you'll find no visible difference in between these two hatch patterns, although one of them is associative and the second one is not associative. So let's select this hatch pattern, and in this case you'll see this simple grip. Now in this case we have the grip at the center, but we also have the boundary grips. Now that's not the only difference. In this case let's select the boundary or the rectangle and let's move it, and the hatch pattern changed itself. Now let's do the same thing here. I'll select this and I'll move the boundary, but now the hatch did not move. It's still at its initial position. So that's the actual difference between an associative and a not associative or non-associative hatch. In this case you have additional boundaries along with the hatch. So now here we have the boundaries, and you can use these boundaries to move the hatch pattern like this. Now let's press Ctrl Z to get back to the original rectangles, and now we'll learn about the origin option. So let's select this hatch pattern, and this time I'll select a different pattern. Let's select this ARB816 pattern, and now click in this area. Now the hatch pattern scale is quite big and we need to change it. We need to actually decrease its value in order to see it clearly. So I'll go to this scale and I'll change its value to 0.1 and press enter. Okay, so that's the hatch pattern here. Now look at the hatch pattern which is applied here. Now in this case the pattern started from any random point and it's now following the rest of the geometry, but we don't have control over the full block size. Now let's say that we want a full block on this corner. We want the complete block to start from this side and we want the rest of the block to follow that pattern. Now for that case you can specify an origin point, and to do that select this set origin option and click at a point where you want to specify the origin. In this case it will be this point. Now click here and you'll notice a change here. Now this side we have this complete block and rest of the blocks will follow this origin. Similarly, if you want to change the origin you can select it here as well or any other point. I'll go to set origin again and I'll click at this point. Now the origin changed to this point. So that's the set origin tool. You can use this tool on other patterns also. For example, I'll select the same hatch tool. I'll select the NC31 pattern and I'll change the scale to 1, and let's apply the hatch here. Now if you zoom into this area, you'll notice that the hatches are not starting from this vertex. Now what if you want the hatch to start from this vertex? Obviously you can change the origin. So go to set origin, click on the vertex, and the first hatch will start from this vertex and rest of the hatches will follow the pattern. So in this way you can precisely change the pattern of hatches and you can specify the origins, and it will be very helpful in many cases. For example, if you want to make a tiled pattern somewhere on the wall, then this can be really helpful in deciding the side where you want the full tile to remain visible. So let's now click on this close hatch creation. And that was all about the set origin and associative option of hatches. Now let's have a look at some of the advanced features of the hatch tool. Now here we have a fairly complicated geometry, and in this case we have multiple areas which are again inside any other area. For example, the first rectangle, then the second one, circle, rectangle. So one area is within the next and there is another area within the next. Now let's go to the hatch tool and I'll select this NC31 pattern for the sake of simplicity, and I'll start applying the hatches. So in the first case, when you select any area, the island will be detected or the immediate boundaries from the point where you click will be detected. So in this case, the outer boundary will be the circle and the inner boundary will be this rectangle. Now whatever the area falls in between these two extreme boundaries will be hatched. So that's the simple island detection. Now if you want the hatch tool to ignore this kind of island detection, you can change its options. So go to this options panel and expand it, and from here you can find this island detection tool. So click on this drop down and select ignore island detection. Now move back to the same area, and this time we don't have any inner island detection. Simply the rectangle is ignored, and if you click inside the rectangle, obviously there is no other island and it will completely hatch it. But if you select this area, once again all the internal geometries will be ignored. There will be no island detection. Obviously the outer island will still be recognized. So in this way you can change this option, and it is really helpful if you have plenty of objects inside any outer boundary that you want to include in your hatch. Now let's go to this options, and from here once again select this normal island detection, and we once again have this island detection. Now let's select the hatch tool once again, and I'll try to apply the hatch in this area. So when I move my cursor here, the hatch will be easily applied. If I select this area, the hatch will again be applied. But when I move my cursor to this area, the hatch will not be applied, and there is a very simple reason for that. Here we have a small gap. So currently the closed boundaries are not found, and that's why the hatches are not applied. But if you try to apply the hatch in this area, there will be a warning message, and this simply states that a closed boundary is not determined. But that simply does not mean that you cannot apply any hatch pattern in this area. You can still apply the hatches in this area using the gap tolerance. So I'll close this hatch creation and I'll remove both of these hatches, and now I'll once again select this hatch pattern. Now I'll click in this area, and obviously you'll find this error message. Now we need to change some values in order to apply the hatch here. Now go to this options panel, expand it, and here you'll see this gap tolerance option. So you need to increase the gap tolerance, and the gap tolerance value should be approximately larger than the value of gap here. So whatever the gap is here, the value of gap tolerance should be greater than that. So I'll simply type DI to find out the gap here, and the gap here is 4.70 units. So let's add a value of 5 in gap tolerance. So select the hatch pattern, expand this panel, and add a gap tolerance of 5 and press enter. Now let's go to this area again and click here, and now we have this message box which is different from the message box which we saw earlier, and here we have this continue hatching this area option. So select it and the hatch will be applied here, and that's only because of gap tolerance. Now click on close hatch creation, and here we have it. The hatch is applied even when there is an open area. So now let's erase it and let's look at other options. So once again I'll select the hatch pattern, and now I'll select multiple areas to create our hatches. So I'll select these 3 areas, and now I'll close the hatch creation. Now in this case, when you click on any of these hatches, you'll find that all of these hatches are selected because I've selected all of these areas in a single run to make this hatch, and that's why they are treated as a single unit. Now you can make them as separate hatches by making the hatches one by one. So you can make this hatch, then exit the command, then make this hatch pattern and exit the command and repeat the process for the last one. Or you can also select a different approach. So I'll first erase this hatch pattern, and now once again I'll go to the hatch tool, select the first area, the second one, and the third area. Now here expand this options, and here we have a create separate hatches option. So click on this create separate hatches. So that will ensure that these hatches will be treated as separate entities. And now click on close hatch creation. Now select any of these and they are completely separate from one another. There is also a draw order for hatches, so I'll erase this complete hatch pattern, and now once again I'll select the hatch and I'll select any area. So let's select this area first. Now in this case we have a boundary and also we have an hatch. We don't know whether the hatch is overlapping the boundary or it's other way around. So in order to check that, again expand the options panel, and here you will find the option. So currently the hatches are behind the boundary. As you can see here, it's sent behind the boundary option, which is now selected. So let's keep that option active. The hatches are behind the boundary, and close the hatch creation. Let's go to the hatch again, and this time change the option, and let's change it to bring in front of the boundary, and apply the hatch here and close it. Okay, so in this case the hatch is above the boundary, here behind the boundary. Let's see the difference. Let's move on to the boundaries here, and in this case you will be able to select the boundaries because the hatches are behind the boundary. Now in this case, when you move to the boundary, the hatch will be selected, and that's quite evident because the hatch is overlapping the boundary. So that's the subtle difference between these two hatch patterns. You can also change the draw order of hatches, and to make it clear I'll once again create a new hatch pattern. So select this hatch, click on this area to apply the hatch pattern, and I'll change the color of this hatch to red. And now here we have these options. Let's click on this drop down, and here we have many options here like the send to back and bring to front. So let's select this send to back option, and now click on close hatch creation. Now the current hatch pattern has been sent to back, but it's obviously not making any difference. So in order to see the difference, let's bring the hidden text. I have already created a text here, so I'll just bring it in the drawing area using this end object isolation, and now you can see clearly that the hatch is behind this text. Now what if you want to bring this hatch above the text? For that you can modify this hatch. Select the hatch, once again go to the options, and from here bring it to front. So let's select this bring to front and close the hatch, and now you can see that this hatch is clearly overlapping the text. So that's the difference between the different draw orders. So in the previous case it was behind the text, and now it's above the text. So you can select any of these options. So that was all about some of the advanced features of hatch. So let's have a look at the boundary and wipeout tools. So I'll start with the boundary tool, and here we have the simple drawing. Now in this case, let's say that we want to find the area of this region. So obviously we can use the area tool, and that's an efficient way, but still we have an alternate way of doing that, and that's by creating the boundary. So here on the draw panel, when you expand this hatch flyout, you'll see this boundary option. Select it, and now you'll see this boundary creation option. Now we have a pick point here, and also we have the object type. So here in the object type, select polyline, and now select this pick point and click at this point. Now when you click at this point, you'll notice that this complete area will be highlighted. So that's the boundary which will be created. Now press enter and we have a boundary. Now click on this boundary and the boundary is highlighted, it's now selected, and you can find the area of this complete polyline to find the area of this region. And you can simply do that by going to the property palette. So right click, go to the properties and scroll it down, and here we have the area, which is 3662.305 square units, and also the perimeter or the length of this complete boundary. So that's quite an easy way of finding the area, and there are also many other applications of this boundary tool. Also, you can use this geometry separately, so you can click on this boundary, move it elsewhere, and you can use it. Similarly, you can create a boundary with the region tool. So in this case, the boundary has been created with polyline, as you can see on the tooltip. Now I'll select the same boundary tool, and this time I'll change the object type to region. Now click on the pick point, and this time I'll select this pick point, press enter. Now we have a region boundary, and obviously you can move it using this grip, and here also you can find the area using the property palette. So we have the area and perimeter and also the boundary, so you can use any of these methods. So let's now erase both of these boundaries. In AutoCAD, the hatch patterns have a unique property of avoiding any object which is already present in the island. For example, here we have this text. Now I'll apply a hatch pattern on this island or in this area. For that, I'll select the hatch tool and select this NC31 pattern and click on this area. Now when you click on this area, you'll notice that the hatch will completely ignore the area which is covering this text. In that way, the text will remain legible against the background. Now click on this close hatch creation, and here we have the hatch. Now what if you decide to make this text after creating the hatch? In that case, the hatch will completely overlap the text, and for those cases you can use the wipe out tool. So let's create a hatch here, and then we'll copy this text here. So go to the hatch tool and click on this area, and let's change the color of this hatch to green in order to clearly separate both of these hatches, and click on close hatch creation. Now we'll copy this text on this area or on this hatch. So select the copy tool, click on the text, press enter, move it on this area. Now we don't have any clear boundaries here, and obviously the text is not very clearly visible against the hatch background. So there are a couple of ways to make it very clear, and in order to remove these hatches along the boundary of this text, you can use the wipeout feature. So before using the wipeout feature, I'll make a rectangle. So go to the rectangle and create a rectangular boundary around this text. So this text boundary will be used for clearing up the hatches. Now select the wipeout tool. So expand the draw panel and select the wipeout tool from here. Now we have an option here which is polyline. Select this polyline and select the polyline here, and here we have an option of erasing the polyline. So whether we want to erase the polyline or not, you can select it here. I'll select yes, we want to erase the polyline. So now the hatch patterns are clear, but we still have a problem. The text is not visible, and in order to bring this text in the front of hatch and in order to make it visible, we need to change its draw order. So select the text. When you'll move your cursor, you'll see that the text will be highlighted and you can select it. Now type draw order and press enter. Now we need to move it to the front. So simply select this front option, and here we have it. The text is now visible. Now there are also other ways of clearing the area. So I'll select this rectangle and I'll erase it, and simply by erasing the rectangle we can again bring back the hatches. Now I'll go to this wipeout tool once again, and now I'll create a frame around this text. So you can simply click on different points to create the frame. You don't need to necessarily have a frame or a polyline, and here we have it. Now simply press enter, and here we have the wipeout region. And in this case also, in order to bring it to the front, you need to select the text and change its draw order. So select the draw order, click on front. Here we have the text. Now the frame is visible in these cases. Now if you want to hide these frames also from the drawing area, you can use wipe out frame system variable. So type wipe out frame, press enter, and now change its value to 0. And we don't have any frame boundary here. So in this way you can change the values of the system variable to make this wipeout frame even more visible. So that was all about wipeout and boundary tools. In this video I will tell you about creating gradients, which are different patterns of colors in our AutoCAD drawing. So for creating the gradients, go to the draw panel and expand the flyout and select the gradient tool. Now you'll see a very familiar hatch creation tab, but we have some simple difference here. In the pattern we have these gradients, the color gradients, and also we have a new centered option here. Now we can select the pattern of colors which we want to apply from this list. So let's select this gradient linear. Now go to any area and obviously it will detect the island as it did in the previous case of hatch creation, and it will apply the gradient there. We have gradient of yellow to blue transition, and that's selected here, the gradient linear pattern. Now if you want to change the colors of this gradient, you can select this menu and you can change the colors from here. So I'll select red as the first color, and for the second color let's change it to this cyan. Now we have this transition here. If you want to apply the gradient in more than one area, then you can also select multiple islands here. And to exit this, simply click on close hatch creation. Now let's go to the gradient tool again, and this time I'll select this circular area. Now in this semicircular area we have this linear gradient, but I'll change it to this centered. Now I'll select this area also, and you'll see that in this case the complete circle will be taken as the hatch boundary. Now the gradient is applied here, and also we have a centrally aligned highlighted area. If you want to change that, if you want to change the highlighted area, you can simply uncheck the centered option, and that will make this highlighted area off-centric, just like this. Now in this case, if you want the hatch to apply on this complete circle, then make sure that this create separate hatches is unchecked. So currently the create separate hatches is checked, so click on this to uncheck it, and now both of these hatches will be treated as a single region. Click on close hatch creation and we have a single hatch here, just like this, although we had a boundary here. So that's very much similar to the hatch creation, but instead of making hatch pattern we have the colored gradients. Now if you want to apply a solid color, then select the gradient, or you can also select the hatch tool and select the solid pattern from this list. So select the solid, select the color which you want to apply. For example, in this case let's select this color and select the area where you want to apply it, and click on close hatch creation, and there we have it, the solid color applied to the island. So that was all about the gradient tool of AutoCAD. So here is our question related to the module. We need to create an associative hatch in a rectangle of length 10 and width 5 unit with these properties. The pattern should be NC31. The origin of that pattern should be lower left vertex of the rectangle, and the scale should be any scale which is clearly visible, and the scale in which the lines of the hatch pattern are clearly visible. So here we have the drawing. Let's start with the rectangle tool. So I'll click on rectangle and click at a point. Now I'll type at and a length of 10 and a width of 5 unit and press enter. So there we have it. Now we need to add the pattern here. So for that I'll go to this hatch tool and make sure this NC31 is selected. Also we need to ensure that this associative option is checked. So with these two options, click inside this area, and here we have it. The hatch is quite clearly visible, but if it is not visible in your case, you can go to this scale and change it. In this case I'll change it to 2 and press enter. There we have it. Now it's widely spaced, and now we need to change only one property here. We need to change the origin. So in this case the origin should be lower left, which is this point. So let's zoom into this area. So here you can clearly see that the origin is not clearly specified and the line is starting from somewhere on this horizontal line. So we need to ensure that this line should start from this vertex. For that, I'll click on set origin and click on this vertex. There we have it. Now it's starting from the required point. Now let's zoom out, and there we have it, the final hatch pattern. So let's now click on close hatch creation, and there we have it, the drawing as per the requirement. So now let's start with the layers. So layers are simply the categories in which you can put your objects. For example, here we have this drawing with simple line, polyline, text, dimensioning, hatches, and many other things. Now let's say that we want to put different type of objects in different categories. Then for that condition, layers can be used. So using layers, you can put all of the dimensions on a separate layer. Similarly, you can put all of the text, geometries, and hatches on different layers. So that will help you in managing the drawing more efficiently. So right now we have all of our drawings on a single layer, which is layer 0, and that can be seen here. So we have this layer 0, and which is available in the drop down. Now click on this drop down and you'll see that we have this single layer which is 0, and also this def point layer which is automatically created whenever a dimension is added. So we'll learn about this def point layer later on. Now in order to add any layer, you need to go to the layer properties manager. So click on this layer properties manager and this palette will appear. Now you can expand this palette just like any other palette, and you can change its size. Here you'll see lots of different options which are related to this layer properties manager. If these options are not clearly visible, simply right click on any one of them and select maximize all columns, so that will make all of these options visible. So right now we are not interested in these options, rather we are interested in adding more layers. So currently we have this 0 layer, and you can see this checkbox along the 0 layer that indicates that this layer is active, and all of the drawings which are made currently in this drawing area will be put on this 0 layer. Now we also have a new layer which is def point, and this is automatically added. In order to add a new layer, you need to click on this new layer icon. Now click on it and now give this layer a name. So by default it will be named as layer 1, layer 2, and so on. So I'll name it as dimensions. So I'll type dim for dimensions and click anywhere in this palette, and now click on this icon once again, and this time I'll add hatch as layer name. Click again and now click on it once again and add a new layer, text, and click anywhere else, and that's sufficient for now, but I'll create one more layer. So let's click on this again and I'll leave its name as layer 1. Now in this way we can add as many layers as we want in this list. There is no limit to that, and if you want to delete any of these layers, you can simply select that and click on this delete layer, and that layer will be deleted. There are certain restrictions and you cannot delete some of the layers, and to know that I'll select this layer 0 and I'll click on this delete. Now this warning message will appear, and that will tell you about the layers which cannot be deleted. So in this case layer 0 and def points cannot be deleted, and we were trying to delete layer 0, that's why it was not deleted. We also cannot delete the current layer. So currently active layer is layer 0. Obviously if some other layer would have been active and if you try to delete that, that will also not be deleted. Also if you have layers containing object, that won't be deleted, and also xref dependent layers. We'll learn about xrefs also later on in upcoming modules. So these are the layers that cannot be deleted. So let's close it, and let's now assign different objects from this drawing to these layers. So currently we have the 0 layer active, and with that I'll close it. Now let's say that we want to first assign all of the dimensions on dim layer. For that, select any one of the dimension and then right click and select this option, select similar. So that will select all of the dimensions which are present in this drawing. Now go to this drop down and select the dim layer, and all of these objects are now present on dim layer. So let's press escape key, and if you want to check that, simply click on any of these dimensions, and when you click that, you'll notice that here we have this dim layer visible, and if you uncheck, if you press escape key, you'll see the 0 layer which is currently active. Now in a similar way we will assign hatch layer. So I'll select this hatch pattern and I'll go to the home tab and I'll assign it to the hatch layer. Also we have one more hatch pattern here, so let's select it also and let's again change this to hatch. Okay, now we have some text here, so let's select the text, then right click, select this option, select similar, so that will select all of the text in this drawing, and once again go to the drop down, select text. So now we have assigned some of the objects on different layers. So that was the introduction of layer. In the next video I will tell you about changing properties of these layers. So let's have a look at the layer properties manager palette. So when you click on this layer properties icon, this layer properties manager palette will open up. Now this is just like any other palette in AutoCAD. You can resize it, you can dock it, you can hide it, and if you move it to this side it will dock it automatically. In order to release it, simply click on this and bring it outside. Now this layer properties manager has a list of all the layers and its related properties. The layer which is currently active will be shown with this green check mark, and you can change the status of currently active layer by selecting any other layer and clicking on this icon, so that will set current that layer. So in this case we have this dim layer which is now active and which is now set as the current layer. So by simply setting any layer as the current layer, you are essentially telling AutoCAD to make any new geometries on that layer. So in this case I have set dim layer as the current layer, so I'll now hide this palette and now I'll make a new drawing. And this drawing will be made on dim layer. So when you click on this object, you'll notice that we have this dim here. That indicates that the current layer for this object is dim. Even when you uncheck it, you'll notice that dim layer is active. But if you select any other object, for example this object, the layer changes to 0, which was the active layer for this object. Similarly, if you select this text, it will change to the respective layer, which is text. So in order to make any of these layers active, you can activate that layer from this layer properties manager simply by selecting that layer and clicking on this set current option, or you can also make it active layer from this drop down menu. So click on this drop down and change it to something else, for example this layer 0. Now we have 0 layer as active layer. Now I'll make a new geometry and it will be made on layer 0. When you click on it, layer 0 will be shown here. So let's now erase both of these geometries and let's expand this layer properties manager. So you can change multiple properties of a layer. We'll start with the color. In this case, here we have this color column and all of these layers have a single color which is white, and that's the color which we see here. Now let's say that we want to change colors of some of these layers. I'll start with the dim layer. So we have this dim layer. Let's select this color box and this will open this select color window. Now from this window you can select any of these colors, and if this window is not sufficient you can select the colors from this true color. That will give you more options to select the color, or you can use color books. For this case I'll select index colors and I'll select this green color and now click on OK. So the layer has been assigned green color and all the objects on this dim layer are now taking that property. So you can directly see it in the drawing area. Also we have all of these dimensions now colored in green. Let's move to the hatch layer and we'll change its color to cyan and click OK. Similarly, we can change the color for text layer. You can change it to red if you want, or any other color. And we have this C line layer also. Let's select it and let's change it color to magenta and click on OK. So in this way you can apply different colors to different layers, and that will help you in identifying these different objects in the drawing area. Now we have some properties here like on, off, freeze, thaw and lock, unlock. Now we'll have a look at that, but before that I'll simply move this palette over here and I'll move this drawing area just towards right. Let's decrease the size of this palette also. Now we have this complete drawing in view. So we have this on and off option, and using this on off option you can hide some of the objects from your drawing area. For example, here we have this dimension layer. Now if you click on this light bulb icon, it will turn off this current layer and all of the objects in that layer will hide from your drawing area. To bring it back, simply click on this bulb icon again and it's back in the drawing area. Similarly, you can freeze any of these layers. So here we have an option of freezing the layers. So when you click on this freeze icon, it will freeze it and you can click on it again to thaw it or bring it back. So visibly, on and off and freeze thaw have same effect on the drawings, but when you freeze your drawing, not only the objects become invisible from the drawing area, but they also become invisible from the background processing of your PC. So when you freeze any of these layers, the objects on that layer will not be counted for regeneration. So AutoCAD will regenerate or refresh your drawings without considering those objects. So that will improve the performance of your software visibly, and this is especially helpful for large drawings. So in large drawings you can freeze the layers which are not required to improve the performance of your drawing and of your software as a whole. So for small drawings, on and off and freeze thaw will have no visible effect apart from hiding the objects. Now let's have a look at this lock and unlock. So using this lock layer, you can simply lock the objects and it will become uneditable. So you won't be able to modify objects on that layer. Also, when you lock any of the layers, the objects on that layer will dim in color, and you can see that the transparency has been increased here. Now we have the 50% transparency, and this small lock icon will also appear along the cursor. The transparency of this locked layer can be controlled by this transparency slider. So you can bring this slider here to restore the complete transparency, or you can move it here if you want to increase the transparency, just like this. So I'll change its transparency back to 50%, and I'll also unlock this layer. So we not only have these many options, we also have lots of other options in this palette. So let's expand this palette. And now we have this line type. So obviously you can change the line type also, but for line type I'll select this C line layer. Now in this C line layer we have this continuous line type. Let's click here and let's select this center line type instead. Now if not many line types are loaded here in the drawing, you can simply click on this load and you can load more line types like ISO dash, and you can use it. So let's use this center line type for this case, and I'll click on OK. And when you look into the drawing area, you'll notice that the line type of the object on that layer will change. Similarly, you can change the line weight. So I'll change the line weight to 0.3. Click on OK, and here we have a visible result. And obviously you can change the transparency. So the value of transparency will range from 0 to 90, and you can change it to any value which you want. So I'll select 70 and click on OK, and here we have it. The transparency has been reduced. In case of line weight and transparency, you need to ensure that this line weight display and this transparency display status bar options are active in order to see its effect. So if you turn off this line weight display, obviously the line weight will not be visible. Similarly, if you turn off this transparency option, the transparency will not be visible. So make sure that these options are active. There is also an option of this plot. Now when you turn off the plot for any of these layers, the objects will not be plotted. For example, I'll turn off the plot for this dim layer which contains this green object or the dimensions. So let's zoom out and let's decrease the size of this palette. Now all of these dimensions will not appear when you plot your drawing. Whether you print it on a paper or you take the output on a PDF file, it will not appear. To make it visible, you need to ensure that the plot is on. The def points layer will always have this plot turned off by default, and you cannot change this value. So let's decrease the size of this palette, and that was all about the Layer Properties Manager palette. In this video, I will tell you about Layer States Manager and Layer Walk tools. So let's start with the Layer States Manager. So in this case, we have this drawing and most of the objects in this drawing are assigned on different layers. For example, the dim layer for the dimensions and the text layer for the text. Also hatch layer for these hatches. We also have a C line or the construction line layer for these construction lines. Now there may be situations when we want different states of layer in which the behavior of layer are quite different, and we may need to preserve that state. To make this clear, I'll make a couple of layer states. So expand this layers panel and click on this push pin, so that will keep this layers panel always open. Now here we have this layer states manager drop down. Now click on this drop down and you'll see this new layer state and also the manage layer states option. So select this new layer state first and give it a name. So I'll name it as all active. So that's simply the name of current state of layer. I'll click on OK, and now this state of layer is saved, in which all the layers are on, all the layers are not frozen, they are unlocked, and they have these conditions of these colors and all the other settings. So that's simply a layer state which is now saved as all active. Now let's make some changes in this state. So I'll click on this drop down and I'll turn off some of the layers. So I'll turn off the dim layer and I'll also turn off this hatch layer. Now we have dim and hatch off, and let's save it as a new state. So I'll click on this drop down and I'll click on new layer state. So let's type dim dash hatch off. Okay, so these two are off. Now click on OK. So we have this second layer state. Now let's go to this drop down and once again change the layer state. So I'll turn both of these on, and this time I'll simply lock the dim layer and I'll also lock the construction line layer. Now let's save this state. So go to this layer states, new layer state, and let's type lock as the name. So that's all. Now click on OK. So we have these three layer states which are saved here: all active, dim, hatch, and lock. And when I move my cursor over these layer states, you will be able to see a preview of what the condition of layers were when they were saved in these states. So in all active, all of the layers are active, and if you want to see this layer state, simply click on it and all of the layers will become active. Now if you want to see the second layer state in which dim and hatch layers were off, simply select it, and now we have dim and hatch layer off. So simply you can toggle between different layer states using this layer states drop down. If you want to manage more about these layer states, click on this manage layer states, and now we have more options. For example, if you want to change the name of any of these layer states, simply select that and click on rename. So I'll rename it as dim lock and click anywhere to change the name. So this has been changed. Now if you want to export this, you can also export it and you can also import them. The layer states file are saved with LAS extension, so you can obviously use them. So let's now close this and let's get back to the all active layer state. Now we also have another tool which is lay walk, which is helpful in managing a long list of layers. So the lay walk tool can be found here. So here we have this lay walk. You can also use its command equivalent lay walk. So let's select this lay walk tool, but before selecting that, I'll just move my drawing towards left and now click on this lay walk. So this will open this layer walk window. Now in this window you'll notice that all of these layers are present and they are all active, as you can see here with the blue selection, but now only the text layer has been active. So using this lay walk you can make a selection of the layer. So I'll make all of them active first, and now all of these layers are visible. Now let's say that you want to see a couple of layers. For that you can selectively click on those layers. For example, we want to see only the dim layer, so click on the dim, and only the objects which are on dim layer will be visible and rest of them will become invisible. Similarly, you can click on any other layer and only the object of that layer will be visible. If you want to select multiple layers, you can press and hold Control key and click on multiple objects, and the objects of that layer will be visible. In a large drawing, it becomes very difficult to find out the exact layer of an object. So for those cases, you can also select this option. So at first, let's select all of these objects. So all of these layers, now they're active. Now let's select this pick box and now select the objects. So we have selected the dimension, and let's select the C line object and now press enter. So now only these two objects will remain visible, and you will be easily able to identify the layers which are currently active using this layer walk. Now if you don't want to keep this state, then you can select this restore on exit and close it, and then all the layers will return back to their original condition. But if you want to keep that state, then select the layer walk and select the layers here, and now uncheck this restore on exit option, and now this condition or this state will be retained. So let's click on continue when this warning message appears, and here we have it, the condition has been retained here. So let's once again turn on all of these inactive layers, and let's click on this push pin to release the layers panel. And that was all about layer states and layer walk tool of AutoCAD. In this video I will tell you about layer filters, and layer filters are very important tools for large drawings. So when the drawing generally becomes very large, it starts to accumulate lots of layers, and the layers can even range to hundreds or thousands of layers. So managing that many layers becomes a very difficult task, and with the help of layer filters you can really make that task easy. So in order to use layer filters, click on this layer properties to bring this layer properties manager, and now here we have lots of layers in this drawing. As you can see here, although the number of layers is not in hundreds, but still we have a fairly large number of layers. Now in this case, let's say that we want to classify these layers depending upon their characteristics or depending upon their properties. For example, the color, the name, and also the states like on, off, freeze, lock, and also the plot. So these conditions can be used to create different filters, and we can then select the objects based upon their filters. So in the first situation, let's create a layer filter which contains all the red layers. So for that, I'll click on this new property filter icon, and this layer filter properties window will pop up. Now let's name it. So I'll name it as red filter. And now we are selecting the color filter. Red is a color, so I'll simply go to this color column. So now click on this color column and you'll see this box. Now click on this box and select the color which you want to include in your filter and click on OK. Now the color has been included and we have all the layers with a red color. Now they are sorted out. Let's click on OK, and here we have a new red filter. If you want to go to the complete list of layers, simply click on this all used layers and we have the complete list. Now let's change the states of these layers. Let's turn off some of these layers, and I'll also ensure that the layers which are off, among those, some of them should have their plot turned off. So I'll turn it off. I'll turn off plot for many more layers. Now once again, let's go to this layer filter and let's name it as off no plot, and we want to create a filter with all the layers which are off and also with all the layers for which plotting is turned off. So I'll first go to this on and off option, and now I'll select this off. So now we have all the layers. Now we also need to select the second condition, which is plot. So go to plot and select no plot. So now we have these many layers which fulfill both the criterias. So all these layers are off and also the plot for these layers is off, and click on OK. So we have this second filter. In a similar way, you can use as many criterias as possible to create different kind of layer property filters. You can not only create the layer property filter based upon their simple properties, but you can also create them using their names. So I'll click on this all unused layers, and now let's have a look at the names of these layers. So the name of these layers are quite random. Let's say that we want to make a layer property filter that start with C. For that, I'll again click on this property filter and I'll give it a name. So I'll type C as the name, and now click on this name field, and now simply type C. So that will make a filter containing all the layers which start with C letter, and let's click on OK. So that's quite easy. But what if we want to create a filter which contains a set of alphabets somewhere in between the complete layer name? For example, we want all the layers in which the third letter is N. For that, I'll once again go to the property filter and I'll name it as N, and now click on the name, and now you need to specify this property using wildcards. So we want third place to be occupied with N, and all the remaining spaces can be occupied by any other letter. So for that, I'll select this question mark. So that will indicate that the first letter could be anything, the second letter could be anything, but the third letter should be N. And now the star or this asterisk mark after N indicates that rest of the letters could be anything. So in this case, you can simply see that the third letter is N in all of these layers. And we have our new layer property filter. So in this way, using different kind of wildcards, you can make a classification of different layers depending upon their properties. And you can not only create this layer property filter, you can even directly use it here in the layer search. Now for example, if you want to search for any layer in which third letter is B, simply type question mark B, and here we have it. The layer with third letter as B will be visible with all of its properties. So in this way you can use this layer search as well. So that's the layer property filter. We also have a group filter, and using the group filter you can add the layers manually that may or may not have any properties in common. So for creating the group filter, click on this new group filter icon and give it a name. So I'll name it as new group. Let's press enter. Now once again I'll double click on all unused layers, and now you simply need to drag and drop all the layers which you want to add in this filter. So I'll select this AM0, add it in this new group, and I'll randomly select some of the layers and I'll add it in this new group. Okay, now double click on this and we have all the layers which we have added, and these may or may not have some properties in common because we have manually added them here. Now there is also an option of inverting the filter. For example, let's just select this red filter, and obviously in this red filter you'll find all the layers containing red as its color. Now if you want to invert the filter, simply click on this invert filter icon and you'll have a list with all the layers except the layers containing red color. In a similar way, you can invert the filter for all of these properties, for example for N, C, or all of these other filters. So that was all about creating layer property and group filters in AutoCAD. In this video, I will tell you about lay merge, lay del, and copy to layer commands of AutoCAD. So I'll start with the lay merge command, and using lay merge command you can merge two or more layers into a single layer, and that will also move all of the objects of the source layer on the destination layer. So to make it clear, I'll start the lay merge tool. So expand the layers panel and select this icon. So that is the lay merge icon. You can also use its command equivalent laymrg. So let's click on it, and now click on the source object, the object which you want to move. So in this case I'll select this letter, and that will select all of the objects which are on this particular layer, and now press enter. Now click on any object of the destination layer. So I'll select this object, the purple one, and click on it, and now you'll notice that the color of this object changes and all the remaining properties of this object will also change, and it will inherit the property from this target layer. So if you want to commit to these changes, simply select yes from the command line, and we don't have red layer anymore. So you can click on this drop down and you'll notice that we don't have that red layer which was named as text, and all the objects of that layer are moved to this new C line layer. To undo the change, simply press Ctrl Z, and we have this here, the text layer, which is here. Now let's look at the lay del command. So using the lay del command, you can simply delete some of the layers and also its objects. So it's not always recommended to use this lay del command, but if required you can use this command to forcefully delete the layers containing objects. So if you open this layer properties manager and if you try to delete any of the layer that contains object, for example here we have this text layer, and as you know that the text layer has some objects, so let's decrease the size of this layer properties manager and I'll move it here. Now we have this text layer and all of these red objects are on this text layer. Now if you try to delete it using this layer properties manager, you won't be able to do that because the layer contains object. That's this third criteria. Now if you want to forcefully delete it, then simply go to this layers panel, expand it, select this label tool, and now select any one of the object on that layer. And here we have it. All the objects from that layer are gone and also the layer will be purged. So if you want to commit to this change, simply press enter and select yes from the command line. And let's go to this drop down and we don't have that text layer, and also all the objects from here are gone. As I told you that there are some layers which are quite stubborn, for example def points that cannot be deleted, but using this lay del tool you can also delete this def point layer, although it is not recommended. This is quite an important layer which is automatically created and it stores all the definition points of the dimensions, so I recommend you not to delete these layers. But still, if you want to delete some of the layers which are quite stubborn and you don't want them, then you can use lay del command. So I'll once again press Ctrl Z to bring that layer back. Now let's have a look at copy to layer tool. So if you want to copy any one of the object from one layer to different layer, then you can use this copy to layer tool. So for that I'll expand this layers panel and select this copy to layer. Now click on the object that you want to copy. In this case I'll select both of these arrows, so I'll select this arrow and I'll also select this arrow. We want to copy this arrow and now press enter. Now specify the destination layer or the layer on which you want to put these arrows. So I'll select this C line layer object. Now it will prompt you to specify the base point. So you can specify the base point and move these objects somewhere else, and if you want to place it directly overlapping the first object, you can simply press enter and we will have overlapping objects. So in this case you may not find that overlapping object, but when you will move your cursor you will see this menu which indicates that we now have two objects. So you can select the original one and you can erase it. Now you can see that we have an overlapping object. Let's select this one also and I'll erase it here. Similarly, I'll repeat the process from this side. So I'll select the polyline, I'll erase it, and I'll select this polyline and I'll erase it. Now here we have it. So the objects are now moved to a new layer and they're also copied. Now if you don't want to do it in this way, if you want to make a copy of that, so you can do that also. So once again I'll select this copy to layer option and I'll select both of these objects and press enter. Now select the destination layer and select the base point. In this case I'll select this point as the base point, and now I'll specify another point somewhere over here, and here we have it. So now the copy of these layers will be made at the point which we have specified, and obviously these objects are on the new layer which we have assigned. So you can use this tool to create new copies of the object on different layer. So this was all about lay merge, lay del and copy to layer tools of AutoCAD. In this video I will tell you about some of the tools which are available on the layers panel for quick access. So when you go to the layers panel, you'll find that we have some tools here and you can use these tools to ease your task, and they are quite shortcuts which can be used directly without using the layer properties manager. So let's start with the first tool, which is on and off. So using this layer off, you can select the layers which you want to turn off. So select that tool and click on any object of a particular layer and all of the objects of that layer will be turned off. Simply you can click on this text and all of the text objects are now off. Now press enter to exit this command. In order to bring it back, simply select turn all layers on or lay on tool here, and all the layers will be brought back to the drawing. If you want to isolate some of the layers selectively, then you can select the second option. So using this second tool, you can select objects and all of the objects except your selection will be hidden. So in this case I'll select this object and all of the objects of this layer And also let's select this dimension. So all of the objects of layer 0 and the dimension will remain, and rest of the objects will be hidden. So let's press enter, and here we have it. So you only have the dimension and all the objects of layer 0, and rest of the objects are hidden. So you can use these tools for accessing some of the layer properties quickly and efficiently. Now if you want to bring all the objects back in the drawing area, simply click this icon, the unisolate icon, and here we have it. Similarly, you can freeze layers selectively. So select this freeze option, click on the object which you want to freeze, and the layer has been frozen. You can select layer 0 also, or any other layer to freeze them. Press enter, and now to bring them back, simply click on this thaw all layers option, and they are brought back to the drawing area. Similarly, we have this lock layer. Select this tool, click on the layer objects which you want to lock, and you need to press enter again if you want to lock more layers. So here we have it. To bring them back, you need to selectively select the tool and then click on the objects. So I'll select this object, and all of the objects of this layer are brought back. So I'll repeat this command, and I'll click on this object, and again it's also unlocked. So these were some quick access tools. We also have a different tool here, which is make layer current. So using this tool, you can make any of the layer current directly by selecting the object. For example, if you have a long list of layer, it becomes really difficult to find that layer in this layer drop down list. So let's say that we want to activate a particular layer simply by selecting the object from that layer. For that, we can select this option. So click on this make current and click on any of the object. For example, in this case, I'll click on this dimension, and as soon as I do that, the dimension layer will become the current layer. You can select it again, click on any other layer, for example text, and the text becomes current layer. Let's return back to layer 0 as the current layer. Now let's have a look at this last tool, which is this match layer tool. So using this tool, you can match the properties of one object on the destination layer. For example, in this case, we have this plan text. Let's say that we want to apply the properties of this layer on this plan text. For that, select it. Now select the text, press enter, and now select the destination layer. And here we have it. The properties of this destination layer are applied here. Similarly, you can do that for these arrows. So I'll select this lay match option, and I'll select all of these arrows. I'll select both of these arrows. Now press enter and select the destination layer. And here we have it. The properties of destination layer are applied here. You can repeat this process for these objects also. So once again, I'll select this lay match option, select all of these objects, press enter, and now apply it to this layer. And here we have it. So the properties of this layer are applied here. So not only the color, but also the line type, line weight, and all the other properties will also be applied on these layers. So this was all about some of the tools which are available on the layers panel, and these tools are really helpful in accessing the properties of layer properties manager without even opening that layer property manager or without even using the layer drop down menu. In this video, I will tell you about hide and isolate options of AutoCAD. So here we have the simple drawing. Now let's say that we want to work on certain parts of the drawing, and for that we need less crowded drawing. So in that case, you can hide some of these objects from your drawing area, and you can work on the parts which you require, and later on you can restore the visibility of those hidden parts. So obviously you can do that using layers, but that's a selective process which involves turning on and off certain layers. But if you don't want to involve layers, you can directly use the hide and isolate options to turn visibility of certain objects on and off. So I'll explain it using this drawing. So in this case, let's say that we want to hide all of these dimensions and also some of the extra annotations which are present in this drawing. So for that, I'll select the dimension first and then right click and select this option, select similar. So that will select all of these dimensions. Now I'll click on this ground level text, then right click, select the same option. It will select all the text, and I'll also select these objects from our drawing area. Now these are the objects that I want to hide. Now in order to hide them, simply right click anywhere, select this isolate option, and now select hide objects. Now the objects are hidden. Obviously the objects are not deleted. You can restore them back whenever required when the editing is done. So in this case, let's say that we want to add a new geometry here. So I'll go to the circle tool and I'll add a new circle here. Now we want to bring back all the objects. So for that, once again right click anywhere, go to the isolate option and select this option, end object isolation. And we have all the objects back in drawing area. Now if you want to work on certain objects and you want to retain them instead of hiding them, and you want to hide all of the other objects from your drawing area, you can do that as well. So in this case, let's say that we only want to work with this circle and with this line. Now rest of the objects we don't want here, we want to hide them. So select the objects that you want to retain, then right click, go to isolate and select isolate objects. So that will help you in retaining those objects, and rest of the objects will be hidden. Now let's erase the circle, and now we'll bring back all the objects. So simply right click, select the isolate option and select end object isolation, and all of these objects are back in the drawing area. Now you can do the same thing using the hide and isolate status bar option. So here we have this hide and isolate option. So you can click on this hide isolate option and select hide or isolate tool. But before using that, you need to make a selection. For example, let's say that we want to hide all of these dimensions. So I'll select the dimension, right click, and I'll select this option, select similar. That will select all the dimensions. Now go to this option, the isolate objects, and select hide objects, and they are now hidden. In order to bring it back, you can again go to the same status bar option and select this end object isolation. So click on it and the objects are back in the drawing area. So you can use any of these methods, either the right contextual menu or the status bar icon. That depends completely on your preference. So this was all about the hide and isolate options of AutoCAD. Okay, so here is your question related to this module. Here you need to create a circle with radius 5 unit, a square with side 5 unit length, and a triangle with edge length of 5 unit. Now make 3 corresponding layers, 3 layers with name radius, 3 layers with name circle, square, and triangle, and place these objects on the respective layers. Now assign a red color and ISO dash line type to layer which contains circle, and a line weight of 0.5 to the layer which contain square and triangle. So let's start with the geometries first. So I'll go to circle, click at a point and make a circle with 5 unit radius. There we have it. Now let's zoom out. Okay, let's go to rectangle, click at a point and make a rectangle with length 5 and a width of 5. So that will make a square. And now the third geometry, which will make with polygon. So select polygon. Now in number of sides, enter 3 and press enter. Now specify center, which should be anywhere. Now we need to specify the edge length. So click on this edge option and click at any point here and specify the edge length as 5 unit and press enter. So there we have it, all the 3 geometries. Now we need to make corresponding layers. For that, I'll go to Layer Properties Manager. Click on New and give it a name. So let's name it as Circle. Make second layer, name it as Square, and make third layer, name it as Triangle. Now we need to put these objects on the respective layer. For that, I'll close this Layer Properties Manager, select the circle, click on this drop down and select circle. Let's press escape. Now select the square, click on drop down and select square, and once again press escape. Now select the triangle, click on the drop down, select triangle and press escape. So now we have made the objects and we have assigned them on different layers. Now we need to change their properties, but using the Layer Properties Manager. So in the first case, we need to assign red color and ISO dash line type to layer containing circle. So go to Layer Properties Manager again, go to this circle layer and assign red color. So I'll click on color box, select red, click on OK. Now scroll it a little bit here. Here we have the line type, click on it and we don't have any line type here, so I'll click on load, and let's load ISO dash, which is here. Click on OK, select ISO dash, click on OK, and there we have it, AutoCAD ISO dash. That's loaded here. Now you can collapse this to see the effect, and there we have it. Let's now bring it back. Now I'll change the second and third properties, which are related to square and triangle layer. Now in this case we need to change the line weight to 0.5 for both of these layers. So here we have the line weight, click on it, change it to 0.5, and change it to 0.5 for this case, and there we have it. Now the properties are assigned. Let's get back to the drawing and let's see the effect. Now here in this case we have some problems. The scale of this line here in the case of circle is very large, that we need to change. So I'll type LT scale, that's for line type scale, and the scale factor is set to 1. Let's change it to 0.25 and press enter, and you can see that it will change the scale. In this case we are not changing the scale from the property panel, but we are changing it using LT scale command. So once again I'll type LT scale and I'll change it to 0.1, and that looks quite appropriate. So you can use this also to change the line type scale of all of the geometries which are present here in the drawing area. Now we need to ensure that the line weight is visible for both of these objects. So for that we simply need to turn on this line weight display, and there we have it, it's now visible. So here we have the final drawing as per the required layer assignments. So now we'll start adding annotations and dimensioning to our drawing, and I will begin this module with the dimensioning tools. So you can start dimensioning from the annotation panel of Home tab, and when you click on this drop down you'll see lots of tools which are available for dimensioning. Also we have this dimension tool which can be used for creating dimensions. Apart from that, we can also make dimensioning and other annotations from this annotate tab. So when you go to the annotate tab, you'll see many different panels like text, dimensions, center lines, leader lines, tables, markup, annotations. Now these are different panels which can be used for adding different kind of annotations, and here we have the dimensioning panel which we will use for this lesson. So I'll use this simple drawing and we'll add many dimensions to this drawing using the default ISO 25 dimension style, which can be seen here. We have this ISO 25 dimension style. We'll learn more about dimension style later on in this module, but first we'll start with this dimension style and we'll add some of the dimensions. So let's go to this drop down. I'll click here and you'll see lots of tools which are available for dimensioning. So I'll start with the linear dimension. So this linear option can be used to add horizontal or vertical dimensions. So let's click on this point and let's click on this point, and now click on the third point to place the dimension, and here we have it. So the dimension has been placed. So obviously for placing the linear dimension you need 3 inputs: the first point, second point, and the place where you'll put your dimension. There is also an alternate method of using this tool. So I'll select the same command and now directly I'll press enter. Now the point selection cursor will change into this pick box, and now instead of selecting the starting and end point you can simply click on the line and it will pick the dimension. Now you only need to click at a point to place the dimension. So you can use any of these methods. Now I told you that this linear dimension can be used to create only horizontal and vertical dimensions. So let's select it and let's try to add the dimensioning on the slant line. So I'll press enter, click on the slant line, and now you'll notice that we can make horizontal dimension if I move my cursor here, and we can make a vertical dimension if I move my cursor to this vertical direction. So you can choose any of these methods, but in order to make a dimension which is parallel to this slant line you need to select the second option. So I'll press escape, and now I'll go to the same drop down and select this aligned option. Now using this aligned option you can create that aligned dimension. So click at the first point, second point, and the point where you want to put the dimension, and here we have this aligned dimension. In this case also you can directly press enter and select the line for creating the dimension. Now let's look at the other option. So I'll go to this drop down, select the angular. So obviously using this tool you can add angles to lines or arcs. So I'll click on this first line, the second line, and now here we have the angle. Now this angle will be placed at the point where you click. So in this case, if I click here, the angle in between these two lines at this side will be created. If I move it to this side, the angle will be created here, even to this side or even to this side. So you can decide the side where you want to put this angle. So I'll click here, and now I'll repeat the angle tool, but this time instead of selecting two lines, I'll select an arc. So click on this arc, and now we have this included angle for an arc. So you can use this tool to create an angle for an arc also. So let's erase this angle for the arc, and now I'll go to the next tool. So click on the drop down, select this arc length. So this arc length is simply the length of arc. So I'll click on this arc and place it at point. So this is simply the arc length from this point to this point. It's not the radius, it's not even diameter of this arc. It's the arc length along the circumference of this arc. Let's go to the next tool, which is radius. So obviously using radius tool, you can create radius for the geometries which can have radius. For example, circle or arc. So I'll click on this circle, and here we have the radius. Now you can select the same tool, click on the arc, and it will also have radius like this, so you can create it. Similarly, you can select this diameter option, and in this case, instead of this R, a phi sign will be added. So I'll click on the circle, and here we have it, the diameter. Now in this case, you can see that this phi sign, which indicates the diameter, will be added. If you press enter to repeat the command and select the arc, this time we have the diameter for this arc with the diameter sign. Now we have quite a crowded drawing, so I'll remove some of these dimensions to free some space here. And now let's look at other options. So I'll click on this drop down again, and here we have this jogged dimension. So this jogged dimension can be used to add radius to different geometries like circle or arc, and it will be added along with a jogged line. So let's select this arc for instance, and now I'll specify the center location. The center location of this arc is here. So click somewhere over here. It should not necessarily be on the center. I'll simply click here, and now we have this jog line. If you look at closely, you'll find that. So click at the first point to place the first jog line and the second point, and here we have this jog line. So these jog lines are generally used where the curvature of arc is very large and the center of that arc falls outside the current drawing area. For those cases, you can use this jogged line. For now, I'll simply erase it. And now let's look at the last option, which is ordinate. So I'll click on this drop down, and here we have this ordinate option. So using this ordinate option, you can enter x or y coordinates of any point. So I'll select this rightmost point, the bottom right point, and now in order to add the x or y coordinate value, simply click here and now move your cursor. So as you can see that this line is moving along the x-axis and it's completely horizontal. That means this will be the axis of y. Now click here. Now click on this point again, but this time I am moving it in downward direction, and now it's following the point along the vertical axis, and that is the x coordinate. So it might be a little bit confusing to you at this point, but we'll use another example later on in this module to make this ordinate dimensioning more clear. For now, you can assume that this is the y coordinate value and this is the x coordinate value. So up to this point, we have seen that all of these dimensions are made on the default layer, which was currently active, and you can see that in this list also. The drop down, it shows use current for the layer. So whatever the current layer is, that will be used for all of these dimensions, but you can select your own layer as well for the dimensions. So I'll click on this drop down, and now I'll select some other layer. So in this case, let's select this layer 1. And now the dimensions will be made on that layer. So I'll go to this drop down once again, and I'll select radius. Now click here and make a radius, and you can see that it's now made on layer 1, and the properties of layer 1 are also inherited here. Similarly, you can switch to any other layer, and when you make the dimension, let's select diameter in this case, the dimension will be made on that layer. Even now the layer will not change. When you go to home tab, you'll find that still we have this layer 0 as the currently active layer, but still the dimensions will be made on the layer which we select. You can even select the dimensioning from this annotation panel. So even if you select it from here, the dimensions will be added on the layer which you assigned on this annotate tab dimensions panel. So since we have assigned the layer 2, the dimension will be made on layer 2 irrespective of the current layer. So that was all about creating simple and basic dimensions in AutoCAD. In the previous lesson, we have used many different dimensioning tools to add dimensions on this drawing, but there is a direct tool also which can be used to add all of those dimensions in your drawing, and that is dim command. So you'll find that tool or command on the annotation panel, and it is this big dimension tool. On the annotate tab dimensions panel, you'll find dim command here. So you can use the command dim, or you can use this tool here from the dimensions panel or from home tab annotation panel. So I'll go to this annotate tab and I'll select it from this dimension panel, and now I'll use this tool to add almost all of those dimensions. So click here, and now we'll start with the linear dimension. So first I'll click on the first point here, then the second point, and now I'll click here to place the dimension. So obviously the first dimension has been placed. Now similarly, if you directly go to the line instead of selecting the points, you can see that now again we have the same linear dimension. Now if you want to place a aligned dimension on this kind of dimensioning, simply click here and place the dimension. Obviously you can also create linear dimension, so for that simply click on the first point, click on the second point, and now press and hold shift key, and you'll notice that your dimension will change into linear dimensions. In this case, since I'm moving my cursor in this vertical direction, it's making this vertical, and if I move it downwards, it will make this simple horizontal dimension. So you can select any of these dimensions simply by pressing the shift key. So I'll click here and we have this horizontal dimension also. Now I'll press escape key and I'll remove some of these dimensionings. Now let's go to this tool again, and this time I'll go to this circle, and now as you can see that we have this diameter, so we can add the diameter. Obviously we can add a radius also, so I'll once again go to the circle, and now look at the command line. So when this dimension is on the circle, you'll notice that the command line has more options, which is radius, jogged, and angular. So let's select R and press enter. Now the dimensioning will change into a radius. So now click on the circle and we can add a radius here instead of a diameter. Similarly, you can do that for this arc also. So here we have this radius. You can change it to diameter simply by pressing D and pressing enter. Now if you want to add arc length instead of radius or diameter, all you need to do is type L, and if you look on the command line, you'll notice that L has been highlighted in this arc length option. That's why we need to enter L. Now type L, press enter, and now instead of radius or diameter, we have this arc length here. Now let's look at the next option, which was angular, and to add angular dimensions you simply need to select this angular option, or you can also type A and press enter for this angular option. Now you need to select the vertices. So click on this line and click on this line, and here we have it. So the 90-degree angle has been added on this vertex. You can even select more vertices if you want. So I'll simply click on this line, and as you can see that we are now making this horizontal dimension, but that hardly matters. Simply go to the second line and click, and that dimension will change into this angular dimension. Now in case you want to add the jog dimension, which we have added in the previous case, once again go to this arc and now select J from the keyboard and press enter. So that will start the jog dimension. Now click on this arc and specify the center point. So I'll specify the center location override somewhere over here, and obviously the jog distance here. So I'll zoom into this area, and this is the jog length, which is quite small in this case, and here we have it, the jogged dimension. Now in order to add the ordinate dimension, you need to select that option from the command line, which we can see here. We have this ordinate option, so select the ordinate option and now click on the first point. So obviously in this case, if you follow this x-axis, so that will make the y coordinate, and I'll explain this logic later on in the upcoming videos. So click here and That's obviously the y value of the coordinate. Now click on this point again and now follow this y axis, and this will make the x coordinate value. So the x coordinate value of this point is 192.23 and the y coordinate value is 99.67. Now let's verify this result. So I'll press escape twice. Now I'll type id, press enter, and now click on this point. And now look at the command line. So we have x as 192, which is here 192.23, and when you expand the command line you can see the results, and the y value as 99.67, which is here 99.67. so that's the result. So let's collapse this command line. So this was all about the dim command, which can be efficiently used to increase your productivity. So now we have made the dimensions in our drawing. Let's modify these dimensions. But before that, let's have a look at a new layer which is always created when you make a new dimension, and that layer is def point. So when you click on this layer drop down, you'll notice this def points layer. So this is the definition points layer, short for def points, which is always created whenever a dimension is added, and it stores all the definition points of your dimensions. It is always recommended to keep this definition points layer. You should not delete it, and if you try to delete this definition points layer from the layer properties manager, it won't be deleted, but obviously you can use ladle tool to delete it. But if you delete this def points layer, the drawing may start to show some errors. Also, the def points layer is on a no plot layer. That means the contents of this def points layer will not appear when you print your drawing. So most people use this property of def points layer to place objects which they don't want to show in the plot. But I would not recommend that. You can create a new layer and put all of the objects on that, and you can turn off the plot for that layer. Now moving on, here we have this drawing with some of the dimensions. Now this dimension is basically divided into three parts. Now the first part here, let's look at this dimension. I'll zoom here. Now the first part is the dimension line, which is this line with these arrowheads at the end. So that's called the dimension line. Now we have the extension line, which are these two lines. So this one is the extension line and this one is the extension line. You can see that by default the extension lines start from the point where we clicked, but a small gap is maintained. So that is done to keep the dimensions legible so that the dimensions can be easily identified from the drawing. Also, the third part is dimension text, which is here. Now we can modify all of these parameters of the dimension separately, and I'll start with this dimension here. So let's click on this dimension and now move on to this grip and hold your cursor, don't click. You'll see plenty of options here. Let's start with the stretch option. So click on this stretch and now you'll be able to stretch this dimension simply wherever you want. Similarly, when you hold your cursor there, select move with dimension line, it will have a similar effect on your dimensioning. Now go to this grip and now select move text only, and obviously in this case the text will move, but your dimension line and extension line will remain unaffected. So let's click here and here we have it. Now let's go to the same grip and now select move with leader line, and a new leader line will be added with its trailing end on the dimension line, just like this. So let's go to this again and let's select move above dim line, and it will take your dimension above dimension line no matter where the position of this text is. Let's go here and now select center vertically. We have it here. It's now centered vertically on the dimension line, and now let's select the last option, which will reset its position to the default value, just like this. There are also plenty of options which are associated with different grips. For example, in this case we have this diameter now selected, and let's select this grip. Now in this grip we have only these two options, the stretch and flip arrow. We have already seen the stretch, by which you can stretch the grip point, and using flip arrow you can change the direction of this arrow. So I'll go to this grip and select flip arrow. Now in this case the dimension line has this flipped arrow. You can do the same for this side as well. So I'll flip the arrow and here we have it. So now this flipping of arrow can be used at crowded places where the arrow might be overlapping with the parts of the drawing, or if there is not enough space for the dimension text. In that case you can flip the arrow to generate room for the dimension text. The dimensions which we are adding here is associative, and that simply means that the dimension is always related with its parent geometry, and when the parent geometry changes, the dimension updates itself. Now to explain this, I'll change some of the geometries in this drawing. So I'll start with this circle. Now click here, and using these grips, let's click on this quadrant and change its radius. So as you can see that the current radius is 15.77 units. I'll just decrease its value, and look at the radius, it's now changed to 10.11. So in this case the dimension was associative, and that's why it has changed. Now let's do the same for this side. In this case you can see that the length of this side is 60.66 units. Now let's select this stretch tool, and I'll stretch this side of the geometry here. Now press enter, and I'll click here, and as I stretch you'll notice that the dimension is also changing because it is associative dimension. Let's click here, and here we have the changed dimension. So as long as your dimension is associative, it will change along with the geometry, but you can break this associativity simply by moving this grip. So if I move my grip from this point to somewhere over here, it will no longer remain associative. And now if I stretch my geometry, I'll click here, and now I'll stretch it. You'll notice that it will not change the dimension, as we have already broken the associativity of this point with this end point. You can again make it associative by simply selecting the grip and moving it to this end point. Now it's once again associative, and if you select the stretch tool, the dimension will once again change along with that. So this was all about modifying the dimensions in AutoCAD drawing. Up to this point we have used the default dimension style to create our dimension. So now we will learn about creating our own dimension style, and we'll create dimension using that dimension style. So for that I'll go to this annotate tab, and now I'll click on this drop down. So when you click on this drop down, you'll notice that we have this ISO 25 and also this annotative dimension style. So these two are the default dimension style which will always be present in your drawing. Now in order to create a new dimension style, click on this manage dimension styles. Now this dimension style manager window will pop up, and it will have the two dimension styles which we have already seen. So when you switch between these two dimension styles, you'll see its preview in this preview box. We'll learn more about this annotative feature later on, but for now I'll select this ISO 25 dimension style, and now let's click on new to create our new dimension style. So when you click on this new by selecting the ISO 25 dimension styles, it will create a new dimension style which is a complete replica or a copy of this ISO 25 dimension style, and we can later on modify that dimension style. So I'll click on new and now give it a name. So let's name it as our dim style, and obviously we want it to start with ISO 25, and that means we need to copy its dimension style, and we don't want it to be annotative, so I'll keep this unchecked. Now click on continue, and we are now into this new dimension style window. Now we have lots of tabs here. So this lines, symbols and arrow, text, fit, primary, alternate, units, tolerances, and all of these tabs can be used to modify different features of the dimension and extension lines. So we'll focus on some of the very frequently used tools of the dimension style, and later on in the upcoming videos we'll obviously look at some of the advanced features of this dimension style. So currently the default dimension style looks like this, and we have used this dimension style to make all of our dimensions so far. Now in order to change the properties of lines, the dimension line and the extension line, you need to use the first tab. Now when you go to this lines tab, you'll see this dimensions line panel, and in this panel all the settings which are related to this dimension line, all of these straight dimension lines can be changed. So the first property is color. Let's change it to red, and you can see that the dimension line color has been changed. Also you can change the line type, you can change the line weight of this red dimension line, and in a similar way we have some options here for extension line. So these are the extension lines, so you can change its color to green just to identify it clearly from the dimension line. You can obviously change the line type for first extension line, the second extension line, and the line weight. If you want, you can suppress or remove the extension lines by clicking on these check boxes. And there are also plenty of options which can be changed depending upon the requirement. Now let's move on to symbols and arrows, and here you will see lots of options. For example, the arrowhead. So first we have this close filled arrowhead, but if you want, you can change into any of these arrowheads. So I'll select this architectural tick, and the arrowhead now changed. You'll also notice that with the change of this first arrowhead, the second will automatically change. But if you change the second arrowhead, it will not change the first one. Now we have these two different arrowheads, which is obviously very bad practice. So you should keep both of them as same arrowheads. Also, you can change the arrowhead type of leader line, or you can change the size of these arrows. You can also select between center marks. So right now a center mark will be placed at the center of these kind of geometries, and the size of center mark is specified as 2.5. If you want to add line instead of center mark, you can do that, or you can select none if you don't want any center mark. So I'll keep it at center mark. Also, we have the arc length symbol. If you want it, keep the first or second radio button checked. In this case, the arc length will precede the text. In this case, it will be above the text. And if you don't want the arc length symbol, simply select the none radio button. So the arc length symbol will only appear when you create an arc length. Now let's go to this text option, and obviously in this case you can change the properties of this dimension text everywhere here. Now we have the text style, which is a standard, and we'll learn more about these text style in the next module. For now, I'll just go to this text color and I'll change it to yellow. You can also change the fill color or the background color of this text. Let's change it to cyan, and here we have it, the background color for the text. You can change the text height, and you can even draw a frame around the text. So for the sake of simplicity, I'll change the background color and I'll change it to none. We don't want any background color. Also, I'll remove this frame around our text. Now you can see that our text is placed above the dimension line, and it can be seen clearly for this dimension here. It is placed above dimension line. Also in this case, it is above and above. Now if you want it to be centered, or if you want it below, you can change it from these values. Now I've selected centered, and here we have it, it's now centered. Also, for this horizontal text, you can select the option from here and the view direction, left to right, or whatever the direction which you want. Now in this case, the text is always aligned with the dimension line. So if the dimension is aligned, the text will be aligned. In this case, it is completely vertical, so the text is also vertical. But if you want the text to remain horizontal in all of the cases, then select the horizontal option and the text will become horizontal in all of these cases. You can also select the ISO standard value, and whatever the ISO standard follows will be applied here. So I'll select horizontal as I use in most of the cases. And now let's move on to the fit tab, and in this case we will look at two important options. The first one is annotative. So if you want to make a dimension style annotative, select this annotative checkbox, and if you want to change the overall scale of dimension, including the dimension arrows, text, the gap, and all of these parameters, you can simply add a scale. In this case, I've used an overall scale of 1. That's the default value, and I'll not change it, but we'll create a new dimension style and we'll change the overall scale to explain it clearly. For now, I'll simply click OK with these changes and I'll close it. So now we will make our dimensions, but before that, make sure that our dim style is selected. Now this is the dimension style which we created and it should be selected. Now I'll go to the straight dimension, the linear dimension, and I'll add it here, and here we have it. The dimension will be added with the properties which we have applied. Even if you apply some other dimension like radius, it will take the same properties. And as you know that we have selected this horizontal placement for the text, it has been applied. Also the architectural tick is here. Now there are some parameters here in this dimension style which we have not yet changed. For example, the number of decimal points and also the decimal separator, which is comma in this case. So let's change these values, but for that I'll create a new dimension style. So I'll click on this drop down and I'll select manage dimension styles. So we already have this our dim style. I'll create a copy